Hello everyone. I welcome you all to the live session on Cloud Computing Full Course by Intellipaat. But before we begin the session, make sure to subscribe to our channel and also hit on the bell icon so that you will never miss an update from us. Now let's see the agenda of the day. Firstly, we will begin with Introduction to Cloud Computing. Post that, we will tell you how to make a career in cloud computing. Then later on, we will move on to AWS and its basic concepts. After that, we will be explaining you different services provided by AWS like EC2, ELB, DynamoDB, VPC, Lambda and lot more. After that, we will introduce you to GCP and its basic concepts. Then finally, we have covered cloud computing interview questions and answers. So guys, this session is going to be very interesting. So stay tuned and watch the video till the end.
Cloud is basically a commoditized service model. The objective of cloud was to basically transform the computing into the commodity, right? So commodity, like if you say in other terms, that another major objective of the cloud computing is to offer the computing services as the utilities, right? If you take the better example, this utility services, same as you get water, electricity, gas, and telephone services, right? It means the service you are using, or you can say what service you are using, you are paying only for that, right? Similarly, you have a electricity meter at your homes, you are consuming 2 units, 4 units, 5 units, 500, whatever as per requirements, you are only paying for that. This was the biggest revolution in the computing paradigm, that cloud computing is changing the phenomena of the computing, right? So cloud computing is basically introduces the concept of utility, right? It is not only the cloud computing, we have on the backend like grid computing, right? So I will let you know what is the grid computing. So first understand what the concept of utility computing. In the utility computing, we do not offer any hardware kind of services to any user. We just offer the virtual services, and we just charge only for what the user is just consuming that particular services, right? So it was not the new concept in the cloud computing. It was just driven from the grid computing. That we will go in the further, our sessions, then you will be realize that it is on the top of the grid computing. So let me give you, very good idea for the grid computing so that you can understand in better way, right? So let me use some, whiteboard to explain in a better way what is grid computing. However, we have a rest of contents later on. So understand what is the fundamental concept of the grid computing that was introduced especially in the India. What happened previously? We have top tier institutions or top tier research, you can say research institution in India, right? For example, let's say one is the IIT, right? Let's say one is the IIT organization, and then we have IISc, right? And then we have top tier central universities, right? So these organizations have a set of compute intensive servers, right? They have huge number of servers, right? What about some other organizations, for example, IIITs, NITs, and you can say some state universities, or you can say some of the other central universities, they do not have any kind of such high performance computing infrastructure, right? However, that peoples in all the organizations are doing some research activities. For example, high performance computing research, or you can say biological based DNA computing research, and scientific applications computing research. So these peoples are running a lot of, you can say, they are facing a lot of problems in accessing the high-end computing services because they do not have infrastructure, and it was harming their research. And as a developing countries, that our government does not have enough fund to offer all the institutions to provide such kind of infrastructure. So for that purpose, one of the another organization that's called CDEC in our India, this is also having a good infrastructure in terms of, you can say, computing services, or you can say computing resources. So what was the idea? That all the you can say all the organizations, they started to share their resources to a particular network, right? And this network was referred as the grid, right? And with the help of this grid, all the organizations like other state universities, you can say central universities, or you can say even other IITs as well, right? Whosoever is participating, now everyone is able to access all the resources. So it becomes a kind of a central portal through which any of the user from any of the organization who is being registered, that particular, you can say, network of grid resources that can access those, services, right? So it was, very interesting, you can say, paradigm, serve the, organizations or premises, those who were running, you can say, lack of computing infrastructure, right? So this was, grid computing. So in detail, I will talk about the grid computing, but right now I think it is enough to make it clear what is grid computing, right? So this was the grid computing again has had a particular vision to offer the computing services as the utilities, right? So this was the, one of the, understanding about the utility services. So in this, the people did not get actual hardware. They used to get only that particular resources what they want, right? So it means they used to get as the utility services. Okay. So you can say it is a promising paradigm to turn the vision of computing utilities into the reality, right? So it was not a new concept, it was a long-term vision of the scientists or philosophers that we will be studying some of the statement that some of the philosophers predicted in very early age when computer was introduced that day will be coming that computing infrastructure will be introduced as the utility services, right? And an interesting thing in the cloud computing is dynamic provisioning, right? Dynamic provisioning basically arranges all the resources as per the requirement of the user during the runtime, right? So it basically dynamically provisions all the resources. Resources are basically compute, it means CPUs and storage like hard drives, networking resources such as switches and bridges or routers and IT infrastructures, right? Some of the applications as well. So it was, very interesting in the cloud computing. Whatever requirement you require in the dynamic in the during the run or during the, you can say, execution of your application, at the time it can manage the resources, right? So it means you are not you are free from the boundary of that availability of the resources, right? You just focus on a problem, what you are going to do, just solve it. You forget about what infrastructure you require. That will be offered by the cloud during the run, right? And resources are accessible via internet and offered on peer basis, right? So that we have already discussed about it. Without internet, you guys cannot access the resources, right? So there are some other queries. Do we have any standard or some protocol using which service providers have to offer the cloud services, which will make the shift from one provider to other easy, right? See, nowadays it's very open because it's totally internet based computing paradigm. So you guys can search over the Google. Do we have any standard or some protocol using which service providers have to offer the cloud services? See, there are always a set of standard protocols, right? See, how you're just accessing, you are not worry about those protocols, how you're getting the access of the internet. The same protocols are used to access the cloud services, right? All the protocols included in the access the networking services, those protocols are being used. However, if you go for the specialized or highly secure services, then some protocols will be explicitly added during your services, right? For example, you want to secure services, then VPN will be there, right? So that is, depends on the service provider and user requirements, right? See, grid will be overlaid if your requirements are going to be very high, right? When number of users are increasing very high. So therefore, we have always an option of the registration, right? We allow the customers or users only as per our capacity. See, there is a resource metering facilities there. Based on that, you can analyze what percentage of all the resources are being utilized over that particular network of grid, right? So based on that, you can allow users to register more or you can stop them out, right? However, I will let you know that it must be knowing you that we are always, you can say, we are not able to utilize in most of the applications CPU to 100% utilized. That's why when we share a particular resource among the multiple, you can say, users, so that it is being efficiently utilized. So when multiple, you can say, premises are sharing a particular network, right? So then these premises basically having a lot of resources. So it is always assumption that not all the premises are using the resources 100%. That's why we are allowing to other users. Otherwise, why we need to create a grid, right? So it is assumption that we have a lot of resources, right? If sometime it is being overloaded, then we have a concept of the waiting queue. So people, or you can say users will be waiting in the queue once other people will be finishing and then their job will be submitted to the server, right? And what kind of connectivity do we have between grid and the edge locations? See, what kind of connectivity nowadays, every kind of connectivity is allowed for all kind of communications. But the major issues comes about the latency, right? It depends on our application, how much latency you can bear with that. If it is a real-time application, then we have another way of, computation that's called edge computing or fog computing infrastructure, right? But in the grid computing, it was becoming fail to offer the real-time services. That's why cloud computing came. Now, cloud computing is also becoming a fail to offer highly latency-sensitive applications as the effective services. Third is what kind of connectivity. See, what is the difference between utility computing and grid computing? See, grid computing is the complete paradigm to offer computing services, and utility computing is a kind of a one, you can say, service model that is adopted by the grid computing. So see, let's read out some of the, you can say, some of the, statement. Those are predicted very early when our computing system was in infancy state, right? Or it was in just evolving state. So you can see Leonard predicted 1969. As of now, computer networks are still in their infancy, but as they grow up and become sophisticated, we will probably see the spread of computer utilities, which like present electric and telephone utilities, right? So similarly, that you will be realizing it is not a new concept, right? It was just I mentioned that it was predicted in very early, age, right? So similarly, you can see another, most of the, diffusive view of the, cloud computing. That one person says that cloud computing is what. So one say, and you can say how this cloud computing came into the picture. So one of the person was having a certain requirement that it says, I don't care where my servers are and who manages them and where my documents are stored or where my applications are hosted. I just want them always available and access them from my device connected through the internet. And I am willing to pay for the service for as long as I need it. Right? So you can say it is not the possible without the cloud or before the cloud. So I can give you a better example for this particular scenario. In 2010, one of the professor from University of you can say Melbourne, that is Professor Rajkumar Bhuiya, came to one of my institution to deliver a talk after 2010. So at the time, we do not have the concept of Google Drive, right? So this person forgot, his charger or you can say adapter of, you can say Mac laptop, right? And it was not available in our campus. So his talk was not able to deliver because his laptop battery was, you can say, not responding at that time. So you can say this was the one of the biggest drawback of the classical computing phenomena without this cloud computing, right? So his talk got delayed 2 hours. One person went to his hotel where he was stayed, then came up with adapter and audience waited for the 2 hours, right? So now you can understand when cloud computing came into the picture, right? So you can see Google Drive is the best example of the cloud that you can realize, right? Nowadays people are not taking any risk to getting all the PPTs in their laptop. Now people before going to the talk, they try to put their PPTs or slides over the Google Drive and they start their talk without worrying about whether my laptop is functioning or not. They can use others' device or they can start their presentation, right? So I hope this way you can understand the role of cloud computing. So here you can see another interesting thing about the cloud computing, that Web 2.0 technology makes cloud computing an attractive opportunity for building computing systems. So here one important term is, Web 2.0. So Web 2.0 is what? Initially, before the cloud computing, or because before 2002, we were having only Wave 1.0. So just understand what is difference between Wave 1.0 and Wave 2.0 and Wave 3.0. So we will be having detailed discussion. Just I am going to discriminate between Wave 1.0 and Wave 2.0. So Wave 2.0 was one of the technologies which plays a great role to attract the users towards the internet, right? Not the cloud. It has played a role to attract the users towards the internet, right? How before the Wave 2.0, we used to deal with the 1.0, in which we are able to just simply do mails and just read the Wikipedia and just are able to you can say we have a lack of interface, or we are dealing most of the command line kind of computations. We have a lack of GUI and we have a lack of application over the internet, right? So when Wave 2.0 basically came in after 2000 approx, then it becomes enriched in terms of lot of application over the internet, right? Even you guys can get a better example of this Google Drive. That is possible due to the Wave 2.0, right? So it means Wave 2.0 basically creates a storage over the web. You can say creates a lot of space for the applications over the web itself. So that's how some applications nowadays you can find over the web. Suppose you want to perform photo editing task, right? Before the Wave 2.0, you guys has to download a tool of photo editing. Then you have to install. Sometime it is asking for the license or some major issues, right? So people were getting very, paid job. Nowadays, you guys can just go. I want to edit my document. I want to signature. I want to edit my photo, whatever. So no need to install anything. Everything is available over the web, right? So now you can edit your photo. You can do any kind of stuff. So it is just because of the Wave 2.0. So Wave 2.0 is just enriching your web in terms of service delivery platforms, applications, and ready-made applications as well, right? So that is basically meeting the users' requirements. So which is attracting the users towards the internet, right? I hope you must be understanding the vision of you can say Web 2.0. First, we are making the users habitual towards the internet. Then we are switching to the basically our cloud computing technologies, right? Until unless users are not becoming habitual towards the internet, our cloud computing cannot be accessed by the users, right? So here you can say that cloud is basically offers the users more abstracted, you can say, applications, right? So in that way, users are not worried about what is going on in the backend. They are getting just a good front end, how VM is being created. They are not worried about just you write your configuration over the particular service provider site, or just you will get a VM, right? So it is very abstracted form. Until when you talk about to installing virtual machine or a machine, you have to download the hypervisor. Then you have to give a particular memory allocation, CPU allocation for a particular VM. Then you can go for the installation. Then you have to again restart kind of things, right? So there is a lot of headaches. But in the case of you can say cloud, you got only the abstracted view, right? And important thing about cloud, that's basically called virtualization, right? So virtualization is very important, or you can say backbone for this cloud computing paradigm. So virtualization basically offers you to customization and control, and offers a lot of flexibility for the users to offer the services, right? So I will tell you with the help of example. This term is coming about virtualization. So because in the cloud computing, the virtualization is the core technology, right? So understand what is this virtualization. So let me take one example. Just I will not go typical definition right now. Just I want to tell you so you will get some idea about the virtualization, right? So suppose you guys have multiple resources. Okay, that means CPU. So let's say you have one CPU. Let's say we have one CPU that is having 4 core processor, 4 core, that means C4 core, and let's say 4 GB, let's say memory, right? And let's say 1 TB hard disk, right? And similarly, let's say you have another device that is called that means you have right now 8-core CPU, and let's say 16 GB memory, and let's say 2 TB hard drive, right? And let's say you have another CPU that is having, let's say, 2-core CPU, right? And let's say 1 TB hard drive, and let's say 2 GB RAM, right? So what basically virtualization does? What is all about virtualization? So virtualization try to create a pool of all those resources, right? So basically in pooling, what happens? It basically collect CPU as a another component. So it will create a now one component as the CPU, that's called CPU, and another component as the memory, or you can say pool of, you can say, memory, and another can be one pool for the hard drives, right? So let me take a different symbol for the hard drives, right? So what happens with the help of virtualization, you can collect, I mean, all those things into the one particular pool. It becomes 4, 8C, and let's say 20, 2 cores, right? Similarly, you can collect, I mean, memory. It becomes 4 GB, and it can be 16 GB as well here. It can be, let's say, 2 GB. Similarly, you can have, I mean, one here hard drives. So it can be, let's say, 1 TB, or you can say 2 TB and 1 TB, right? So this is the, I mean, job of your virtualization. So virtualization creates a pool of those resources. When you put a virtualization layer here, that can be any hypervisor. So right now you don't go for the typical what is hypervisor, but we will go to that content that we will discuss about it, right? So it is basically virtualization, right? Just understand this is virtualization layer. So we have some software. So the software is doing this job. So right now, whatever users are coming here, so here users are coming. So now users are requesting to this particular layer, right? Whatever they want, services will be offered to the users from these pools, not from this, I mean, particular, physical infrastructure. So services will be offered from this pool only, right? So because of this, let's say one user wants now, I want 12-core CPU, or I want 12-core CPU machine, right? So here, with the help of this virtualization, you do not have a 12-core machine. This, with the help of this virtualization, you are able to offer 12-core machine to a particular user, right? Similarly, you do not have a, or you can say 20 GB RAM, but with the help of this virtualization, you are able to offer 20 GB, let's say, a particular RAM to a particular user, right? Similarly, you can also customize the hard drive, right? So this is the, I mean, advantage of the virtualization, and this is the all about of the virtualization, right? And typical definition we will go later on. So this virtualization is giving very important property that is called elasticity, or basically it can also shrink. Like suppose you do not have a 1 GB RAM, you can also offer the 1 GB RAM, right? You do not have a 1-core CPU, you can also offer the 1-core CPU, right? So this is, I mean, all about your, I mean, virtualization. I hope this virtualization is now clear for all of you. So here you can see this is the all, I mean, becomes very interesting to serve to the users because of the dynamic resource provisioning, right? That I have already discussed about it. So with the help of dynamic resource provisioning, you are able to manage this infrastructure to the user based on its requirement. So if you see that long-term vision of the, I mean, this cloud computing, that cloud computing is basically wants to offer these services as the utility without any kind of technological as well as legal barriers, right? So technological means I'm using now 4 GB, now I want 8 GB RAM. I do not want such kind of excuses. I have a 4 GB, you can say, resources, and now I want 8 GB. So such kind of technical barriers we don't want, right? And legal barriers means who is basically providing your services, who can access your files, who cannot access your files, and some of the IT laws. That is, I mean, consideration in the cloud services, right? So some of the research are going for this by legal barriers. It's, I mean, very important, very critical issues, right? So cloud computing is basically coming up to all the, I mean, solutions, whatever users want. right? And ubiquitous storage and computing power on demand, right? It means you can access the resources around the globe. So best example of ubiquitous storage is the Google Drive, right? And computing power on demands, it is just you can go for the, you can say just I have given you go for the virtual machine from the AWS. Becomes the best example, right? Nowadays, let's say you are having one application that is requiring 4 virtual machines. Tomorrow you suddenly got a heavy loaded application. Now you want 8 virtual machines, so that can be automatically dynamically provisioned by the service provider, right? So that was the long-term vision of the cloud computing, right? And accessibility and availability of low-cost services to poor infrastructure client. So it is very beneficial for basically the people which are basically working kind of a startup, right? So startup people do not have a good amount of fund. They are because early stages. So those people want such kind of, let's say, GPU-based computing, high-end computing, and they have a 10 lakh project. Now they have to purchase 20 lakh server. This is not possible, right? So they can buy, they can get rental services from the service providers, and they can access that. So it is, cloud, very beneficial for the low infrastructure clients, right? And web-based access to documents and processing, so that you must be knowing. It's a good example of again Google Docs, or as well as you can create your own local, you can say secure storage services, right? And basically, cloud is also satisfying users' needs in the global market. You can say global digital market with a set of few important advantages, right? So one important advantage is service providers are becoming visible and more revenue, right? How? Because it is digital market, right? So everything is available over the internet. So the client who want to access it, that can search and that can easily access. There's no hardened there is no need any hardcore reference to those particular services, and it reduces the barriers of between service providers and service consumer. So see, at the one time, service provider can also be a consumer, and consumer can also be service providers. It depends to from one you can say one class of customers to the other class of customers, right? Suppose nowadays you are running with a big let's say a company. Now you want let's say hundreds of data centers to run your industry, and suddenly what happens, you do not get any project, right? And now you have already taken a subscription for a 1 month of 100 VM. So what you can do, you can hand over to those VMs or those data centers to the low compute required clients, right? So here you can become a service provider to the other clients. However, you are taking services from the other, you can say, service provider. So this can be true in the vice versa, right? And most important thing is about the cloud computing, or you can say about the long-term vision of the cloud computing is to offer low cost and high revenue or greener IT solutions to the clients, right? So how it is possible? It's very interesting concept. How this low cost solution is possible, okay? And how this cloud is basically offering the low cost solution, and how it is generating high revenue, and how it is offering the greener solution. So you guys have to think about it, you can say a bit, you can say technically, right? What happens, as I told you previously, if you have a one particular, let's say, data center, and you have one server, let's say you are one of the organization, or you can say one of the user, you are having now ICV processor, and you are just watching movie, or you are just not always watching movie, you are doing some kind of document editing, some kind of code writing work. So you guys can try it, you guys can analyze this. At most 20 to 30% you are utilizing your CPU on average, right? And what happened if you send this device to the our as a cloud service? So it means it will be shared among the multiple users, right? So this device, one device, you can say three different peoples are utilizing the same device 20%, 30%. Now three peoples can utilize only one device that can go to up to 90%. And performance will not be degraded that much. However, there will be certain degradation in the performance, but it is acceptable, right? So this is what, instead of using the three CPUs, one CPU is being used by the three people, right? And in that way, you are saving what? You are saving the cost of two CPUs. You are saving the cost of electricity that is being consumed to CPU. You are saving the cost of basically cost of two air conditioner, right? So this is what it is leading to the low cost and high revenue, right? Now another question comes, how it is offering greener IT solution. Greener means it is offering low consumption. So one of the example I have given to you, that instead of two CPUs, three CPUs, we are making turn on with one CPU and two CPUs are basically turned on. So in that case, we are not consuming a higher electricity and we are not emitting huge amount of carbons. So it is contributing to our environment. So it is the greener IT. But now another question is coming. Suppose three different peoples are working in the three different CPUs. How they can be merged to one, right? So for that purpose, cloud offers what concept is called server consolidation, right? So with the help of server consolidation, three CPUs can go to, I mean, one particular, you can say, those can be shifted to one particular CPU. To see that global cloud marketplace, right? So first understand how this cloud computing basically came into the, I mean, existence, or you can say how this technology come at that particular level, right? So see, for any technology, the first important thing, or for any business, whatever you are guys doing, or maybe in companies, you must be realizing that for any of the business, customers are, you can say, very necessary, right? And we require two things. One should be the service provider, and one should be the service client, or even service accepting client, right? So that once these requirements are going to map to a particular platform, then your business, or you can say your technology, will definitely go to the moon. So this one, or you can say few smart people identify some few things in this global market. What was those two things? They identify the two verticals. One vertical is this set of, I mean, peoples. This is, I mean, one vertical. This becomes the another vertical, right? So one vertical is the, I mean, set of peoples. Those are having access of the resources, and one set of peoples, or you can say, in the one vertical, the set of peoples, those are having requirement of the resources. So cloud computing is doing basically nothing. It is just taking the both the, I mean, kind of users or both the verticals to the common platform. So now you can read it out, some of the text. One person is saying, I'm having a lot of infrastructure that I want to rent on. And another person is saying, I need to grow my infrastructure, but I do not know how, for how long. So he cannot buy the resources, right? So he can take the rent. He can take those resources on the rent, right? Similarly, you can see one person saying, I have a surplus of infrastructure that I want to make use of them. One person saying, I cannot invest in infrastructure, just I shared my business, right? So that kind of requirements are coming here. So one and two are coming to one particular platform, right? So cloud computing is just nothing. It is just doing, or it is coming with both kind of verticals to a one particular platform. But more than this, I mean, carrying the two different kind of verticals to one particular platform, there are certain challenges that are also being taken care by the, I mean, cloud service providers. That is what that's called, I mean, quality of service parameters. So quality of service parameter means how good you are going to offer the services. Suppose if one person is giving their resources to you, right, and that person is just stealing your data from your device, and who will be responsible for that? So this is again one of the quality of service parameter. There should be a trust and privacy among them, right? So that we will discuss about it. And one can be money, one can be energy, right? One, we have to take care of the environment if you're increasing a lot amount of computational infrastructure, and what about, I mean, carbon emission kind of things, right? So this quality of service parameters are taken by the cloud. So for that purpose, cloud, you can say service providers, or you can say vendors, are deploying a lot of, I mean, schedulers, load balancer, resource provisioning strategies, so that these guys can take care of this service quality of service parameters, enhance the user experiences, as well as optimization of the resources and optimization of those quality of service parameters. So in the cloud, since last 2 decades, quality of service parameter optimization becomes always challenging, right? If you go for the Amazon or any kind of industry, Google, Microsoft, these people hire the R&D people to work on those parameters. Then how to attract the good class of, you can say, customers to our, services, right? So they are always in continuous computation about it. So see, just to understand what is cloud. So I hope you guys have heard about cloud in multi-base. It offers us Google Drive. It offers us VMs. It offers us software. It offers us something else. So you all are right, right? To understand in cloud, it is same like that. Blind people are touching an elephant and they are giving 8 different answers, right? The cloud is same like that. It is very hard to go for a you can say one unique definition for a cloud, right? Cloud is having in multiple dimensions. People from the infrastructure side, it's accessing cloud from the different perspective. People from the platform side, they're accessing cloud in the different perspective. People from management side, they're accessing the cloud from different purposes. And people from economic side, they are working for the some of the algorithms to efficient billing kind of things. They are looking cloud from different side, right? Similarly, same as one blind person who is touching the trunk of the elephant, who is saying elephant like a snake. One person is touching like a side of the elephant, he is saying that it's like a wall. One person is touching like a tail, he is saying that it's like a rope, right? So this kind of phenomena are there in the cloud. However, we are just going to try to define some of the we are trying to read out some of the definitions through which you get an idea what is cloud. So see this Berkeley Red Lab defines the cloud. Cloud computing has the following 3 important characteristics. One, the illusion of infinite computing resources, right? Cloud can offer the infinite computing resources. The elimination of an upfront commitment by the cloud users, right? Cloud does not require any kind of upfront commitments. Third, ability to pay for the use as needed. It means you will be paying for what you require, right? So here one important thing is that you might be encountering many times infinite computing resources. How any service provider can offer infinite computing resources? How it is possible? See, what happens when we talk about the infinite computing resources? See, we are offering the infinite computing resources in the form of virtual machines. And virtual machines are nothing, it's just a piece of code. So we can create multiple images of the VMs to the, or you can say we can create an infinite number of, by putting an infinite loop to the users. But at the end, computing services are not the infinite. We have finite set of CPUs, finite memory, finite hard drive, but those programs can be mapped those hardware. So you can say sometimes we are adjusting with the hardware, those VMs will be putting in the queue. As soon as one person is releasing the resources, and the job, and the you can say VMs coming from the pool, and we going to map to the hardware infrastructure. So this means of infinite, right? So do not be confused in terms of the infinite computing resources. You can create as many as VM virtual machines, but you have to always take care of your hardware limitations. If you're creating the number of VMs beyond a certain limits, your system will be hanging, right? Or your response time will be delayed a lot. But you can create any number of VMs. So that you have to put a certain threshold and how many number of VMs you can create. If you see the definition from the business perspective, that McKinsey given a particular definition, clouds are hardware-based services offering compute, network, and storage capacity, right? Where hardware management is highly abstracted, that can be done by a basically any software that we can call hypervisor or something else nowadays for the containerization that can be container engine, something else, right? And buyers incur cost as variable OPEX. It means that buyer's OPEX means this operational expenditure, right? Operating expenditure, right? So buyers, basically different buyers are paying different, different amount of money for the different services, right? It's not uniform that we have told the region because different QS parameters impact the different, cost. and infrastructure is highly elastic, right? And if you go for the technical perspective, a style of computing in which dynamically scalable and often virtualized resources are provided as a service over the internet, right? So it means cloud computing always offers the virtual services. It never offers the physical services. It never give a local, or you can say physical data center to any of the client, right? So this you must be able to understand from the cloud. Cloud offers everything in the form of virtualization. Similarly, you can go for the second definition by the REIS. REIS is saying that the service is accessible via web browser or web service applications, web service application programming interface that requires zero capital expenditure, right? And you pay for what you use, right? And here we have two important definitions that I would like to put more of first to make it clear about the about depth of the cloud. One is given by the Professor Rajkumar Goya. A cloud is a type of parallel distributed system, right? So it means cloud is built over the on the top of parallel distributed system. So that we will discuss about in detail. Please hold on that. Just I will give you a brief idea about parallel distributed system. So grid, I gave you example. It was built over the on the top of distributed system. What do you mean by the parallel? Parallelization means, see, when you need more than one resources, then what is need of those resources? Ultimately, you have to understand you are parallelizing something, right? Suppose I am hiring 4 people in my organization and I am giving the 4 CPU to them. Then what I am doing at the end? I am paralyzing my job. I am paralyzing my application, right? I am paralyzing my function of my industry, right? I'm paralyzing my computation. It can be different, I mean, way. One person doing documentation, another person is doing programming, another person is doing debugging. So ultimately, I'm paralyzing the process, right? That's called, I mean, parallel processing. So as many as resources you are requiring, either in your, you can say, personal life or in professional life or in computation, you are moving to the parallel computing. So therefore, in the cloud computing, we are asking for the multiple computing infrastructure. So it means cloud computing is a type of parallel distributed system. It ultimately tries to parallelize your applications or your requirements or your jobs, and it is built over the distributed system, right? On the top of the distributed system. That is basically grid computing that we will discuss in depth later on, right? Consisting of a collection of interconnected and virtualized computers. So it means it offers always the virtualized computers which are interconnected together. It means they can run in the isolation virtually, but they're interconnected. Means it is not that that particular VM is dedicated to one user that cannot be later on will be handed over to others after releasing, right? It is not true. In cloud, all the VMs, all the or you can say virtual computers are interconnected via some network that are dynamically provisioned and projected as one or more unified computing resources based on the service level agreements, right? So it is, I mean, very important term here, service level agreement. So when you go for some contradictory quality of service parameters, right? Sometimes time and cost, right? SLA helps when one person is asking two contradictory QS. For example, time and cost, right? If you want, let's say, faster computation but cheaper, it is not possible because faster CPU, faster VM will be expensive. You are going for the i7 processor. i7 processor is very, I mean, expensive. But you want cheaper, it means you have to go i3 processor, right? So in such cases, like some person is interested, I want with this amount of money, I want faster services but cheaper. Cheaper means I'm limiting my budget. So in that case, we have to put some kind of service level agreements between customer and the service provider, right? So it means if you are sacrificing some amount of time, then you are getting benefit in terms of your cost. If you are basically sacrificing the cost, then you are getting the advantage in terms of the time. So that is, I mean, kind of agreement has been made between the service provider and customers. Then, I mean, further service will be offered to the clients. Otherwise, client or service provider can be conflicting in their promises, right? So this is kind of a negotiation between service provider and consumer, right? So in brief, now you must be able to understand what is, I mean, cloud. It's a parallel distributed computing system that offers all the computing resources at the virtual machines, which are basically able to dynamically provision, right? And it basically offered with the help of SLA between service provider and consumers, right? I hope definition is clear.
Just a quick info, guys. If you want to make a career in cloud and DevOps, then Intellipaat provides an advanced certification in cloud computing and DevOps by ENICT Academy IIT Roorkee, and it is taught by IIT Roorkee professors and industry experts. This course is designed to help you upskill and land in your dream job. Now, let's continue with the session.
So now we have, another definition that's called, NIST. It is, very, important definition that is basically given by the NIST, National Institute of Standards and Technology, right? So same definition written here. So this is very important. We, accept this definition globally. You can say cloud computing, a model for enabling ubiquitous, convenient, means user-friendly, on-demand network access to a shared pool of configured computing resources, right? That I have told you. Because of the virtualization, in the cloud, we always create the pool of the resources which is being shared among the multiple users, right? These resources are networks, servers, storage, applications, and services, right? Which can be rapidly provisioned, or you can say dynamically provisioned, right? And released with minimal management efforts of service provider interactions. So it means all the services are automatically managed by the one piece of software that's called by our hypervisor, right? And NIST also gave some of the, 5 essential characteristics, 3 service models, and 4 deployment models. So let's see one by one what are important characteristics. So one important, these characteristics will help you out to discriminate among classical computing as well as the cloud computing or other computing, or you can say cloud computing paradigm. So if these 5 characteristics are being basically satisfied by a particular technology, then you can say it is right now cloud or it is not cloud, right? So first important characteristic is on-demand self-service. See, these are the not limited only, but these are the standard characteristics which are given by the NIST, right? So if you understand this, on-demand self-service, you can say real life examples. If you go for the online servicing, or you can say online shopping, right? Whatever you want, you can buy or you can pay, right? So it is your on-demand self-service. Nobody is there to serve you out, right? This is best example for the online. However, some of the offline, you can say stores are also providing this kind of, or you can some of the outlets are also providing this kind of services to you, right? So in which you can choose whatever you want and you pay for that. The best example nowadays, you can go nowadays, most of the airports are having a kiosk that is basically automatically serving you different fooding materials like cold drinks, chips, something like that. So you guys just you can choose that particular code, right? And you can, according to that code, you can insert some money and that particular item will be in your bucket, right? So this is, somewhat of on-demand self-service. So same way, nobody is here to guide you. Nobody is there to, guide me. Some instructions will be there to guide you, but nobody is there to interference in between what you are asking for. Same way, even when you go for the cloud services, either AWS, Google, Microsoft, you can go for your self-services. You can write your configuration. You can ask for the VMs and other kind of services. And second important characteristic is broad network access. So broad network access means without, first important thing is without internet or without network, you cannot access your cloud services, right? And second interesting thing is here that cloud basically offers few capabilities. One is availability over the internet. It will always be available over the internet, but it will be accessed through the standard mechanism or standard protocols. You cannot access it, your local protocols or local ways. It is always following the standard mechanism. Because of that, any kind of customer can connect to that, particular service, right? So any kind of means heterogeneous users can also be there. One can be thin client or thick client, right? So if you talk about thin client means any compute resource that is having capability to just connect to the internet, that can be considered as the thin client. your mobile phone, or you can say your any device which is having processor, or you can say kernel that can run your browser. That can be considered as a thin client, right? A thin client can be one particular device that can basically offers you some of the computational facility or computational resources in itself, such as your desktop, such as your laptop. Those comes under the thick client, right? Because some of the computations you can also do on your device as well. So basically, cloud offers the services to get from both the, you can say, both kind of, clients, right? If you see, in other countries, that's called multi-tenancy and resource pooling, right? So I have already given you this with the help of example of virtualization. So virtualization is very, important technology to offer this, resource pooling or multi-tenancy architecture, right? Because of the, virtualization, you can make a pool of the set of, or you can several computing resources or memory resources or networking resources as well, right? And those pool can be shared among the multiple customers or multiple clients. So that's so it means what do you mean by multi-tenancy? That multiple computing resources are, or you can say pool of multiple computing resources is being shared among the multiple clients. So this kind of paradigm or this kind of architecture is referred as the multi-tenancy architecture, right? This pool that already have we have discussed, it can be a create for the all kind of hardware resources. So see, it is location independence. Important characteristic about this pool is location independence. It means in the cloud you do not know where these resources are there. It may be possible that one hardware is in Delhi, one hardware is in Bangalore. They can also create a pool of the resources. It is not required that all the hardware will be or you can say whole infrastructure will be at the same place. It is not always required, right? So it means it is location independent. It can be lie in India or abroad anyway, right? And has major implications over the performance, scalability, and security, right? So obviously, if you're having a good pool of high compute intensive resources pool, it will also improve the performance. But another thing you can say, if you are creating a pool of the resources, those are inside of one particular organizations, they will be having minimum latency. So it will be, or you can say minimum latency computing services will be improving the performance. And similarly scalability and security, right? So security, if you talk about the security is here having a great role. Suppose if you're using the virtualization role, sorry, if you're using virtualization layer, right? So that is one person is basically attacking over this particular device. So that particular you can say attacker or hacker cannot attack that particular device. It will be limited with the virtualization layer only. So in that context, this is the secure, right? Your data will be saved at the infrastructure because this pool of resources created on the top of the physical machines, or you can say physical infrastructure, right? So if I give you a typical example, so you can see here what are typical layers in this particular services. You can see we have at the bottom infrastructure. That means your CPU, memory, or you can say network, all hardware resources. On the top of, we have either, it depends on the kind of hypervisor that we will discuss later on. It depends on whether you are having a host OS, it is optional. On the top of, we have virtualization layer, that's called hypervisor, or you can say virtualization layer, right? Whatever you want to say, virtualization layer, right? And on the top of, we have to create the set of VMs. These are all VMs, right? So this is the typical architecture. On the top of, we have applications, application layer, right? It can be A1, A2, A3, and A4. So you see, if somebody is trying to attack on a particular, you can say infrastructure, so or on particular application, so that particular person will be attacking here only, right? So if you're trying to attack on VM, it will be limited to this particular layer. It will be tackled by the hypervisor. It can attack over the hypervisor, but your data is being basically saved here. The data is not being saved in the hypervisor, right? Your data is being saved here at this particular layer. So that's how it gives a good security on this over this particular layer, right? So that's why we say cloud is secure in that particular terms. However, cloud is not secure when you are using the public channel, when data is being transmitting from one spot to another spot. For that purpose, set of other technologies are being developed, like blockchain are also coming for the cloud, and some you can say private channels are being developed, like virtual private network, so on, right? So in that context, some other extra efforts are being made to make these services as secure, right? So let's move to another characteristic, that means rapid elasticity, right? So rapid elasticity means it is very important, or you can say it's very unique property of the cloud that is even not offered by the grid. In the grid, we are able to offer the scalability, right? It means if your demand is increasing, we can increase number of resources. But your demand is decreasing, we cannot decrease the number of resources. This was not true, basically, in the case of grid. But in the case of cloud, you have, or you might be encountering some of the applications, you cannot predict the resource requirement for that, right? Dynamically, or you can say during the implementation or during the run, the requirement is being changed, right? So in that case, elasticity plays an important role. Cloud can increase or decrease the number of resources as per your demand, right? So that is what we call elasticity. So this is unique property of your cloud, right? And another property is called measured service, right? So you see, cloud is basically completely business model, right? So nothing is being offered in the cloud without any payment. However, for the students or for the advertisement purposes, some amount of you can say money, AWS or Azure or Google Cloud give some amount of dollars. For that particular dollars, you can get the service. After that, they start charging, right? So for the charging, we need a proper mechanism for the measuring the services, right? Measuring and metering these services, right? So for that purpose, we require a metering capability, same as you use in the electricity that you consume. You have a meter. So same kind of algorithms are running at the back end to the service provider side. The measure your services, what amount of services you are using, that amount of payment you have to make, right? What amount of services you are using, what kind of services you are using, because cloud is offering you to services, right? So according to that, it is having a proper algorithms through which you will be charged, right? So here you have a brief summary of the characteristics that you can read it out. These are 5 important characteristics: one, on-demand self-service, right? And broad network access and resource pooling, right? It means multi-tenant architecture provide, and rapid elasticity, that is taking care of scalability and speed of execution and releases, right? So it means it is giving faster services in terms of execution and releases. That's why we call it rapid elasticity, right? And measured services, right? So measurement to ensure automatic control and optimal resource use, right? So and optimal payment, optimal charges from the client aspect, right? So these are 5 important characteristics. So see, still cloud computing is becoming very confusing. What is all about cloud computing? Still, some of the terminologies are there, some of the points we have put on here, but these are not sufficient enough to define the cloud. We have a lot of things are there, right? But these are the few things that is, are part of the cloud, right? So you must be knowing that virtualization that we have discussed, resource provisioning on demand, we have already discussed, scalability, we have discussed, elasticity, we have discussed. Now we have discussed security as well, right? So see, here we have a different concept to understand. In cloud, security is just basically to understand the to ensure the your access of the resource, access of the data, or you can say prevent the unauthorized, or you can say unauthenticated access of the data, right? So if you understand the unauthorized and unauthentication concept, you can take this. One of the best example, that suppose you are going to catch a flight, right? And you have a security check, right? And the security check is that one, you can say security check, that one person, you can say policeman or maybe any concerned person who's checking your passport, who's checking your name and validity of your passport. That's called authentication, right? So just you are authenticated, then you are allowed to enter to airport, right? If you understand the concept of authorization, then once you get the deep boarding pass, right, then you become authorized to enter into the flight. So it means authentication is just preventing to you can say unauthenticated access, and authorization is just to having a valid region to access the resources, right? So in the cloud and security, we deal with two important things: how to prevent the unauthorized and unauthenticated access of the resources, right? And another term is privacy and trust. So privacy is that how your data is being maintained at the service provider side as the private, or how your information is being maintained at the private, or how to put set of, or you can say constraint that what amount of my data will be accessed by the particular class of users only, right? So the privacy, we need to ensure that my information, if I am submitting to the cloud, it must be, you can say, safe, and it not be shared among the other peoples, right? And if you talk about the trust, trust is very important. I mean, concern nowadays. Trust is basically we understand in two different ways. One, the amount of, you know, the percentage of confidence that you have on the service provider, that your information or data is not being shared among the multiple users, right, or unauthorized users, right? If you talk about the trust, then basically trust is basically, and in another way, suppose data is being transferred from A source to another B. So how you can trust over the cloud if my data is being transferred from the A source to B, that it is being delivered to the right source? Or C, another way, that how you can trust whatever data I'm transferring from the source A, that same data is being delivered to the B. It may be hacked, or it may be changed, right? And for this, I hope the security and privacy and trust has been, clear to you in this regard. And we have already discussed uh, this pay as you go. This is the, I mean, one of the important thing in the cloud, that you have to pay only for what you are going to use. And another thing is IT outsourcing. So cloud also supports the IT outsourcing, right? It means it also supports the services becoming outsources, right? It means you are accessing services from this one service provider. If it is not there, then it can be outsourced from the other service provider, right? And economy of scale means that if you are using the one services or one amount of services, if you are increasing your demand of the services, it means if you are using multiple services, or you can say that multiple users are using their services, that service becomes cheaper. Why? Because when resources being shared among the multiple users, the cost will be divided among the number of users, right? So that means when number of people are using, or number of, you can say number of requirements are increasing, your average cost will be cheaper, right? And virtualized data centers, that means cloud always offers the virtualized data center. It does not offers any, you can say, a dedicated data center to any person, right? And that SLA we have already discussed, service level agreement. If you talk about billing, cloud is having proper algorithm and proper, you can say, scenario for the billing. It is not like that whatever they are charging in other cases. Let's say suppose you go for the other kind of in real market, you go other services. Sometimes people are, one person is charging anything, another person charging anything, right? So here you have a proper standard, proper set of rules, proper charging rates. Your billing will be proper for what you are going to access, right? And it will be always served by the internet. There is no capital investments, and the quality of service, you must be knowing that it is major concern, that you have to take care of quality of services while offering. So cloud offers the quality of service based services, or you can say user based quality of services. And utility computing, if we have already discussed, green computing we have already discussed, and one is remaining cloud bursting, right? So cloud bursting says that, see, it is having multiple deployment models. One is private, public, right, and hybrid as well, right? So when you are going to use the hybrid cloud model, so it means your cloud. Suppose you are having lack of resources see, when you go for the hybrid, model, then first priority is given to the private resources, right? So once you are take over the private resources, now you need more resources. Then, if you are using the hybrid cloud concept, then your cloud will be burst to the public cloud, right? It means when you are having scarcity of private you can say resources, then automatically your cloud will be switching to the public clouds, right? So it means you will be starting to access the public resources. So this feature is given. It is not limited that you are having always private resources. It may be also possible for certain services you can go for the private cloud, or for certain services you can also go for the public cloud.
So why consider cloud computing? Why not other technologies? There are so many different domains which you can go ahead, but why exactly should you go with cloud computing? So one reason is whenever a technology or an industry is growing, if you start learning and get into that industry right when it's growing, you grow with it, and you will basically be a senior or an expert in whatever you want to do. So I just want to show some numbers and stats which shows that cloud computing is growing exponentially right now, and this would be the right time to get into it. So over here you could see some this is worldwide public cloud service revenue forecast, and so they've split it into 5 different parts. That is PaaS, infrastructure as a service, software as a service. So they've split it into multiple parts, and you can see all different types of cloud. The expenditure, sorry, the incoming revenue is just increasing and it's not decreasing, and it will keep increasing. By next year, this is the forecasted numbers. And yeah, so basically when investment gets higher in a particular domain, so in that case, if they invest more, obviously they're going to hire more people, and the need for cloud computing engineers is going to increase. So it will be different. So there would be administrators, there would be what is it, architects, there would be so many different roles, but the demand for cloud computing professionals is steadily going to increase. Yeah, so another one is that this is just the spending from the top 3 cloud providers, that is AWS, Azure, and GCP. And over here, you can see by quarter since 2018 and till 2019. So basically, the cloud infrastructure services, so just infrastructure services has grown 37%. And yeah, so even right now, the public cloud market share is pretty similar. AWS owns 31% of the public cloud market share. Azure is around 15-16%. Google Cloud around 7-8%. And then comes the others. So they are the top 3. And yeah, so you can choose any cloud computing provider. So basically, you want to learn, you can go ahead with AWS or Azure or GCP. All 3 are great. It's not that you will just have to go with one. All right. Okay. So over here, these are again some numbers which I got from various platforms like Forbes and Gartner. And over here, you can see Gartner has predicted that 95% of cloud security failures will be the customer's fault, not the cloud computing provider's fault. This basically shows their investment in cloud security and also cloud security services. And then over here, so basically, of the organizations using cloud services, more than 75% indicate they have a cloud first strategy. That basically means, let's say there are 100 companies using cloud, 75 of those companies want to make cloud computing their main infrastructural what is that? Yeah, so basically they completely want to abolish their on-premise setup and bring everything to the cloud computing platform, right? So and other things you can just read from here. So public cloud soaring to $331 billion by 2022, according to Gartner. Cloud computing is crucial to the future. So again, this is from Forbes. And so there is an article in monster.com, which is a pretty famous job portal. Again, why it's a great time to start a job in cloud computing. So you can just go through these articles, look at the numbers and statistics, and that's what I wanted to show you. And some top companies like Reddit, Facebook, Google, Amazon. Basically, every single company right now is using cloud, and every major company obviously needs cloud computing. And without cloud computing, or without the help of cloud computing, no companies could function right now. So what I basically mean here is if you learn cloud computing, you could get into one of these major companies as a cloud engineer or cloud architect or a cloud developer or a cloud administrator. So whatever role you want to go into, it's in your hand, but you can get into a top company. And so in Indeed, you can just search with the keyword cloud computing. So I'm just showing you the jobs which I searched for a little while back and just checked it. So you can just check in the job portals and you can check there is always jobs available under cloud computing. And if you have the right skills, you can get into it. And also one more thing everybody looks into is the average salary. And so cloud engineer is a pretty generic term. And so basically a cloud engineer could be a cloud admin, a cloud architect, a cloud what is that, developer. So there could be anything. So it's a pretty generic term which I wanted to include because this is more about how to make a career in cloud computing, not how to become a solutions architect or how to become a developer. So I just wanted to keep it generic. So now the average salary, you can again check it in various job portals. So I checked in ZipRecruiter and Indeed.com. The average salary in US is $128,000 per annum. In India, it's 7 lakhs per annum, and in UK, it's 60,000 pounds per annum. So this is the average salary. So as I told you, this is the average salary. That basically means as a junior or as a beginner, you would basically start with a lesser salary than that. But as you grow, as you gain experience, let's say you become a senior cloud engineer, you could earn up to 25 lakhs per annum. So I've seen these numbers posted on Glassdoor and many other job portals. And if you have the right skills, you can also get into it. All right. So now the skills to have in cloud computing. All right. So cloud service providers, knowing a popular cloud service provider like AWS, Azure, or GCP. So most probably you guys would have had a question right now, which is better, AWS or Azure, or AWS or GCP, or yeah, basically you would obviously have this question. So the thing is, no cloud provider is better than another cloud provider. All cloud providers provide this same service or similar kinds of service, because they are all cloud providers, they provide similar services which is required for infrastructural purposes. All right, so you could choose AWS or Azure or GCP. It totally depends on your perspective. So let's say you're going to work for a company which uses Azure. In that case, you should learn Azure. If you want to apply for a company which is using AWS, go for AWS. So it depends on the company you want to work for or the company you are currently working in. So under that, there are various services. Again, so EC2 app services. So as a beginner, you wouldn't know what exactly they are. But once you get into and start learning AWS or start learning Azure, you would obviously learn and understand more about it. And then networking. So why I say networking here is, so understanding the very basics of networking is really important while you get into cloud. So let's say you're launching a server. So when you launch a server will have a public IP address, it will have a private IP address, it will have a DNS name. So you might be alien to these terms. So it's better to have an idea of all these terms before you get into cloud computing. So understand what is an IP address. So that's a very basic thing. So understanding what is an IP address, understanding what is the subnet mask, understanding about common protocols like HTTP, HTTPS, SSH. So learning these basic networking will help you when you get into cloud, because obviously cloud itself is a network which is just on a different day on a data center on the cloud providers infra. So basically, let's say you are creating an architecture on AWS. Obviously, that architecture is created in AWS's physical data center, and that particular architecture, yeah, so it is basically a network. So everything is network, and learning the basics of networking will help you. And then Linux skills, command line Linux skills are important because 90% of the cloud servers run on Linux. So again, if you get into a company, most probably there is a 90% chance that they will use Linux as their cloud servers rather than a Windows server, or yeah, so rather than a Windows server. So learning Linux, I would say it's a must if you want to get into cloud. All right. Okay. So other skills, so DevOps. So again, most of you would have questions like, so if I get into cloud computing, can I get into DevOps? What are the tools will I have to learn? So again, to start off with the very basic, start with GitHub, that is Git, and then you can learn some major tools, major containerization tools like Docker, Kubernetes, and there are other CI/CD tools like Jenkins, Azure pipelines. So there are various tools which you can start from. But if you want to start from cloud, so basically, if you don't sorry, if you have not started with cloud, then please start with cloud first and then check out what you can learn or what you can do in cloud computing. All right. Sorry, what you can do in DevOps. All right. Okay. So programming and database skills. Um, Programming skills is important if you are looking for a certain job role which will require you to know programming. For example, cloud, as I told you, cloud engineer is just a generic term. So there is solutions architect. It's a particular job role, and there is administrator, cloud administrator, and there is cloud developer. So if you want to become a cloud administrator, you do not need any programming skills. But if you want to become a solutions architect, you would have to know at least one programming language, one high-level programming language like Java or Python or C Sharp. It doesn't matter. You will have to know one high-level programming language. And then if you want to become a cloud developer, in that case, you should know how to do software development, and also you should know about cloud computing. Okay, so these are some skills, and again, database skills is basically learning SQL is like Linux. SQL and Linux are pretty common for every single IT job. Whatever application you are developing, if you're going to use a relational database, the relational database will have SQL running on it. All right. Um, Okay, now security and disaster recovery. And in this case, this basically would be theoretical when you learn, but when you get into a company, you will be setting up certain best practices in order to make sure that the architecture you've created or the application which is running on cloud is performing properly, and also there is no security issues or vulnerabilities. So that basically you set up security properly. And then disaster recovery, again, this is basically, let's say you have your application running on one particular region, and let's say you've not migrated it or replicated it in another region. And if that particular region goes down for a couple of minutes, then your application would suffer a crash or your application would suffer a downtime for that particular period of time. Okay. So if it suffers downtime in that particular period of time, in that case, what happens is uh, your application's usage would be decreased and you would obviously have a loss in that case. So making sure that your application is replicated in another region. So whenever one region goes down, the other region would still be running, and the incoming traffic will be diverted to the application which is running on the other region. So this is another major skill you should have. All right. So who is a cloud engineer? I'm going to skip this part because I'm going to talk about the top skills you should have as a cloud engineer. That is top skills in the sense, top skills as a cloud professional. So I took this from Indeed.com. So Indeed.com basically did a survey on various job descriptions they have, and they've decided the top 5 skills according to the number of times a particular skill has been mentioned in a job description. So AWS was the most mentioned job description for a cloud professional, and then came Python, came Linux, then shell scripting and Azure. So these are the top 5 skills which a cloud engineer should know. So again, you could know Amazon Web Services or learn Azure, but learning one high-level programming language is required for most cloud roles. Linux is a must. Shell scripting is also required because sometimes you might not be able to automate a task using a cloud automation tool. In that case, you would have to automate it using shell scripting. And in that case, you should know shell scripting or scripting using Python or using Perl. Okay, so this is the thing. And all right. So you want to get into cloud, in that case, there are various job roles. You can get into cloud from various different profiles. Let's say you are from a development background. Let's say you are an expert in .NET. You can learn cloud and become a cloud developer. If you're if you're an IT admin or Linux admin or Windows admin, again, you can learn cloud and become a cloud administrator. And if you're from even tech support, or if you're a support executive, in that case, you could learn and you can become a cloud operations engineer, or you can become a cloud support engineer. And then from that particular role, you can switch to solutions architect or cloud developer as well. So whatever role you are in currently, you can still switch to cloud engineering or any cloud job role. So these are the top 5 job roles: cloud solutions architect, cloud developer, cloud sysops admin, cloud DevOps engineer, and cloud support engineer. So cloud support engineer, solutions architect, sysops admin, developer, these are the basic roles. Cloud DevOps engineer, you cannot directly become a cloud DevOps engineer. You should have the right skills for it, and you should have done real-time projects, and you should have done what is that? You should have some real-time exposure, and it could come from work experience, or it could come from you doing projects, and yeah. So basically, you're doing projects and making sure they reflect on your resume. Okay, so these are the top job roles, and let's say you could go with solutions architect. So if you want to go with solutions architect, in that case, you should know one high-level programming language. If you want to go with developer, in that case, you should know software development. It could be web development, it could be mobile application development, but you should know. If you want to become a cloud sysops administrator, you do not need any programming. You just have to know that particular cloud tool and how to monitor and report using them. And then cloud DevOps engineer. So for this, you should know cloud as well as various DevOps tools and DevOps principles. And finally, cloud support engineer is basically a person who guides basically guides their clients or their company's cloud infrastructure to basically, whenever there's a problem, they troubleshoot it and make sure the solution is in place. So these are top job roles. And so you guys also might have a doubt, or you might have a question on what certification could pay me more, or what certification should I take. So the highest paid certification according to Forbes and Gartner, so it's basically Google Cloud Certified Cloud Architect Professional Certification. But the professional certification is pretty tough. I would suggest you to go with an associate certification in AWS if you are a very beginner to cloud, and if you're not sure to choose what cloud provider you should take up. So if you're not sure about choosing, if you're not sure about AWS or Azure or GCP, I would say go with AWS. And I would say go with AWS Solutions Architect if you're not sure. All right, because the AWS Solutions Architect pretty much covers and keeps its foot in all areas. And if you become and learn solutions architect and get that certification, it'll be really it would be a really good first step for you.
So next is, what is AWS? We all know that AWS is a cloud computing platform. That is, AWS, Amazon Web Services, is a cloud provider which provides a lot of services on the internet to the user. Many companies like Netflix, Unilever, Expedia are using Amazon Web Services for their own personal needs. Netflix have went all into AWS. That means all of their infrastructure right now depends on AWS. So think of AWS's capability. Now let me give you a few examples of other cloud providers. The first one is Microsoft Azure. Azure is owned by Microsoft, and they also host their own products on it, like Office 365, and also you can do native integration of IDEs like Xcode, IntelliJ IDEA, and Visual Studio. Then Google Cloud. We all know Google is the biggest brand name in the internet industry. Google Cloud came around 2011 and it has become a hit, and it is now the third most popular cloud provider in the world. Alibaba Cloud. We all know Alibaba. Alibaba is a China-based company. Alibaba Cloud is also called as Aliyun. It basically provides services to businesses who want to host their services online. Next is IBM Cloud. IBM Cloud is also similar to Azure, Google Cloud, and Amazon Web Services. It also provides services like compute, networking, and storage services. Then comes VMware. VMware is a software virtualization company. So basically they provide virtual machines via the internet to users or companies. Finally, Salesforce. Salesforce is also a cloud platform and their main tool is CRM, that is Customer Resource Management, and they are considered to be the number one at it. So why is Amazon Web Services so successful? They have started AWS in the year 2006 and it is still the number one cloud platform. Let us see why. Before even a cloud company thought of it, Amazon Web Services already revolutionized the IT industry by introducing a new way to use servers to the companies and the businesses. And there are three key points which made AWS successful. The first is its simple and per hour billing. The billing system of AWS is very simple that you will be only charged for the particular services which you use, and it is also based on the number of hours you use, not the days or the months. The second reason is Amazon's brand name. Amazon.com is a household name all over the globe because it is the biggest e-commerce platform. Third reason is its easy profile setup. The first thing you have to do is provide your details, your email address, your username and password, just like you create a social media profile. And the second step is you have to give your credit or debit card details, and that's it. Your AWS profile has been set up. But what makes Amazon or Amazon Web Services peculiar? So Amazon has its own leadership principles and it makes its employees follow that. Let me give you a few examples of them. The first is customer obsession. Customer obsession is that leaders start with the customer and work backwards. The first thing they follow is they need the customer's wants. That means whatever the customer wants, they want to give. Then they work backwards. They reverse engineer. The second is invent and simplify. Leaders expect and require innovation and invention from their teams and always finds way to simplify. They also need inventions and also they need to simplify it. The simplified, most easiest user-friendly manner is more attractive for a customer. Third principle is ownership. Leaders or owners, all the employees in AWS or Amazon need to have that feeling of ownership. And the fourth point, this point is common for anybody. So learn and be curious. Leaders are never done learning and always seek to improve themselves. So always keep on learning and be curious in what you do. The next is the future of AWS. So what is going to be the future scope and the job trends of AWS? Let us see. So the market share of 2018's quarter 4, that is the last 3 months of 2018, Amazon Web Services had 32.3% of the cloud computing share, and Microsoft Azure comes second with 16.5%, which is almost the half of Amazon Web Services, and then Google Cloud Platform, and then Alibaba Cloud, and after that comes the other services, other cloud providers like IBM Cloud, VMware, and Salesforce. And what are the AWS job trends right now? Let me give you few job trends. So the 4 job trends are AWS SysOps Administrator, Cloud Developer, AWS Solutions Architect, Cloud Software Engineer. So the salary of AWS SysOps Administrator is $111,000 to $160,000, and the Cloud Developer is $95,000, and an AWS Solutions Architect salary varies from $98,000 to $150,000, and a Cloud Software Engineers varies from $63,000 to $93,000, and these are all the numbers for a fresher. The salaries may vary with your experience. If you are an experienced person in the cloud industry or in AWS, you might be earning more than this. This is just the starting. Okay guys, now we've come to the most technical part of AWS. The AWS service domains and the services they provide. The AWS service domains are vast, but let me give you few of them. So few of the service domains are compute, database, storage, migration and transfer, customer engagement, security, identity and compliance, management and governance, and networking and content delivery. Before starting off with explaining the services, let me be sure that the explanation of each of the services will be very simple that anybody watching this video could understand it. The first service domain which we are going to see is compute services. Under compute services, there are a lot of services, but right now we are going to see only 4. These are the most important ones. First is Amazon EC2, then Elastic Beanstalk, then Amazon Lambda, and Elastic Load Balancing. First we'll see what is EC2. EC2 is one of the most integral parts of the AWS ecosystem. It allows users to rent virtual computers on which they can run their own computer applications. Also, EC2 is providing on-demand scalable computing capacity in the AWS cloud. So, for example, if you own Macintosh and if you want to run a Windows application on it which is not compatible with your computer, instead of buying a laptop or a new desktop, you can just opt for a virtual machine on the AWS cloud in which you can run your Windows application for a short time and pay only for what you use. Also, this illustration says that you can also increase your system specifications or rent multiple virtual machines on the same specifications. Moving on to the next service. The next service is Elastic Beanstalk. With Elastic Beanstalk, you can quickly deploy and manage applications in the AWS cloud without having to learn anything about the infrastructure that runs those applications. For example, if you want to run a PHP application and you don't know anything about PHP, you just have the PHP project folder, you can just upload it to the Elastic Beanstalk. It will automatically take care of launching it. It will give you an URL which you can click and see whether your application is working or not. So let me give you a brief summary of what happens here. First, you create an application, whichever platform which you want, like Ruby or Python or PHP. Then you upload that project folder here. And after that, you launch the environment. Then the final thing you have to do is manage the environment, because you will be provided an URL which the application will be running on. Then after that, you can update your software and keep on uploading the updated versions, and it will automatically get updated. You need not have any technical knowledge or programming knowledge to use Elastic Beanstalk. Now moving on with the next service. The next service is AWS Lambda. AWS Lambda is a compute service that lets you run code without provisioning or managing servers. So look at this illustration below. Okay, now you are on an e-commerce website. Take it as Amazon.com, and you are confirming a package order. So that package order details will be stored in a database. Take it as DynamoDB. And at that time, the Lambda will be triggered. The Lambda runs a data transformation code which is loaded into the Redshift warehouse. Let me explain what are DynamoDB and Redshift in the later parts of the video. But right now, learn what is Lambda. So Lambda runs this data transformation code, or whatever code you put into it. And finally, after it is stored in the data warehouse, it will be giving you analytics which are created from those data which you have collected. So this is what Lambda does. The last service in the compute service domain is Elastic Load Balancing. Elastic Load Balancing distributes incoming application or network traffic across multiple targets such as Amazon EC2 instances, IP addresses in multiple availability zones in many geographic regions. So look at this illustration. There are users trying to use the application and the ELB is in the center of it. So what basically happens is when there are 10 users trying to use a website, the traffic will be less. So ELB will target them or redirect them to a particular EC2 instance. But what if 100 people are trying to access the same website at the same time? The traffic increases. So the ELB divides the 100 people into 10 groups and redirects them into 10 different EC2 instances so that they have easy interaction with the web server without crashing it. The next service domain is database. Database gives us a lot of services in Amazon Web Services, and right now we are going to see 4 of the most important database services. The first one is RDS, then DynamoDB, then Redshift, and finally Elastic Cache. Now let us see one by one. The first one, RDS, it's Amazon Relational Database Service. It is very easy to set up, operate, and scale a relational database in the cloud. And Amazon RDS provides you with 6 different options. The first one is Amazon Aurora, then MariaDB, then PostgreSQL, then Microsoft SQL Server, MySQL, and Oracle Database. So what can you do with these? So basically, if you want a SQL service or a database service, you could opt any one of these database services like MySQL or Oracle Database and use those services like they are in your local system. Now let us go on to the next service. It is DynamoDB. DynamoDB is a database provided by AWS. It is a key value and document-based database that delivers single-digit millisecond performance at any scale. That means single-digit millisecond performance means it gives you a very low latency. That is, it provides a very fast database communication system. So now imagine there is a social media stream in real time is coming into your application or your website. So there is a Lambda code which you would have written for generating hashtags. So basically think there is a hashtag and there are a lot of tweets coming in that particular hashtag. So what do you do? That Lambda is triggered, then finally all those data can be stored in DynamoDB. After storing them there, you could take it out or you could use those data whenever you want to create a trend and put it in your application or your website. DynamoDB is used in web, mobile, gaming applications and also in IoT because of its low latency. Now moving on with the next service. Amazon Redshift is a fast, scalable data warehouse that makes it simple and cost effective to analyze all your data across your data warehouse and data lake. So what is the data warehouse? Data warehouse is like a database, but here you can use it to store raw data and analyze data, and it is mainly used to take business or management decisions. So go into this illustration. So check out, first there is an input, then there is an S3 bucket to store that data which is inputted. Then after that there is Redshift. So what Redshift does here, it stores all the raw data inside. Also it has elastic resize and concurrent scaling. These are few of its attributes. So assume that you are storing a large amount of data and you still need more data space stores so that you can store more data. So what elastic resize does it automatically or dynamically resizes or scales your space. Or if you need only to store a less amount of data than you usually do, then it automatically reduces the size. So after doing all these, you can create an analyzed output for business decisions using business intelligence tools. Now moving on to the final service in the service domain. The final service is Elastic Cache. First of all, let me tell you what is a cache. Cache is an auxiliary memory for high-speed data retrieval. So how does a cache or an elastic cache provide high-speed data retrieval? So basically the cache or an elastic cache is between the two sides. That is, one side is the user end which contains the internet applications or the web applications, and in the other side is the server side. So whenever the user wants any information or data or a service, he requests, and first it checks in the cache whether it is available or not, and if it is available, it will be directly taken to the user. But if it is not, then it will go to the server and come back. So if the same information or data is used frequently by the user, it will be automatically stored in the cache, and the next time he uses it, it will be there. And also in Amazon Elastic Cache, there is an option that you can scale up or down dynamically. Moving on with the next service domain. The next service domain is storage. Storage also has a lot of services. Storage is one of the main features which is used by companies and firms who are using AWS. Take Netflix or Expedia. So what they do is they rent the infrastructure from AWS and they store all of their components, all of their informations, all of their data in AWS storage services. But the data is not owned by AWS. Only the services which they provide are owned by AWS, and the data is totally in control of the company who is offered that. Okay, now let us see the first storage service, Amazon S3. Amazon Simple Storage Service or Amazon S3 is the first service under the storage service domain. So it is an object-based storage and it offers a high scalability and data availability and a very good security and also performance. So what you can do with this storage services, if you are a user, you can create a storage bucket and then upload your files and also store it there for how much ever time you want, and then you could download it. It basically is stored in the internet, and the objects which you are storing like image files or video files are called objects, and those are stored inside buckets. So the next service under the storage service domain is Amazon S3 Glacier. Amazon S3 Glacier is basically used for archiving data and backing up data. Many companies use Amazon S3 Glacier because of its very low cost service. It is very secure and also durable, and you can use this for a long term backup. If you want to back up your data for the next 10 years, Amazon S3 Glacier is your right option. And let us now move on to the next service under the storage service domain. The next service is Amazon EFS. EFS is nothing but an elastic file system, and it provides a simple scalable elastic file system for Linux based workloads. That means you could create file systems and mount it to your EC2 instance, and you could use it as an elastic file system or a normal file system, and also you could create a single EFS or a single elastic file system and mount it to multiple EC2 instances. And when you change in a particular EC2 instance, and when you upload a file to the EFS in a particular EC2 instance, it will be updated in all the EC2 instances. That is because the EFS is a single entity and there are 10 EC2 instances, and the same EFS instance is connected to the 10 EC2 instances. And you could use EFS to test and optimize and then move data and finally share data between instances. Now let us see the last storage service domain, storage service under the storage service domain. The last storage service is AWS Storage Gateway. AWS Storage Gateway is an actual gateway between the on-premise software appliance and the cloud-based storage. So what AWS Storage Gateway does is, it is the intermediate or the middleman for the on-premise application and the AWS cloud infrastructure. So whenever an on-premise application is opted for AWS cloud infrastructure services, AWS Storage Gateway leads the way. So what it does is, it gives a seamlessly easy integration with data security features between both the on-premise IT environment and the AWS storage infrastructure. So this is all about the storage service domain. Now let us move on with the next service domain. Networking is the next service domain. Networking's most used services are Amazon VPC, CloudFront, and Amazon Route 53. Let us look at them one by one. Amazon's VPC is one of the most used services all along. So what it does, it lets you provision a logically isolated section of the AWS cloud where you can launch multiple AWS services in a virtual network that you define. So you could create multiple subnets in multiple availability zones, and you could launch a lot of services like EC2, Elastic Beanstalk, OpsWorks, and also Route 53 and everything. So you could launch all of these services within that, and you can make all of them communicate with each other. Also, another use of VPC is that you could use VPC peering to connect two VPCs together and make them communicate with each other and route traffic across both VPCs. Let us move on to the next service. The next service is Amazon CloudFront. Amazon CloudFront is basically a content delivery network or a CDN. So it is a CDN service that securely delivers data, videos, audio files, applications, and APIs to customers globally. So what it actually does. So for example, there is YouTube. YouTube is a video streaming platform, and YouTube needs a content delivery network to store all of its videos. So what it does is, it has an origin server, but it cannot provide all the data to all the users all over the globe from that particular server. So Amazon's CloudFront has multiple edge locations all across the globe. So if there are 3 different end users from different parts of the globe trying to access the same file from the same CDN from the same origin server, for each user the CloudFront edge location will vary, and they request the origin server and get the data and then move it forward to the end user.
Just a quick info, guys. If you want to make a career in cloud and DevOps, then Intellipaat provides an advanced certification in cloud computing and DevOps by ENICT Academy IIT Roorkee, and it is taught by IIT Roorkee professors and industry experts. This course is designed to help you upskill and land in your dream job. Now, let's continue with the session.
So this makes the content delivery even faster and secure and better. Now let us see the third service in the networking domain. The third service is Amazon Route 53. Amazon Route 53 is a highly available and scalable cloud domain name system web service. So what is a DNS or a domain name system? Domain name system is like a telephone book for the internet. It stores all the IP addresses and it converts the domain names to IP addresses. So for example, if an end user asks for a website called example.com and the DNS resolver checks it, and if it doesn't have it, it asks to the Route 53 which you have configured, and the Route 53 converts that particular domain name to an IP address and sends it back to the DNS resolver, and that IP address will be forwarded to the end user and he can use that particular IP address to access that web service. So this is all about networking services. Now let us move on with the next service domain. The next service domain is security, and we are going to see about security and identity services here. Okay, there are three services which we are going to see right now. The first one is IAM, the second one is KMS, and the last one is Cognito. Okay, so what is AWS IAM? IAM is an identity and access management service. This will enable you to manage access across all the AWS services and resources securely. So what is an access management tool? So consider you own a website. So in that website, you need to provide different people who use your website different accesses. Okay, consider there are three main employees who use your website. The first one is the administrator of the website, the second one is the web developer, and the third one is a data scientist. So you have to give your root credentials to the admin, but not to the web developer or data scientist. But you have to provide the web development dashboard credentials to the web developer and the data analytics dashboard credentials to the data analyst or the data scientist. So you can use IAM to create user credentials and also remove unused or stale or unnecessary IAM user credentials. You can restrict the use of the AWS root account to only particular users, and also you could enable multi-factor authentication for all the users so that your website and your data is secure. Now let us see the next service. The next service is AWS Key Management Service. So thus the name Key Management Service, this service is used to create and manage keys and control the use of encryption across a wide range of AWS services and the applications which you have uploaded to the AWS infrastructure. So what a KMS does? First, let me tell you what you will do to secure your data. So you have data and you're uploading it to the AWS infrastructure and you want to secure it. So you create an encryption key for that data. But what will happen if that encryption key is stolen and used? So to provide encryption for that encryption key, you can use CMKs or customer management keys. CMKs are used to encrypt your encryption keys which holds the encrypted data. So you can use CMKs and also enable policies that would use your CMKs and who cannot use your CMKs. So you can mention particular users who could use your customer management keys and the other users who cannot use the customer management keys. This would be very helpful in securing your website. You can also use CMKs to protect your data, but mainly CMKs are used to create encryption for the encryption keys. Now let us move on to the next service. Amazon Cognito is the next service. Amazon Cognito lets you add user sign up, sign in and access control to your web and mobile app quickly and easily. This is mainly designed for developers who want to add user access management to their applications and sync it. So what basically happens here? In Amazon Cognito, there are two pools, user pools and identity pools. So what are user pools and identity pools? User pools is an user directory which provides sign up or sign in options for website or mobile applications users. And identity pools provide AWS credentials to grant your user access to other AWS services. So basically what you do is you use Cognito to take the identity credentials from other third-party providers like Amazon.coms or Facebook's or Google's, and Cognito is the middleman who authenticates the user's credibility to use AWS services. And if the user's encryption keys are checked and are verified, then the permissions will be provided to the user who could use the permissions to log on to the AWS console and use AWS services. I hope you understood security services. Let us move on to the next service domain. The next service domain is management, and under management we will be looking at services like AWS CloudFormation, AWS OpsWorks, Autoscaling, CloudTrail and CloudWatch. The first service is CloudFormation. AWS CloudFormation provides a common language for you to describe and provision all the infrastructure resources in your cloud environment. In simple terms, AWS CloudFormation lets developers and businesses create a collection of AWS resources and services and provision them in an predictable and in the same order in which they want the services or resources to execute. So what is made possible by CloudFormation? Using CloudFormation, you could create a repeated task into a single task which you can use multiple times by just writing a simple code. So what basically happens is you create a code from scratch, or you can use available templates which is already provided by AWS, and then you could code locally or upload it to the S3 bucket. And after that, you can use CloudFormations using the GUI which AWS provides, or you could use command line interface of AWS to create a stack-based application using your template code or using the template which is already provided by AWS. And finally, AWS CloudFormation provisions and configures the resources you have specified on your template. Whichever the resources you have specified on your template, and in the same order, the resources will be provisioned and configured. Using CloudFormation is as simple as creating an EC2 instance. Now let us see the next service. AWS OpsWorks is a configuration management service. OpsWorks provides managed instances of Chef and Puppet. So what are Chef and Puppet? They are automation platforms that allow you to use code to automate the server configurations of your application. Also, what are OpsWorks stacks? OpsWorks stacks lets you manage application and servers on AWS and on-premises infrastructure, so that you can design your application with different layers. That is, you can provide stacks of databases, load balancers, and servers as per your wish. That is, each layer of the OpsWorks stack is a different AWS service. Now moving on with the next service. AWS Autoscaling is the next service. Autoscaling monitors your applications and automatically adjusts capacity to maintain steady, predictable performance at the lowest possible cost. So in the simplest terms, autoscaling basically monitors your website's traffic, and when it increases the hardware components it requires, and while the traffic decreases, it decreases the hardware components which is required. Let me provide you a simple example. A company XYZ uses 4 servers and 4 databases for their website, and suddenly there is a peak of traffic in Monday and they require 10 servers and 10 databases. So what they basically do is they try to purchase 6 more servers and databases and install in their on-premise setup. But after Monday, for all the 6 days of the week, they will not be having any traffic and all those servers will be idle, and that will be a huge waste of cost and time. Instead of that, they can opt for AWS Autoscaling, which will only cost you for the servers and the databases or any hardware components you are using currently. And when your traffic increases, it increases your servers and databases needed, and while it decreases, it also decreases your servers and databases needed, and only the particular servers which are used currently will be taken into account. And also AWS Autoscaling provides you with 2 different scaling methods. One is vertical scaling and another one is horizontal scaling. Vertical scaling is nothing but when there is an increase in the users, the server components will be automatically increasing with that. And horizontal scaling is said, and right now vertical scaling is that the number of server components won't increase. Only the specifications or the configuration of the particular server or the database will increase. So for example, you own a server and a database which has a particular capacity, but when the number of users increase, instead of buying more servers and databases of the same configuration or specification, you tend to improve your servers and databases configuration by providing them with more hardware components. That's all is about AWS Autoscaling. Let us move on to the next service. AWS CloudTrail is the next service. CloudTrail is a web service that records activity made on your account and delivers log files to your Amazon S3 bucket. If you are using CloudTrail in your AWS account, you can log and continuously monitor and retain account activity related to actions across your AWS infrastructure. So basically you can check what are the services which have been used, who are the users who have used those, and how much amount of services have been used. And also you could store it in your S3 bucket as log files, and you can review the log files later for reporting it. Now let us move on to the next service. Next service is Amazon CloudWatch. CloudWatch is a monitoring and management service built for developers, system operators, and site reliability engineers, and also IT managers. CloudWatch is basically a monitoring service which you use for the AWS resources which you use, and also the applications which you have uploaded and are using in the AWS infrastructure. You could collect the log and metric data of your AWS resources and also the applications which you have uploaded and which is running on the AWS infrastructure, and then monitor your applications and your AWS resources using those collected metric data, and also use that metric data for further business use to add business value. CloudWatch lets your application run smoothly by providing you details of resource utilization and your application's health and performance. CloudWatch could be accessed using APIs, command line interfaces, and also the AWS Management Console. Let us move on with the next service domain. Now we have arrived to the final service domain, which is application services. In application services, we will be looking at three different services. The first one is SNS, the second one is SQS, and the last one is SES. Let us first see SNS. Amazon Simple Notification Service is a web service that enables applications, end users, and devices to instantly send and receive notifications from the cloud. Before telling you how SNS works, let me tell you who are publishers and subscribers. Publishers and subscribers are two clients who use SNS. Publishers are the people who send the message or the notification, and subscribers are the clients who receive or consume the notifications. So how does it work? Publisher sends or pushes the notification and it goes to the SNS topic and stores there. And SNS then filters a message according to the subscriber's needs. If a subscriber doesn't need or subscribe to a particular topic, he won't be sent that particular notification. And only the subscribers who have opted for that notification or that news will be sent that. So there could be n number of subscribers. It could be AWS Lambda, AWS SQS, and also an AWS SES, an email service. But why do people use SNS? SNS provides simple APIs which you could integrate with your applications and use SNS services. And also SNS is a push-based delivery system. So it is very easy for publishers to push their data into the SNS topic and continue to send the messages to the subscribers. Let us see the next service. The next service is Amazon Simple Queue Service. The Amazon Simple Queue Service is almost similar to the notification service, but there are few differences. The main difference is that SNS uses a push mechanism, and because of that, time critical messages are sent through that. And SQS uses a polling model to exchange messages for distributed applications. In SNS, we saw publishers and subscribers, and here the same is producer and consumer. Basically, the producer sends the message and the consumer receives the message, and in between that, a polling model is used that whenever a message is sent, only one message can be sent through the queue, and at a time only one message can be sent to a consumer or a subscriber. That's all about Amazon SQS. Now let us see the next service. The next service is Amazon Simple Email Service. So we all know what is an email. It is an electronic mail which we use to send messages through the internet. So SES does the same thing, but here it is a cloud-based email sending service designed to help people who market on the internet and also application developers to send their marketing notifications and transactional emails or bulk amount of emails to the recipient. So how does it work? So the sender sends the email. A single email also can be sent, or a multiple number of emails. And first it goes to the SES, the simple email service, then pushes the data or the email to the receiver's ISP, the internet service provider. And finally, that ISP will provide the email to the recipient. It is a simple working method which could be easily understood. That's all about application services. Now let us move on. Now we have come to the part of Amazon's pricing models. Okay, come on, let us look into it. So AWS provides three types of pricing options. The first pricing option is pay as you go or pay per use. The second pricing option is save when you reserve. And the last one is pay less by using more. Let us see pay as you go right now. So what is pay as you go or pay per use? So whenever you use a service or multiple services, you only have to pay for those particular services, not the whole infrastructure. So if you use a particular service, say as Amazon EC2 for 20 hours in a period of 2 months, you won't be charged the amount for 2 months. You will only be charged for 20 hours which you have used. That is very easy and cost effective for any business or a personal user. The second option is save when you reserve. You could always reserve instances in Amazon Web Services. By reserving instances, you have the ability to launch the amount of instances or the number of instances whenever you want until the period which you have reserved those particular EC2 or any instances. Also, when you reserve a particular number of instances, they are reserved for you so that you would get up to a 75% discount sometimes. And also, you could change the configuration of the reserved instances whenever you want. Now let us see what does pay less by using more means. So we all know when we go to a shopping mall and if we purchase a lot of products, we might get a discount more than we expect. So the same thing goes with AWS. Amazon Web Services provides you a lesser price or they provide you discounts when you use a lot of services. If you are provided with a 20% discount for using 100 instances of AWS resources, if you use 500 instances, you might be given more than 25 to 30% of discount. Now that's all about pricing options. Let us see the next topic. Next topic is free tier. AWS provides a free tier for a year. Also, the services are always free and available for anyone. If you create an AWS account right now and the moment you created, after that you have free services for next 12 months, but they have limitations. Also, you could use few software solutions as a free trial and check out whether which particular service or which particular software solution is suitable for your business needs. So also, AWS provides a free usage of Amazon EC2 up to 750 hours every month for 12 months. Also, the same goes with Amazon S3 and Amazon RDS. But Amazon DynamoDB is always free. You could use until you want to stop using AWS, and it is always free, and up to 25 GB of AWS DynamoDB storage space is given to you. Also, AWS provides you with a simple monthly calculator. This can be used to calculate the amount of expenses which you have spent on particular services and finally add them up. Using this calculator is very simple and they have provided all the options and all the documentations and blocks you need to start with this. So if you are an AWS user, please check this simple monthly calculator so you could calculate all your expenses. Okay guys, we've seen a lot of theory concepts till now and let us see a practical concept. That is, we are going to create a demo and host it on AWS. We are going to do a hands-on right now. And what is going to be the use case? The use case is very simple. We are going to host a website and which it can upload and download files which can be either PDF, docs or image files. And also using Amazon Web Services, we are going to create the databases and storage buckets to upload the files. Before going inside the project, let me give you a brief explanation of how we are going to do this. So there is a user who enters an URL or an address inside his URL locator bar in his browser. So our website will be loaded there and we can use that website to upload files to the file server and database and also download it back. Let me show you how our application works. Okay, so this is the application which I have created. So you can use this application to upload a file and also check whether that available file is there. Okay, so to give you a small example, let me upload this file number 2 here. I'm opening it and I'm uploading it. So the file has been uploaded successfully. That is, it has been uploaded to the database. And in the download page, you can see number2.pdf and its size and the download numbers and also download and uploads location available. Also, I can download these files. See, and this downloaded file will be stored inside the uploads file inside the demo. We all know that in XAMPP server, any projects folder will be inside htdocs, and here inside htdocs I have created a folder called uploads and I have given that path in order to store these files. Let me show you whether it is available in the database or not. Okay, so I have used the root credentials to come inside, and I have used the database which I've created, which is upload, and also I have selected the star from files, which is showing the last time which I tried. So right now I'm going to try it again, and here you can see the updated one. So this is the basic functionality of a application, and let me explain the code a little bit. Okay, so this is the main page, this is the index.php, and I am linking filelogic.php here. Also, it contains a simple form with a type file and also a submit button. So while you press the submit button, which has the name save has been taken because I've given method is equal to post there. So save will be taken and this code will run. So what it basically does is it takes the file name, it takes the file size, it allows PDF or docs or JPG extensions. You can also upload zip files. Also, it doesn't let files to be larger than 1 MB. And then it uploads to the file to the destination path. So here we are using a SQL query, which is we are uploading name, size, the download and location. Also, the values are $file name, $size, 0 and upload/file name. It is 0 because initially the downloads value is 0. Also, if it is uploaded successfully, we'll get the message file uploaded successfully. If it is not, we'll get file failed to upload file. And this is for the download part. So the file ID is taken and select start from files where ID is equal to $ID. So a particular ID of that SQL database tables will be taken, and from that table files, if my file's ID is 1 and I want to download that will be downloaded here. And it takes a file path. If the file exists, it automatically downloads it to this path with the file name and it updates the query. It also updates whenever you click on download, it will get uploaded and the downloads value will go up by 1. Let me show you the downloads file also. Downloads file is a simple table. It contains table headers as ID, file name, size, downloads, action and location, and it contains a for each loop. And in that for each loop, every time been made, it will get uploaded here. It will get updated by this. It takes this ID, name, size as the SQL files attribute names. Okay guys, before moving further with AWS, I'll show you the last time when I created a hosted site for the same application. So here it goes. My address is intellipaat.ml. So here you can see the same structure has been uploaded, and here you choose a file and you upload this, and the file has been uploaded successfully. You can see it in the download page, and you can also download it. So already there are 2 files existing in that. These files exist in the RDS instance of the AWS services. Also, it gets uploaded to the S3 bucket. Let me show you how to do this one by one. Open your AWS Management Console first of all. Okay, so I have already logged into my account, and this is my account. So the first thing we are going to do is launch an EC2 instance. Also, we are going to create an RDS instance. It is a database instance. Then after that, we will create an S3 bucket to upload our files there. Let us start with creating an EC2 instance and connecting it. Okay, now there are 0 running instances. Let us launch our first instance. So I'm going to choose the AMI as Ubuntu server because I'm going to run my files on Ubuntu. Then this is a demo, let us choose free tier eligible. Always choose free tier eligible options because this is just a demo. So for testing, that is more than enough. So this is configuring instance details, and here they are creating there is already a default VPC available, a virtual private cloud. And then we are moving further and adding storage. The size is 8 GB and that is more than enough, and it is root. Then adding tags are not required, and configuring the security group. We are creating a new security group here. So also we can add a custom rule so that we are going to launch it on the browser with that IP address. So for that to run here without the firewall intervening, we have to create an anywhere for the port range 80. And now let us review it and launch it. just check it once and launch. And also you have to create key pairs. That is, if you don't have an existing key pair, you have to create a new one. So key pairs are basically you will be provided a private key which will match with this public keys, and after that the encryption will be decrypted and you will be allowed access to this. So let me give you the name for this key pair, and I'm giving it as Intellipaat. So I'm downloading the key pair and keeping it right there. Okay. So I'm launching the instances now. So this is going to take around 2-3 minutes. So let us check the other things. So go to this folder where this is available and check the folder where it is available, and it should be accessible for you, because if you lose this file, you're going to lose your entire EC2 instance and your data on it. Okay guys, now the instance is running, and now let us create a .ppk file for PuTTY, because PuTTY doesn't accept PEM files. So I already explained why we use these files. They have a public key and we will be given a private key, and private key will be used to decrypt the public key so that we get access to it. So let us load our PEM file here. So the PEM file is available in downloads. Okay, so in downloads files you can see it, but instead of ppk you have to give it as all files, so that, and you can search it here. Okay, so here the file is, and we are going to open this, and Region takes it and just give OK, and it is going to convert this file into a ppk file. So you save this private key and save it in a place which you can access very easily. So without this you cannot access your EC2 instances. So I'm going to store this ppk file here, and I'm going to name it as the same name as I gave for the PEM file. So I saved it and I'm closing it. So it's still running. So now we are going to connect this instance. So to connect this instance, what we have to do? We have to take this IP address. So first let me run and show you. So it won't connect because the EC2 instance is not running. So let me connect the EC2 instance. So you have to give this particular public IP here, and after providing the public IP, we have to upload this ppk file here. So after that, just give open, and you will receive a PuTTY terminal and give AS. So they'll ask login as, and the common ID for this is, username for this is Ubuntu. And right now you're logged into a Ubuntu instance, a Ubuntu EC2 instance. So right now, first thing we have to do is we have to update this instance. Okay, after updating, we have to install a web server called Apache 2. So we are installing Apache 2 right now. We are using Apache 2 to run our PHP files in this Ubuntu server. So this is the way to do it. And always provide sudo in front of your commands so that it takes the admin permissions here. Okay, so it has been uploaded. So let me show you the example right now. So I'm going to take this again and paste it here. And now you can see file running here. This file is index.html, which is inside the Apache 2 folder in Ubuntu EC2 instance. So we are going to change this file into our PHP file. So let me show you how to do that. So let us go back to the root folder, and right now we are in the root folder, and there is a file called where, and we have to proceed into that. So where, and here there will be a file called www. So, and then here there is a file called html, and here we can see index.html. So what we are going to do is we are going to upload our files here instead of index.html and making our file run. So let me do that first. But before trying to do that, we have to install PHP first. So to install PHP, you have to give this. And also you have to check what version you're going to use. If you have used PHP 7.2 in your local host, please download the same file here and install it. Now we have installed PHP 7.2, and after that we also have to install PHP's Apache 2 library. So to install that, we need this commands, and also we have to install MySQL, which supports PHP 7.2 in Ubuntu. So we're going to paste that here, and these are the commands. And also you have to make this PHP to PHP 7.2 so that PHP 7.2's MySQL APIs are downloaded, and hit the enter button. Okay, now all the required installations are done. So right now we are going to upload our files into this particular path, and after that we are going to remove index.html and then run our index.php file in this. So how to do that? First you have to open a text editor. So you have opened this. Now we have opened the index.php file here. So what we are going to do is we are going to copy the file content from our local host, the file content which we have used. But I have made a slight change here because instead of 3 files, I have used 2 files here. So my file contents are available here. So I'm going to open this and see I have reduced the file content to 2 files, and I have just implemented, instead of calling file logic, I have implemented the file logic inside index.php and inside downloads.php. So what I'm going to do is I'm going to copy all of this file content and I'm going to paste it in the EC2 instance. So I have pasted now. So I'm giving Ctrl O and then enter and Ctrl X. And after that I have to create the downloads file. And inside the downloads file, again I'm going to do the same thing. I'm going to open the downloads file, copy the content and paste it inside, and Ctrl O, enter, Ctrl X. So we have done this. So after that also we have to create a directory uploads, because we are using an upload files and an upload files path in order to save our files in that. So we are going to create a folder called upload. After that we are also going to create a folder called AWS, because we have to implement all the AWS API keys here. So let me explain you what is AWS APIs for PHP. Okay, so AWS PHP API. So AWS SDK for PHP, and what we have to do is download this AWS PHP's zip file, and what we are going to do is we are going to curl it there. I've created the AWS file, so I'm going to go inside the AWS directory, and here I'm going to curl this link. To curl it, you have to provide this particular attribute, and also you have to provide the file which this particular zip file is going to be available in. So now the file's download has been completed, and now you can see an aws.zip file. So to unzip this, you also have to download and install a software called Unzip. So now Unzip has been installed, so you can use Unzip. Okay, we've used Unzip to unzip all the contents from that aws.zip file, and here you can see all the available content. We are going to use this content to inside our PHP code. We are going to use this AWS PHP API keys, and we are going to use these PHP files and the AWS PHP SDKs to build our code. Now let me go out of this. Okay, so now we have everything we need. We have the AWS folder with all the AWS PHP SDKs, and we have the downloads.php file, the index.php file, also the uploads folder where the uploaded files are going to be uploaded. Now to proceed with this, we have to create an RDS instance and an S3 bucket. We have included that in this PHP files code in order to upload it to the S3 bucket and the downloads folder. Let me show you how to do that. I have come again inside this AWS Management Console, and right now I'm going to choose the service RDS. So I'm going to RDS. So there is no DB instances running currently. So we are going to create a database. We are choosing MySQL because we are using MySQL in our local host. And also we are enabling only options which are used for free usage tier. So I'm providing next. So it has to be t2.micro so that free tier is enabled. So I'm going to provide identifier as MySQL instance. My master username is going to be Intellipaat, and my master password is going to be Intellipaat123 and Intellipaat123. So next. So now I'm creating a new VPC security group here, and I'm not preferring anything here. So this is not that much important. So right now what we have to do is we have to give our database a name. So I've given the same name as the database which you have created in the localhost as upload. And after that, I'm going to remove this thing because we don't need snapshots in our AWS Management Console right now because this is just a demo. Okay, after checking everything, I'm going to create this database. So to create a database instance, it takes around 2 to 3 minutes. So let us create an S3 bucket in the same time. I'm going to open S3 here. And after opening S3, we are going to create an S3 bucket named Intellipaat. You can see here already there are two buckets available. So what I'm going to do is I'm going to delete this bucket. So what we are going to do now is we are going to create a new bucket. I'm giving the bucket's name as Intellipaat2, and after that I'm providing next. And also we don't need to see this that much because we don't need a tag. Also make sure all of these are checked and then give next. And after that, if you want to review it once, review it and then provide create bucket. But before that, I'm changing my region to Virginia because each region in this AWS Management Console has a different code. So I have used North Virginia's code here, so I'm going to use this. So I'm providing next. So now I'm going to create the bucket. See, now bucket Intellipaat2 has been created successfully. So you can see here a bucket has been created. Also here, I think MySQL database will be running. So it is still in the creation process. So let us wait for some more time. Okay, now our database instance is available. So what we are going to do is, so I'm going to use this endpoint in order to connect with the database. So now I'm going to the EC2 instance and let me see. So downloads.php, index.html, index.php and uploads and AWS directories and files are there. So what I'm going to do is I'm going to open index.php. So what I'm going to do here is I'm going to copy this particular and paste my code, paste my endpoint. So I have pasted my endpoint here. We're going to use this endpoint for this MySQL instance to connect with our database. So what I'm going to do is I'm going to edit the code according to this. So I'm going to close all the unwanted files here, and I'm going to keep only these two files. So this is the endpoint of the previous RDS instance which I used. So I'm going to change it with the current RDS instance, and I provided my username as Intellipaat, and my password as Intellipaat123, and my database name is upload. So I'm going to use the same thing. So I have put it here, and also I'll also explain the S3 code while I'm doing it. So right now we'll do only this. So here also we have to change it because I'm connecting with the database instance twice. So I have changed the code here also. So what we are going to do right now is we're going to remove the index.php files, create a new index.php file which has the current instance. So I'm going to copy this and paste it here. Control O. After that, I'm going to now create the downloads file. And then once again, first remove the downloads file and then clear. So I'm removing the downloads file first. So after that, I'm opening again a downloads file. After creating a new downloads file, I'm going to paste that edited code here, and I'm going to save it and close this. So now we have both the files which we require. Also, we have created the S3 buckets name as Intellipaat2 because my S3 code has the Intellipaat's file name as Intellipaat2 here. So now let me explain you what happens here. So when the submit button is clicked and save is off, so here the file name is taken, the destination path is taken, and what is this? This is the AWS autoloader.php which we require to run PHP files using S3 buckets, because to connect both S3 and PHP we need these APIs and PHP files. So also here we are creating a new S3 client and providing its region, its version, and also the security credentials. And what I'm doing is I'm going to put an object inside the S3 bucket. So to put that object to that, we need three attributes. The one is bucket name, the second one is key, that is the file name which you have already mentioned, and the last one is the source file, the destination file. And this is the downloads code which I already explained to you. Okay, now let us move on. So what we are going to do right now is we are going to try to run it. So before that, we have not created any tables inside this new RDS instance which we have created. So how to connect your RDS instance with your local MySQL shell? Let me show you that. First of all, let me open the shell which I have opened the local database in. So this is the local database, and here you can see the database and the tables inside the database and the files which have been uploaded, or the entries which have been updated here. So to connect an RDS instance, the first thing you have to do is open another shell, and you have to use the same commands which you have used here as MySQL and the username and the password. You have to use the same thing there, but two attributes will be included there. The first one is port number and the second one is endpoint.
Just a quick info, guys. If you want to make a career in cloud and DevOps, then Intellipaat provides an advanced certification in cloud computing and DevOps by NICT Academy IIT Roorkee, and it is taught by IIT Roorkee professors and industry experts. This course is designed to help you upskill and land in your dream job. Now, let's continue with the session.
So let me show you how to do that. Open a new shell. So first it is MySQL, and my username which I've given for that RDS instance is Intellipaat, and the password I don't need to give it right now. I can give it later when I click on enter. And the port number is 3306, and you can see the port number over here. And the next field is endpoint. So I'm copying this endpoint value and I'm going here, and you have to give -h and paste it, and Right now you have to enter the password. The password which I entered was Intellipaat123, and I have given enter, and now I am logged into this RDS instance which I have created. So here you can see the databases which are available. So these are the databases which are available, and upload is the database which we have created while creating the RDS instance. So first thing we have to do right now is we have to create a table for this database. So first let us use this database. After using it, now we have to create a table. So to create a table, we have to use the same table and the same fields, the same attributes as how we created our local database. I have already told you how to create a table and also the query to how to create a table. So now let us create a table. So to create a table, we have to use the command create table and the table name, and after that we have to give the attribute. So instead of wasting time by typing all that, I already have it typed up over here. So let me just copy it and paste it over here. And we have created a table now. So let me show you the table. So there is a table files available, and it will be an empty set. So what we are going to do is we have already changed the code according to this endpoint. So if this RDS instance is running with this table available, so obviously the code which we have stored in the EC2 instance, the index.php or downloads.php will run. So let us try by running them. And we know how to run that. We have to go take its IP address and just paste it in the URL tab. So we know how to run the EC2 instance. We just have to take the EC2 instance IP address and paste it on the URL tab in the browser. So let us do it now and check whether the database and the S3 bucket is getting updated. And if we do that, our project is complete. Just we have to create a Route 53 hosted zone and host it online. So right now, let us see whether it's running or not. I'm just going to do. Okay, so now we can see our website is running over here, and this is the local one, and this is the EC2 instance website, the PHP file. So this is the index.php file. So right now, let me upload a file and show you how it works. So let me upload AWS 1, and I'm uploading it. And the file has been uploaded successfully. And let us go to the download page and check once. So here we are receiving it. So AWS 1, the size is 9 KB. It has been downloaded 0 times. Then the download button is over here, and also the location is provided. This location is the location which is in the EC2 instance. So right now let us check and confirm whether the data has been updated. Let me go to this. Now again I'm selecting start from files, and right now you can see an entry has been made because we have uploaded a file. So also let us check in the S3 bucket whether the file is uploaded there or not. Let me refresh it, and you can see here also the AWS 1 file has been updated here also. So our project's objective has been complete here. So what we have to do now is we have to create a Route 53 hosted zone in order to host our website online. So let us do that. Now you could say that our website is running completely on AWS services. Our websites in PHP files are running on EC2 instances, and our database is on RDS, and the storage bucket we are using S3. So now let us start with Route 53. So now we are going to start with Route 53, and before starting that, we will get a free domain. We will purchase a free domain in order to run our website on that particular domain. So to get a free domain, you could go to freenom.com and you could sign in this and you could get a free domain for yourself. I have signed in right now and I already have a domain available. But let me get a new domain so that I could show you how to do Route 53 and how to host our website online. So let me type the name which I want as the free domain. So I'm typing Intellipaat here and I'm giving enter. I have received multiple domain names for this name Intellipaat. So I'm going to go with intellipaat.tk. trying it now. I've selected it and I'm going to purchase it. So I'm going to go to checkout. This Intellipaat.tk domain name. So I'm going to use this domain name to host my IP address on that. So what I'm going to do is I'm going to first create a Route 53 hosted zones. So first I'm going to manage the domain here. So I'm going inside this domain and I'm going to the name server. So what we have to do is we have to create a Route 53 hosted zone and take the name servers which it provides, and we have to change the name servers over here. So that is what we are going to do. So let me show you how to create a Route 53 hosted zone. So we have opened the Route 53's homepage. So I already have a hosted zone which I created for this intellipaat.ml file, so domain name. So I'm going to create hosted zone for our intellipaat.tk. So I'm creating one. I'm providing my domain name, which is intellipaat.tk, and it has to be public hosted zone, and I'm going to create it. So you can see here you have two values. This is the name server value. So what we have to do is we have to copy this name server values and paste it over here. So we have to do that with every single name server. So there will be 4 name servers available. So we have to do that for each and every one. So I'm done pasting now. So also please remove that dot which is available here. So it is not actually required, and save the record. And right now we have to create 2 record sets so that our website, when we type intellipaat.tk, it should run. Also when you type www.intellipaat.tk, it should also run in the same time, because we are going to provide our IP address inside 2 created record sets. So the first record set is going to be intellipaat.tk, and it has to be IPv4 address, which is the type A, and you don't need to create any alias. What you have to do is you have to copy this IP address, paste it over here, and HTTP, it should not be there. It should be just the plain IP address. So what you have to do is just create it, and now create another zone, another record set, and provide www.intellipaat.tk and paste the same IP address here and create it. So we have given here, and right now we have to change the name servers here. So the intellipaat.tk domain is active now, and we have also created so that we redirected this IP address to this Route 53's values, that is to these domain names. We have redirected the IP address to these domain names. So whenever a person searches this domain name, the DNS resolver will check for this, and if it is not available, it will check to the Route 53. So if it is available in Route 53, it will give back the IP address so the user could use it. So now let us try whether our website is running or not. So in Route 53, for a website to get hosted, it will at least take 3 to 5 minutes. So if you're doing this right now and if your website is not hosted immediately, don't panic, because take some time and check it again. So now let us check whether intellipaat.tk is online or not. So I'm typing intellipaat.tk. So you can see here the website is running. Also you could check by providing www.intellipaat.tk, and the website runs now also. So let me upload one more file for your clarification. Let me upload it, and so it has been uploaded successfully, and I'm going to the download page, and you can see the 3.pdf file. Also you could check it here. The 3.pdf file has been updated. Also I'll show you whether it has been updated in the S3 bucket. So the S3 bucket has been updated with 3.pdf. So right now we have created a complete website by hosting it on using Route 53 and using S3 bucket to create a storage a bucket, and also we have used RDS to run MySQL on it. And finally, the first thing we did was creating an EC2 instance so that we could run this index.php and download.php files, so that you could use that IP address to create a website to host. And finally, we got a domain name and we hosted it. This is the complete demo, and this is the complete hands-on which we have done. I hope that you have understood all the concepts which I have explained here and all the 4 main AWS services which we have used. So now let me show you how this is layered, and finally we'll do a knowledge check by reviewing few questions which you have learned from this AWS tutorial. I'll be asking you a few questions and you have to answer them, and you could comment that down later. So right now let me show you how the layer has been implemented here. So you could see this. The user is you or me, and Route 53 is the DNS resolvers. So the user is you or me, or it could be anyone, and Route 53 is used to host that IP address using a domain name. So we did that right now and it got online immediately. So if it doesn't get online for you, just wait for some time and check it again. So after that, that Route 53 IP address redirects to the EC2 instance. So from the EC2 instance, to connect to the RDS and the S3 instances, we have to provide security credentials, and I showed the security credentials in the PHP code which I showed you in the beginning of the video. So using that, we are logging into the RDS instance and the S3 instance.
Alright guys, so moving forward now, let's go ahead and do some hands-on. So what I'm going to do is, let me first show you how you can create your account on AWS first. So let me just jump on to my browser. Alright guys, so the first thing that you would be doing is heading on to aws.amazon.com. Okay, so once you are on this website, you will see a big orange button over here which says create an AWS account, right? Just click on that and that will take you to the next screen wherein you will have to fill out your details. So fill out all your details over here, right? And once you have done that, let us enter some pseudo values. So let's say it's abc@intellipaat.com. Password, I can set anything over here. Similarly, I'll set anything over here. AWS account name, let's say it's Intellipaat-test, right? We'll click on continue. Then it will ask you what is the account type? Is it a professional account or it is a personal account? So we'll select personal account because we are just trying out AWS, right? So we want to use it for ourselves. Give some number. Let's say I give 1 2 3 4 5 6 7 8 9, and the country or region, you can select any region that you are in. Your address, the city that you are in, postal code. So let's say the city is Bangalore. State, let's say it's Karnataka. And once everything seems fine to you, just click create account and continue. Once you do this, you will reach this screen where you'll have to enter your debit card number or credit card number, right? Enter everything over here and click on secure submit. Once you've done that, the next page will ask you what kind of account do you want to create. Is it a business account or a standalone account? What purpose will you use this account for? It's all logical. You just know what you have to answer. Just remember this, you are creating a personal account and it's nowhere related to a business. Select everything, click on finish, and you will have a new AWS account created for you. Now, one awesome thing about AWS, guys, is that it will give you free tier. That is, you can launch instances free for 1 year, right? And every account that you create on AWS, or when you sign up on AWS, you'll get a 1 year free tier account where you can launch a certain EC2 instance for free, and that too for 750 hours a month. So 750 hours is actually 30 days, and that too for 1 year, right? So 1 year of free instances you can launch. So I'll show you guys how you can launch instances as well, but this is how you can sign up for AWS. So once you have signed up for AWS, guys, next thing would be to basically log in, right? And for that, you'll have to, once you go to aws.amazon.com, just click on AWS Management Console and it'll take you to the sign-in page. Okay. So on the sign-in page, just enter the email address through which you want to connect. 1 second, guys. So this would be the email address that I want to enter, followed by the password. And this will make you sign in into AWS. So this is a step that you should reach once you have completed your sign up. Okay. And now what I want to do is I want to launch my first server on AWS. Now, how will I do that? So we have studied about the EC2 instance, right? So for launching the EC2 instance, here is the domain. So the domain that we went through was compute. Right? So in compute, you have these many services. You have EC2, ECR, ECS, then you have Lambda, Elastic Beanstalk. There are other services as well. We have not touched those services because they would go beyond the scope of what we intend to do in this session. This session is an overview for AWS, for an AWS solutions architect, right? So the services that we have picked up, they're all the basic services that you should know about. And once you understand all those services, understanding the rest of AWS would be a cakewalk for you, right? So there are so many services in AWS. You have ground station, security hub, artifact. If you're into game development, then you have Amazon Game Lift. But all these services are basically confined to a certain kind of work that you want to do. Like, I am not going to develop a game, right? Or I'm not into gaming, or I'm not into game development. So this service is not for me. Similarly, there are IoT services that you have to know of, but IoT, not every company would use IoT, correct? Some companies would use IoT, and for you to learn the IoT service, it would be a waste of time for you, right? And that is why what we have done is we have picked up some services which are essential and which most of the organizations will use who are into IT and want their application up and ready. And we have just selected those applications, right? Or those services. Also, your AWS Solutions Architect exam would be confined to only these services that we are learning. Alright, now what we wanted to do was we want to launch our first server, and for that there is a service called EC2. So either you can find it under the domain compute, that is EC2 over here, or you also have an awesome option over here to search for any kind of service. Let's say I want to launch or I want to go to EC2, so I can just write EC2 in the search bar and I will get the respective result over here. Let's click on that, and now this link would basically open your EC2 dashboard. Right? So from here you can launch your first EC2 instance. There are a lot of options on the left, guys. Do not worry about each of these options. These are options that we will be studying about when we purposefully just talk about EC2 service, and that will be in the further sessions that we're going to have. For now, just understand how to launch an EC2 instance, and for that you just have to click on this blue button which is here, which says launch instance. Just click on that. Once you've clicked on launch instance, you will get an option to select the operating system that you want to run in your server, right? So there are a lot of operating systems to choose from. You have the Amazon Linux AMI, which is a custom Linux that AWS has created. Then you have Red Hat OS that you can run. You have SUSE Linux, you have Ubuntu. There are a host of operating systems that you can run from. You have Windows as well, right? So you choose whichever you want, and always ensure you choose an operating system which says free tier eligible, which would mean that it will fall under the free tier and it will not be charged for you. Okay. So let's say I select the Ubuntu server. I'll click on select, and now it will ask me what is the size of the server that you want. How much of CPUs do you want? How much of memory do you want? So the only server, so there are a lot of options over here to choose from. Right? But the only server that is free for you would be T2.micro, okay, which has 1 CPU and 1 GB of RAM, which is enough for demo purposes when you want to try out AWS. Okay, so you would select T2.micro if you want to be under the free tier and not be charged. So just select T2.micro. Next, you will click on next, and then it will ask you for all the details that are over here. Do not worry about anything, just leave them blank. Click on next. Next step would ask you for the hard drive storage. How much of hard drive storage do you want? So by default it's 8 GB when you're launching a Linux instance, so we leave it at default. If you want, you can change this, right? Then click on next. You can add tags over here. What are tags? Tags are nothing but metadata to your instance, right? Like for example, I can say the name. I can add a tag that the name of the instance is something, then the department to which this instance belongs to is this. So all those values I can write over here, and those will serve as a metadata for the instance, so that when somebody is searching for all the EC2 instances for, let's say, the IT department, they just have to type in department equal to IT and it will list all the instances. So for those kind of searches you have tags. Click on next, then it will give you the option of configuring your security group. What is a security group? It's nothing but a firewall. It's a very simple firewall, guys. In this, what you have to tell is, so basically all these rules that you can add over here, these are all inbound rules, right? So inbound means what kind of connections are allowed on this server. So there's a SSH connection which is allowed, right? So you can select the protocol that you want to allow on this server, right? So right now, what has been allowed is the SSH protocol, so that we can log into this server. SSH means that, right? If you select SSH, it will fill out all the details for protocol and port range by itself. Now, whom do you want the SSH protocol to be used by, right? If you want it to be accessed by anyone, you can just give anywhere. Why is this option helpful? This option is helpful when the IP address of your computer is not fixed. Let's say you can access this instance from office, but you also wanted to access it from home as well, right? So if you want to access it from home, then you have to select anywhere. If your IP address is not changing, you can select my IP, right? Let's say this is my IP address right now, and only I will be allowed to connect to this instance using the SSH protocol. But it's the generic use case that everyone deals with is that they want to log in from anywhere, right? So I'll select anywhere. It fills the data by itself. And now finally, I can just click on review and launch. So if you want to delete a rule, guys, since in this rule, I did not define anything, I can just delete this from here. And now let me click on review and launch. Okay, so now I can review all the settings that I've done. Once I feel everything is correct, I'll just click on launch. And this is a very important step, guys. Now, to log into any server which is there on the remote system, imagine like if somebody gets your IP address, anybody can access that server and they can make any change that they want, right? But it's obviously not like there's a security layer that we add, or which AWS has added to the servers that it launches. It gives you a key pair, right? What is a key pair? A key pair is nothing but it will give you a key that you will have to use while you're connecting to the instance. Okay, so as you can see, there's no key pair right now. So what I can do is I can create a new key pair. Let's name this key pair as, let's say, test-Intellipaat. Let's say this is the name, correct? I will click on download key pair. So unless I don't create a new key pair, this launch instance button will not be active. So this will download a PEM file for you. This is a file which is of the PEM extension, right? So this will be used to connect to our instance. And finally, when everything is set, let's click on launch instance. So now you can see your instances are now being launched. This is a message that you're getting. So I can just go to the instance and see that, okay, so there's an instance being launched. The instance state is pending, which means it's still in the launch process. I can give this instance a name. Let's call it test. Okay, and now it's in the running state. Great. So now once you have selected test, you can refer to all the details of test in the below panel. So here is the IP address which will be used to connect to it, right? The instance type, which is t2.micro, the state which is running, right? Then you have the security group. So view inbound rules, you can see there's a SSH rule that you have added over here, right? And then the next step would be that what is the key pair name for this instance? It's test Intellipaat, so on and so forth, right? Now that you have launched the instance, the next step is to connect to it. Now, when you want to connect to this instance, there's a software called Putty that you can download, right? So here's a software that I've already downloaded. If you want to download this, just search on Google for download Putty. You will get this link. Go to this link, right? Now guys, there are two things that you have to download. One is you have to download Putty, which you can use by clicking on this link. It will take you on this page. Just select, if you're on Windows, just select Putty 64-bit. Just click on it and it'll basically download the Putty software for you. The other thing that you'll have to download is Putty Gen, right? This is also required. I'll tell you why it is required. So this is basically Putty Gen, and the other software that you need is Putty. Okay. So once you have both the softwares in place and you have installed both the softwares, next step would be to connect to our instance. So this software of mine is Putty Gen. Let me launch it for you. This is Putty Gen, guys. The PEM file that you get, guys, if you have to use it with Putty, the way you can use it is by converting this PEM file first to PPK, because that is what your Putty software would accept, right? So first I'll have to load this file on my Putty Gen. So let us do that. So I'll click on load and then I'll select the PEM file, which is this. It says successfully imported. Great. Now I want to save the private key. If I save the private key over here, it will ask you, are you sure you want to save this key without a passphrase? Yes, right? And let's name this private key something. Let's name it, let's say, test. So as you can see, the format now is being changed to PPK. Great. Let's save the file. The file has been saved. Next step is launch your putty software. Right, this is my putty software. The instance that I want to connect is this. This is the IP address that I want to connect to. I'll mention it over here. Then I'll go to SSH. Because I've mentioned the IP address in the session part, now I also have to put the key using which I will connect, right? So for putting the key, you have to go into SSH, then you'll be clicking on auth. In auth, I have to select the PPK file which I created. So this is the file, test. Let's select that and let's click on open. So now it'll give you a message that this server host key is not cached in the repository. Just click on yes on this message. And now you will see the screen which says login as, right? So now since I was launching an Ubuntu instance, what I have to enter over here is Ubuntu. I'll hit enter and now it will verify the key that I inserted and it'll be able to connect to the putty, to the server that I created on AWS using the key that I put, right? And now I'm logged in on my server. Now I can do anything over here. I can install any software that I want. So this is how you can connect to an EC2 instance which has launched a Linux AMI or Linux OS. Okay, for connecting to Windows, guys, you do not get a PEM file. You do not get a PEM file. What you basically get is an RDP file along with the password. Okay, so you will be given the password, you will be given the username, you will be given a RDP file. So you select the RDP file and then it will ask you for the password. Just enter the password that was given to you by the AWS Management Console. You click on connect and then you will be able to launch a Windows instance. So there are only two types of OS that you can launch on AWS. One is Linux, second is Windows. So I told you how to connect to Linux instances. Let me also walk you through how to connect to a Windows machine. Alright guys, so now in order to launch a Windows instance, again we'll just click on launch instance. Let's select a Windows OS which is free tier eligible. Let's select this. Right, t2.micro is the instance that we want to launch. Let's click on next. Let's leave everything at default. Let's click on next. Here you can see the default size is 30 GB because in Windows it takes a lot of space. So it's 30 GB over here. Let's click on next. Configure the security group. Here you can see that instead of SSH you have RDP, right? Because for Linux instance, because it's a command line, what you do is you collect through SSH. But because Windows is a GUI based OS, you have to connect through RDP. All right. So we'll click on review and launch. And now we'll select the same key pair which was there. And let's click on launch instances. So our instance is now launched, guys. We can just go here and we can see it's in the pending state. All right. So let's name this instance as Windows. All right. And now in order to connect to it, this is the IP address that you get. Now just click on actions. So select the machine that you have to connect with. Once it's launched, you'd be able to click on actions and you'd be able to click on connect. So in the connect, so when you click on connect, you will get all the options of how to basically connect to this particular server. So let's wait for this instance to be in the running state and then let's review. Okay, so the instance is now in the running state, guys. Now let's click on actions. Let's click on connect. And this is basically the way to connect to it. You can download the RDP file by clicking over here. So as you can see, I got the RDP file. The username is administrator. And if I click on get password, it says password not available yet. Please wait at least 4 minutes after launching an instance. Okay, so the password will be available once the instance is 4 minutes since launch. But this is the way you get the password. Okay, now if I click on the RDP file, it will directly give me this kind of a window where it will say, are you sure you want to connect to it? Let's click on connect. And now it is asking for the password. So all you have to do now is wait for the password to be available over here. Right. And once the instance is ready, you'll get the password here. Once you have the password, just put the password over here, click on OK, and you should be able to connect to your Windows instance. So let's give it the time. Let's wait for this instance to get in the running or in the password state. And then we'll just enter the password here and click on OK. And let's see how it goes. Alright guys, so let's try now. So I just click on actions. I click on get Windows password. I get this page. Now what I have to do is I have to choose the key pair path. So in this PEM file will work. So I'll just enter the test intellipaat.pem. Remember, the PEM file will work and not the PPK. Let's click on open, and now let's click on decrypt password. So guys, this is the password for connecting to my instance. Let's copy it, go to our instance, let's paste it over here, and now let's click on OK. Now it says the identity of the remote computer cannot be verified. It's okay, just click on yes, and now you should be able to connect to your server. So here you go guys, here is a server launched on AWS for you. It's a fresh server. You can do anything that you want on this, right? You can install any kind of tool on this. You can make it a database server, make it a web server. You can make this server anything. Okay. So guys, this is how you can connect to a Windows instance. I've showed you how you can connect to a Linux instance as well, right? This also, you can install any software on this server and it can become anything for you, right? Now, let's go ahead and come back to our slides. Alright guys, so I've showed you how you can connect to an EC2 instance. We got to know how to connect to a Linux instance. We got to know how to connect to a Windows instance, right? And let's talk about the other services as well. So let me come back to my dashboard. So like I told you guys, EC2 is an infrastructure as a service where you get access to the operating system, right? Now there is a service called Elastic Beanstalk and there's a service called Lambda. Let's look at Elastic Beanstalk. How is the dashboard look for Elastic Beanstalk? Right. So as you can see, it says welcome to AWS Elastic Beanstalk, and it says just select a platform, upload an application and run it. That's it. You don't have to connect through SSH to that instance in order to install the software and get your application ready, right? So as you can see, when I said get started, it gives me create a web app, right? So you can only create a web application here. It will not act as your backend server, right? It can only host application. So let's give it an application name. Let's say it's test. Okay. And then let's choose a platform. What do I want that software or that web app to run? So I can put my web app in .NET, I can put my web app in Go, I can put my web app in PHP. It's all my choice. So let's click on PHP, right? And the application code, let's have the sample application first. And now let's click on create application. So these were all the settings that you had to do, guys, nothing much, right? And now it will start to create your Elastic Beanstalk. It will not give you an access to the operating system. Remember this, guys, you will not get an access to the operating system. All you will get is a dashboard on which you can upload your website and it will be hosted for you. When I created the EC2 server, I could not do anything on it. I had to install the software, then I had to put my application on it, and only then I'll be able to access it. But in this case, everything is done automatically. I can just upload my code and that's it. All right. So let's wait for this to be ready and then we'll go forward. Alright guys, so as you can see, my Elastic Beanstalk is now ready. And now if I go to this particular URL, which Elastic Beanstalk has given me, you'll be able to see the web app, right? This is a sample application which has been deployed. I can click on upload and deploy, and just I have to choose a file, click on deploy, and that website will get deployed automatically over here. I will just go to this link, refresh it, and my website will be visible over there. So I guess now you know when I said that you just get an access to a dashboard, you're actually not getting an access to the whole operating system, right? You do not have a control on that. All right, let us look at Lambda as well. So let's see what happens if I click on Lambda. All right, so when I click on Lambda, guys, this is the dashboard that you get. And as you can see, it just says run. So if I run it, it says hello world, right? You just have to enter the code here. It will give you the output. That's all what Lambda is. It will not host your application. It can just give you textual outputs in the form of JSON or in the form of textual content. It can just give you that. Okay. Now, if I change something over here, let's make it hello world 123. If I run it, it says hello run world 123. So if you want to create a function, just click on create a function over here. Author from scratch, use a blueprint, browse serverless app repository. You can just see if there's any code that you want to take from what has been done before. You can do it from here, that browse serverless app repository, use a blueprint. Here you have a lot of blueprints which most of the companies use, right? So you don't have to write the whole code from scratch. You can just click the blueprint that you want. For example, it's a microservice HTTP endpoint. That is, you just have to hit on the API and it'll give you the result. If that is the kind of Lambda function you want, you can also do that, right? Then you have kinesis, fire assist log to JSON. There are a lot of things over here. Don't get confused with all the jargons used over here, right? This you will be able to get once you have a hang of all the services in AWS, which we will teach you in the upcoming sessions, right? For now, you just understand what Lambda does, right? Lambda, you give the code, it will run the code. That is it. It will not host an application. Elastic Beanstalk, it will host the application for you. And EC2, you can do anything. You can also configure your EC2 server to basically become AWS Lambda, but you'll have to manually install all the softwares and then you'll be able to do that job. So I guess, hope guys that you are now clear with the basic services of the compute domain of AWS, that is EC2, Elastic Beanstalk, Lambda. Auto-scaling and load balancing, we will do it as we move along in the sessions because that requires you to know a little bit more, right? So let's move on and come back to our PPTs and let's start with our next domain now. Alright guys, so our next domain is the storage domain in AWS, and let's see what all services do we have in the storage domain. So guys, these are the important services that we have in the storage domain of AWS. Our first service is Amazon S3, then we have Amazon Glacier, Amazon EFS, and AWS Storage Gateway. So let's look at these services one by one and understand what they do. So guys, S3 is an object storage service, which basically means that all the files which are uploaded on the S3, they are basically regarded as objects. Objects for us as layman users, they don't differ much. I mean, you won't see the difference in terms of when you're using the file or downloading the file that, you know, it was a file before and now it's an object. Object basically is at the back end, that is how you store a file, is in the form of an object, right? So it's basically on the infrastructure side that it makes a difference, that each file in an S3 bucket acts as an object, right? Now, why do we use S3? Why do we need a storage service, right? Is because, like we have discussed previously, that we need distributed systems on an application. The more distributed it is, the more fault tolerant it becomes. When I say fault tolerant, basically it can tolerate faults in its nodes. Each node in the application, whether it be the storage node, the compute node, it could be the backend compute node, the database node, each of these nodes, if they fail, right, it can tolerate that failure in your application, can still be working. Okay, so Amazon S3 is a file storage system by AWS, which says that it will give you the availability of 99.99% times. That means only there's a 0.01% probability that, you know, your service is going to fail. Otherwise 99.99, it's actually not 99.99, it's 99.9999, 4 times 9, right? That is the kind of availability that AWS guarantees that your object will have. And obviously you can increase this SLA, this basically called a SLA, service level agreement, that what kind of service will AWS provide to you. You can further increase this SLA by providing redundancies, by using certain techniques wherein you can take a backup of your bucket at every 24 hours, so that if there is a data corruption, you can always get that data back, you know, from the vaults and then store it back again in the bucket. But that is only when you have failure in the S3 service, and for that I told you the probability is 0.0001%. Okay, that is the kind of service that AWS provides. So you can be rest assured that if you want to host files on AWS, if you host it on S3, your files will be available pretty much all the time, right? That is what you have S3 for. Now, what are the common use cases where you will be using AWS S3? You can imagine it like this, that if there is a website wherein the logo is there, if there are certain images on that website that have to be loaded at the time of a web page reload, all those images will be taken from S3 and will be presented over there, right? So rather than storing all these files on the server on which the website exists, you can store all these files, all these images on S3, and then you can just get it from there, right? S3 also provides you the facility of hosting static web files, right? So you can host a website also by using an S3 bucket, and all you have to do is enable static hosting on that bucket and you will be able to host static websites in that case. Alright, our next service, guys, is AWS Glacier. So AWS Glacier is an extended version of the S3 service, which is the Glacier does not give you a direct access to itself. It basically takes a backup of the S3 service. So let's say you created a folder in S3. So folders in S3 are basically called buckets, right? The root folder in S3 is called bucket. So if you have a bucket and you have a lot of files inside that bucket, and if you want to take a backup of all those files, you can take it using the Glacier service in AWS, right? And Glacier service, the reason we have two services over here, the reason for that is that S3, you can get the objects instantaneously. The moment you put the link of the object, you can download it, right? You can access it. But when we talk about Glacier, it takes time for the object to be retrieved. It takes times in hours, sometimes 2 or 3 hours to retrieve a file in Amazon, right? So that is the kind of service that Glacier is, and it's a backup service and it's also cheap. So the main difference between S3 and Glacier is that if you are taking a backup in Glacier, it'll be very, very cheap. I think it'll be 1/10 of the cost of the same size of files which exist on Amazon S3. The reason for that is Glacier is strictly a backup service, and because it is low priced, because of that there are some compromises in its performance, wherein the time to retrieve the object, it takes time, right? It takes 2-3 hours to retrieve an object in Amazon Glacier. When you compare it with Amazon S3, it's instantaneously, and that is why even the price is higher on the S3 service. More about pricing we'll talk as we move along in the session, right? But right now it is very important to understand the functionalities of these services, right? So why do we use AWS S3? For hosting our files, and those files can then be retrieved on whatever application we want. It's basically anywhere on the internet. If you put that link, you will be able to download that file. So that is what AWS S3 is for you. If you want to take a backup of AWS S3, then you can use AWS S3 Glacier, which will help you to take backup of any buckets or files which are there in your S3 inside it, right? After Glacier, guys, the other service that we're going to discuss is EFS. So what is EFS? EFS service is again a storage service, but it's different from S3. How is it different from S3? That EFS service can be mounted on your operating system as a volume, right? Isn't that interesting? So you can mount Amazon EFS as a volume on any computer on the AWS network, right? So let's say you launch a server of Windows on AWS and you feel that you need a network drive. If you guys have worked with network drives, then EFS is exactly a network drive. It mimics the usage of a network drive, right? And it's also scalable. That means the size increases as and when you need it, right? So that is scalable. It can be attached to multiple computers. That is, it can serve you as a shared drive. That is, there could be tens or hundreds of computers which have the same volume inside them, and that same volume would be EFS for you. So how does that help? That helps when you have a scalable architecture, where there are 7 or 8 systems, and whatever changes one system is doing, that has to be seen by the other system as well. So in those kind of cases, you use EFS, wherein they will have a common drive on which the data will change dynamically. No matter which server is changing it, all the changes will be available on the other servers as well. And that is what EFS is for you guys, right? So EFS can be mounted on Windows machine. It can also be mounted on Linux machines. And the way you use it is, I just told you, it acts as a shared drive. And where do you use it? You use it where you want shared data between multiple servers which are working in an architecture. All right. So that is what EFS is for you guys. Then our next service is AWS Storage Gateway. So it basically helps you to connect an on-premises system to the AWS cloud infrastructure. So if there is any storage application which is there on your on-premise systems and you want it to be connected to the AWS infrastructure, you will be using the AWS Storage Gateway service. All right. So guys, this was all about the storage domain in AWS. Let us quickly jump on to our AWS Management Console. So I'll show you a few of the services in AWS that ways. So let me jump on to my Management Console. All right, guys. So here I am on my Management Console. The first service that we discussed was under storage, which was S3. So let's click on the S3 link, and that will give you UI which will look something like this. So I have some buckets already configured. You can create a new bucket. So like I said, bucket is nothing but the root folder where you put all your files, right? So let's say the bucket name is test-Intellipaat, right? This is the bucket name. Then the region that I want to put this is, let's say I want to put it in Oregon region, and that's it. Let's click on next and keep all versions of an object in the same bucket. Leave everything at default. Just click on next.
Just a quick info, guys. If you want to make a career in cloud and DevOps, then Intellipaat provides an advanced certification in cloud computing and DevOps by NICT Academy IIT Roorkee, and it is taught by IIT Roorkee professors and industry experts. This course is designed to help you upskill and land in your dream job. Now, let's continue with the session.
Leave everything at default, and now let's just click on create bucket. Alright, so my bucket is now created. I can go inside this bucket and I can upload files over here. Let's try to upload a file. Let's click on upload. Let's click on add files. Let's go to pictures and then let's try to upload something. Let's go to documents. Let's say I want to upload a file, and let's say I upload this particular file. Okay, so this is the file that I want to upload. I'll just click on next. It will now upload it. Click on next again. Here are the so this is basically the types of classes that you can access, right? Do you want to access, put it in S3, you want to archive the data, put it in Glacier, all those you can do. Let's click on next and click on upload. So right now we have not changed any setting in S3, right? We are just uploading an object, and as you can see, my file is now uploaded over here. Right now, if I select this file, I can actually see the properties of this file via this link. Right, here's an object URL that you get. If I click on this object URL, it will say access denied. Why access denied? Because first I have to make that object as public. So for that, what I have to do is I'll be going into properties, right? And over here, I will go to permissions, and then I will go into public access, right? So right now it says you can't grant public access because block public access settings are turned on. Let's go ahead and remove those things. So I'll just go to Amazon S3, click on the bucket, and then let us click on permissions. And in this permission, I want to edit block all public access. I've done that. Let's save this thing. And to confirm these settings, just type confirm, hit and confirm, and my settings are now done. Now let's go back to overview. This is my object, right? And if I refresh this, it says still there's access denied. Now what I'll do is I'll go to permissions, and now I'll give public access. So I want to give read object to everyone. Let's click save. Now, if I go to the website, hit refresh, I can see the image over here. Now, this link, anybody who has access to this link will be able to see this image. So you can also embed this link in your website, and you will be able to load that page on your website just like that, right? So this is what the link does. This is what the link is all about. So if you upload an object, guys, and you want to make it public, just go to the permissions of that particular object, make it as yes, and you're set. All right. So this is how you can read from S3. All right, guys. So now let's start off with EFS. So I'll just click on the EFS service on my AWS Management Console. I will reach this page where I will have an option to create a file system. Let's click on that. And now it will ask me for the VPC that I want my EFS to be created in. Now remember, guys, the VPC that you select here should be the same as the instances on which you want to mount the EFS volume. So right now it's VPC 4B58233. Let's click on next step. Right, leave everything at default, guys. Don't touch anything else. Let's create the file system now. Alright, guys, so my file system is now being created. Now remember, guys, the security groups that are attached to this particular EFS drive has to be the same as well for your EC2 instances. Okay, so how to check which security group is this EFS drive mounted on? You can check that by You can check it over here in this table. So right now it is in creating state. So once it is available, you will have the security groups listed over here. Okay. Now, since my EFS is going to take some time to set up, let me show you the instances that I've launched. So I have two instances. One is Ubuntu and the other is Ubuntu 2. I'm going to mount the same EFS volume, which I've created over here, to basically connect to these two instances, right? Now, how to do that? First, I will click on, let's connect to our Ubuntu instance. Let's connect to this Ubuntu instance first. So this is the IP address, and I guess I've already connected to this IP address, 172.31.51.195. This is the private IP address for the Ubuntu instance, and this is the same, right? So even this is the same. So let's close the extra terminal from here. And now let's connect to our second Ubuntu instance as well. So this is the IP address, guys. Let's copy it. Let's launch a new putty console. Let's paste the IP address. Let's select the PPK and let's click on open. For clarity, let us change the colors of the terminal. Let's make it orange so that we can differentiate between the first instance and the second. So as you can see, the IP address for this is 172.31.51.17, and the IP address is same over here as well. So that means we have two Ubuntu servers that are now open on my putty terminal. And what we will be doing is we'll be connecting this EFS mount point to my Ubuntu instances. So this is a security group, guys, 7F087236. Now we'll have to ensure that both my instances have that security group associated with it, right? So if we have to check the security group for my Ubuntu instance, here it is, guys, the security group which you'll have to connect. So what you will be doing is you'll be going to networking, you'll go to actions, go to networking and click on change security groups. So as you can see, it is only launch wizard 1 has been connected to it. My security group that I have to connect is 7F087. So this is the security group that I have to connect to my instance. So let's connect both of them, right? And now let's click on assign security groups. So my Ubuntu instance is now connected to the security group of my EFS. Let's do this to our second instance as well. Let's select the default security group that is there. Great. So now both my instances are connected to the security group of my EFS, right? Now what I'll be doing is I will be following a set of instructions that you will find on this console as well, right? So the first thing that you have to do is on an Ubuntu instance, you will have to install this package. Let's do that. So this is my first instance. Let me copy the command and it is already installed. Great. Let's do the same on our second instance as well. So let's first update the machine, sudo apt get update. All right. Once it's updated, the next step would be to run that command. Now let's run that command and my NFS common package will install over here. Right now what I can do is I can create a directory on my first instance. Let's the directory be EFS test. Okay, great. And let's create a directory here as well. Let's name it as EFS test 2. Okay, now what I'll be doing is I'll be mounting my EFS volume. So for mounting it, just copy this command, go back to your server, paste the command and put the directory name. So in case of my first instance, the directory name is EFS test. Let's hit enter. Great. So EFS test directory is now connected to my EFS volume. We'll verify whether that is working or not, right? Let's similarly copy the command over here as well. And this would be EFS test 2. This is the directory name. Great. So even this instance is now connected to EFS. Let's go into EFS test 2. Great. Now, as you can see, if I do an ls over here, there's no file, right? Similarly, if I do an ls over here, there's no file. Let's create a 1.txt file. Let's put sudo. Great. If I do an ls, you can see there's a 1.txt file over here. If I do a ls over here, you can see there's a 1.txt file here as well. That means this is a shared volume, correct? If I create, let's say, one more file over here, if I do an ls over here, I can see the 2.txt is also available. Similarly, I can create a file from here as well. And if I do an ls over here, I can see that the 3.txt file is also present. So guys, this is how EFS works. It acts as a shared drive between multiple instances in AWS. All right. So let's come back to our slides, guys, now. So guys, we have successfully discussed what S3 is, we discussed what Glacier is, we discussed what EFS is, and we have discussed what storage gateway is. Our next set of services belong to the database domain. So let's go ahead and understand these services. So the first service, so guys, the database domain comprises of these many database services in AWS. The first AWS service that I have is Amazon RDS. Then we have Amazon DynamoDB, Amazon Redshift, and in the end, Elastic Cache. So let's understand these services one by one, starting off with Amazon RDS. So guys, Amazon RDS is nothing but a relational database service. Guys, it's not a database, it's a database service. What do you mean by that? Is that you will, under the RDS service of AWS, you can launch these many databases. You can launch the Microsoft SQL Server, you can launch the MySQL service, you can launch the Oracle SQL, PostgreSQL, MariaDB, Amazon Aurora. You can launch all these databases. But what is RDS for? RDS basically manages these databases. Now, how does it manage? It makes sure that it takes automated snapshots of all these databases, which will be corresponding to a particular time. It can also ensure that if there are any read replicas required or if there are any replication required in your database, that also can be taken care of RDS or by RDS. Third thing is it also takes care of any security patch which has to be applied on your database if you enable automatic updates, right? So this is how RDS works, guys. Now again, let me emphasize on the point that RDS is not a database. It's a relational database service in which you can launch all these relational databases. All right. So guys, I hope RDS is clear with you. Next service is Amazon DynamoDB. Now, what is Amazon DynamoDB? It's basically a NoSQL database by Amazon, right? And what is a NoSQL database? Whenever you have to store unstructured data, that is data which does not follow a particular format, you use unstructured database like DynamoDB. Now, alternatives to this, you might have seen or you might have heard about MongoDB or you might have heard about other NoSQL databases. This Amazon DynamoDB is a NoSQL database by Amazon, right? So there is no database that it supports. It itself is a database unlike RDS, and in this you can store unstructured data. Okay. Third service is, guys, Amazon Redshift. So Amazon Redshift is a data warehouse service, which basically what it does is under the data warehouse you will have multiple databases. So those databases can be queried by your warehouse, and it looks as if all the databases, they combine together to give one database where all the data exists, but it is actually not like that. Amazon Redshift comprises of multiple database engines which it can connect to and give the output as required. Next service is Amazon Elastic Cache. So Amazon Elastic Cache basically is a service which serves as a cache. So what is a cache? A cache is a layer between the client and the web server or the server from which the information is being requested. What happens is, let's imagine you want to get the data for an employee whose salary is greater than 10,000, and you basically want to get all the current cities that the employees are staying in, right? Now let's say you do this query time and again. Now what happens? Your server is again and again doing a query on the database using a particular query that this is the data that I want. Now what happens is, when again and again you're doing the same query, it does not make sense to run the same query again on the database, let it do the computing work and then get the results. So for these kind of data, what Elastic Cache does is, whenever it sees that there's a frequently accessed data, it stores that data on the cache, which means whenever a similar request will come, rather than querying the database, the same data will be going back to the customer from the cache layer itself. So it decreases the overhead on the database, and it also at the same time increases the performance of your application. All right. So that is what Elastic Cache is all about, guys. Alright guys, so our next domain is the security domain. So in security domain, these are the following services that we have in AWS. So we have the first service, which is AWS IAM, and the next service is AWS KMS. Let's check out both these services and understand what they do. So guys, IAM is basically used to authenticate users to your AWS account. Now, the account that you just created on AWS, it basically is the root account for that AWS account. Now, what happens is, big companies or companies like Netflix, Airbnb, they own only one AWS account. And what they do in that AWS account is they create multiple users with restricted permissions. Okay, so each user can have their own user ID and password, but basically they will be logging into the same AWS account, and that is possible using AWS IAM, right? So you can create multiple users for a single AWS account with granular permissions, such as what actions can they do on the AWS management console. You can also restrict them to particular services that they can access. For example, the user can just access S3, or he can just access EC2, or he can just read EC2 and cannot stop and start an instance, or he can just start and stop an instance but cannot create a new instance, right? Or you can put also a restriction that nobody can terminate an instance whoever users you are adding, right? The account or the user that you signed up with, that is basically the root account. Now, what is the root account? Root account always has all the privileges, right? It has all the privileges, can do anything. But if you have to put any restrictive access to a particular person, you'll have to create a user account in IAM. So that is one type of account that you can create in IAM. The second type of account that you can create in IAM is an application account. Now, what is an application account? Let's say I have a website which can upload data to S3. Now, how do I authenticate my website to upload data on S3? For that, we have the AWS IAM service, using which I can create application identification keys as well. So what you get in that case is you get access key and you get a secret access key. So that access key and secret access key has to be embedded in your program, and only then your program is authenticated to upload data onto the S3 service of your AWS account. Otherwise, it cannot, right? So this is one of the reasons, or these are actually the reasons that you use IAM for, right? It can help you to put restrictive access on user accounts as well as application accounts. All right. Moving forward, guys, the next service is KMS. KMS means Key Management Service. So Key Management Service is basically used to create the key pairs that we saw while we were creating EC2 instances, right? So those key pairs are actually created by the KMS service, right? So similarly, if you want more key pairs to be created, you just have to head on to the KMS service and you can create your key pairs over there and authenticate yourself accordingly to whatever service you want. All right. So guys, this was the security domain. Now let's move on to our next domain, AWS Services Management. Alright, so this is our next domain, guys. So let's see what all services are included in this domain. So guys, these are the domains that are included in this, these are the services that are included in this domain. So first service is AWS CloudFormation. Then we have AWS OpsWorks. Then we have AWS CloudTrail. And in the end, we have CloudWatch. Now, what is AWS CloudFormation, guys? AWS CloudFormation is basically used to templatize an AWS infrastructure. Okay. So let's say I have launched two EC2 instances with a load balancer with in an autoscaling group, which is connected to an RDS instance, which in turn is also, connected to my EFS. So all these things I will have to launch, right? If I know what the architecture is, I will have to launch everything one by one, and then probably my architecture would be ready. But what I can do with CloudFormation is everything I can specify in a JSON file. So in a JSON file, I can specify all the resources that I want to launch, all the things that I want to configure in the network, everything I can specify in the JSON file, and just run it through CloudFormation. So what CloudFormation will do, it will create that whole architecture according to my JSON file. So I don't have to stress too much on, creating my architecture one by one using either through my management console or through my CLI, right? I can directly do that by just writing a JSON file and passing it through my CloudFormation. So this also helps us when we want to replicate our architecture across multiple regions, right? Let's say I have an architecture in one particular region, I want to replicate it across multiple regions. So in that case also, CloudFormation helps us a lot. So it's an automation tool which can help us to launch AWS resources by specifying it in a JSON file. Our next service is AWS OpsWorks. Now it's a little similar to CloudFormation because this also deals in automation, but basically this is a configuration management tool. So if you guys are aware of DevOps, there's a configuration management tool called Chef, right? So Chef recipes are readily accepted by AWS OpsWorks. And what you can do is in AWS OpsWorks, what happens is there are multiple layers that you have to configure, and all these layers together, they form to become a stack. Okay, so what I'll be doing is, let's say in the first layer I specify the EC2 instances that I want to automate on, right? The second layer could specify what all software that I want to be configured in that EC2 instance. So that is how OpsWorks is helpful, guys. So a configuration management tool is nothing but which can configure all the software requirements on a particular set of servers at the same time, right? That means if I have to install, let's say MySQL on, let's say 100 servers, how will I do that? It's a very daunting task. I'll have to go to each server, I'll have to install MySQL. So OpsWorks makes it easy for me, and it makes it easy in a very effective manner. That is, every server will have the same configuration that I specify in OpsWorks. Now don't get confused with CloudFormation and OpsWorks, guys. CloudFormation is used to deploy an architecture. OpsWorks is used to specify consistencies in that architecture with respect to the softwares that we are going to install in that. Okay, so and also it's not just a one-time deployment that you'll be doing through OpsWorks. Let's say tomorrow your database link and the password is changing, right? And you have some 200 servers in your fleet. How will you do that? So that is possible using OpsWorks. All you have to do is just go to that layer where you have specified the link and the password, just change that and update or deploy the OpsWorks architecture. And then in that case, it will update all the servers with that very small change that is specified in one of the layers, right? So for all these very small changes, which are very important and have to be same across all the servers, I use OpsWorks, right? Next service, guys, is AWS CloudTrail. So AWS CloudTrail is basically a monitoring service which logs everything which is happening in your architecture, right? So that logging is not enabled by default to some of the services. You can enable logging by specifying that, AWS CloudTrail should log each and every action which is happening. And it exactly does that. It basically would log each and every action or each and every event that is happening inside a particular AWS resource once you attach AWS CloudTrail to it. And then that log data basically you can use to do further monitoring by connecting it to probably a BI service which can visualize your log data, etc. Right? So that is what AWS CloudTrail is all about. Then our next service is AWS CloudWatch. Now, what is CloudWatch? CloudWatch is basically, again, it's a monitoring service, but it's a little different kind of monitoring service, right? So what you can do with CloudWatch is you can set up alarms. For example, if let's say I want an alarm whenever one of my servers goes in unhealthy state, right? No, so how would I do that? So one thing would be that I continuously hire my employees and they are constantly checking if my servers are in the healthy state or not. Or what I can do is I can configure will take very less time to just configure my CloudWatch to monitor all my resources, and whenever there is a resource which goes in the unhealthy state, it can trigger an alarm. Now, what kind of alarm can it trigger? It can either email you, or it can basically trigger a next set of events. It can trigger to create an EC2 instance, or it can trigger an AWS Lambda function. It can trigger something else as well. So this is what CloudWatch is all about. It watches all your resources, and on basis of that, it can do a simple process that you define in CloudWatch. Okay. Moving forward, guys, our next domain is customer engagement domain. So in this domain, we have the following services. The first service is Amazon Connect, and then we have simple email service. So let's look at what these two services do so that they are so helpful in the AWS community. The first service being Amazon Connect, guys. So Amazon Connect is nothing but it's a full-blown customer contact center for your company. For example, you would have seen that whenever you purchase a product, there's always a customer helpline that you can call on, right? And then you get the IVR options in there where you choose, and then you get connected to human agent to talk your way out, right? Or you to put your grievances and you talk to your customer service agent, right? Now, if you want to set up something like that for your company, it is very simple to set up that using Amazon Connect. You can build a customer contact center in less than 5 minutes with Amazon Connect, right? All you have to do is go to Amazon Connect service, click on get started, and it will allot you a toll-free or a normal phone number based on what you choose. After that, you just have to fill in the agents that you want to be on the other side, so that whenever people will be calling that one particular toll-free or normal contact number, they should be routed to the agent's screen, right? And this happens on the internet, so there is no need of purchasing carrier plans or something like that, right? So this is what Amazon Connect is all about, guys. Our next service is simple email service. Now this is also plays a vital role in customer engagement. You would have seen that you get marketing emails from a lot of companies. For example, if there are food companies that you order for, or if you have went into a store, you gave your phone number over there in the contact list, they'll also message you. Pizza delivery stores or grocery stores, they all email or SMS you one way or the other, right? This service right here is when you want to have email interactivity with your customers, right? You can send bulk emails. You can also set up your simple email service to respond to particular reply emails, right? So that is what SES is all about. And this also can be configured to route emails. For example, if there is an email address that you set up for your company, for example, support@intellipaat.com is our email address, right? So if you email to that particular email address, it will get routed to our support agents who will help you out in solving your queries, right? So that all can be set in Amazon SES. Guys, so this is it for the customer engagement services. Our next domain talks about app integration, right? So in this domain, we'll basically have services which help you to integrate 2 or 3 services in AWS. Let's look at what services they have to offer. So there are 2 services basically, guys. One service is called Simple Notification Service and the other one is Simple Queuing Service. Let's see what these services are. So the first service, which is Amazon Simple Notification Service, basically helps you to send notifications to other AWS services in occurrence of an event, right? So it waits for a trigger to happen, and based on the trigger, it sends a notification to a corresponding AWS service which has to work next. For example, you can set up a website which can send you an email, and all you have to do is, let's say, whenever a customer purchases something from your website, you want to trigger an email to the customer with all the details. Now, if you have to do this on a distributed environment, what will you do is the moment there is a trigger that there is a cash payment received from a particular customer, your Lambda event will be triggered, right? Now that can be triggered in numerous ways. One way is either your service can directly trigger the Lambda event, but that is only possible for some of the AWS services. The other way around is that you can send a notification to SNS, right? So SNS will detect the type of notification received and it will have a mapped out row as to which service it has to notify next. So in this case, it will receive the notification. It will see, okay, so this is the type of notification received. It will invoke the Lambda function, which will basically send out the email to your customer. All right. So this is how an SNS service basically works. As you can see in the diagram here as well, that you have a publisher. A publisher is a person who sends out the notification, right? The next thing that you do is the way of filtering out different kind of notifications in SNS is that you define topics. Okay. So based on the topics, the messages are filtered, and what you do is in the topics, you will define which service to basically trigger. And based on that, those services will be triggered, and the services to be triggered are basically called subscribers. Okay. So guys, this is how an SNS service actually works. Moving forward, now let's look at the simple queuing service. Now, what is a simple queue service? It's basically a queue it's basically a place where you can store all your jobs whenever you have a stateless kind of an architecture. What is stateless kind of an architecture? Let's say you have a system which doesn't have its own memory. The prime example for this would be AWS Lambda. So what AWS Lambda does is it does not know what is happening in your application. Okay. What it knows is just the job that it has to do. For example, let's say the job of the Lambda server is just to send an email, right? It will not know whether it has already sent an email to a particular customer or not. It will not know whether it has already sent an email to a customer, right? What it will do is it will just pick up jobs from the queue that you have, and based on that it will perform the job. And that is exactly why you have a simple queuing service, so that it can feed to Lambda what the next job is without Lambda having to remember what it has to do, right? So guys, this is what the SQS service is. Now guys, this was all about the different AWS services that we have and that you need to know in order to get started with AWS. So for I think we have almost covered all the use cases that you can encounter in an organization, and basically your job would be to that based on the problem you would have to suggest an AWS service, and that AWS service implementation also details you will have to know, right? So based on the knowledge that I've just given you what each and every service does, you can now decide what an architecture should basically have in order to get a job done. All right, moving forward guys, now let's talk about a very important topic, which is AWS pricing. Now we know about all the services that we're going to use, right? But what will we do or how will we use these services totally depends on the pricing of these services, correct? So let's move forward and understand how the pricing model works in AWS, and if I'm using a set of services, how will I be charged? How much will I be charged? So guys, the AWS pricing options are among these three, right? The first option is pay as you go model, which means whatever amount of time you will be using an instance for, or whatever amount of time you will be using a server for, that amount of time will be billed to you and will be given back to you. So whenever you will be launching any server, you will get a per hour basis charge on that particular service, right? So you can see that service, you can see what the charges are, and accordingly you will be charged whenever you terminate that instance, or whenever there is a monthly billing cycle of yours which is ending, right? So the first model is pay as you go model, which is widely used. Second model is save when you reserve. Now what do you mean by that? Let's say you're launching a website today, right? And that website is for your company, and you foresee that I will be at least running this website for the next 3 years. Based on it's just a startup, I might not see that much growth, but I will sustain it for 3 years. In 3 years my website is gonna there, right? Let's say this is the scenario. So what you can do with AWS is you can opt for dedicated instances or reserved instances. So you can say that I'm going to use this instance for 3 years from now on, right? And I'm not going to back out. I am going to use this instance for 3 years. Then what AWS will do for you in that case is it will give you a counter offer. It will give you a discounted price, right? Reason being that it is no longer an on-demand service. It's a service that you have asked from AWS, which you will use for 3 years, which means that you will pay, you will have two options in front of you to get this kind of a deal. One thing is you can do a full upfront payment of 3 years, right? You can pay all the whatever discounted price they deliver to you. You can just give the amount for 3 years and you can use your instance, right? Then you're locked in. Or what you can do is you can also do a partial upfront payment if that eases out the financial stress on you, right? For example, you do not have that kind of money to pay for 3 years. So what you can do is you can divide your payments into EMIs and then you can pay it to AWS. That's a partial upfront payment. So with this, you can get discounts up to 70% of the pricing which is there in pay as you go model, right? So the guys, that's very cheap. So if you have an application where you know the server that you're going to use is going to be there for like 2 or 3 years, then it's better to go for reserved instances where you can opt for taking a server and you'll get huge discounts on using them. Right? The third kind of pricing is pay less by using more. What this basically means is the more you will be using your instance, for example, your instance, the type of pricing that you get for instance is on a per hour basis, right? The more you will use your instance, the less the hourly rates will become, right? So that's also an awesome feature by AWS which says pay less by using more. All right. So guys, these were the pricing options in AWS. There's one more pricing option that you get in AWS which is called spot pricing. What is spot pricing or spot instances? Spot instances are basically idle instances which AWS is running, and what it does is it offers it to you in a cheaper price, right? So for example, it's 2 p.m. in the afternoon and I know know that the load is less at this particular time. So what AWS will do is it will offer you some instances at a lowered price rate, because those are just sitting idle over there, and if you want to use them, you can use them. So what happens in that case is you take that instance and you bid it, right? If you want to take that instance, you'll have to bid amount on that particular instance. The higher the bid amount is, obviously that bid amount will be lower than the actual rates, but the higher the bid amount is, that instance goes to that particular person, right? Now there is a catch in this, basically, that if somebody bids higher than what you have bidded, in that case your instance will be stopped immediately and it will be given to someone else who has done the bidding higher. All right, so that's a catch over here, but it could be particularly helpful when you are dealing with workloads which are not that important, but anyways you have to do them, right? In those kind of scenarios, you can take up spot instances and you can just bid a particular amount which you feel you are comfortable in, and in case in future the price goes up, your instance will be stopped, but at least you're getting your work done in a cheaper rate, right? So that's the ideology behind spot instances. So I guess now it's clear with all of you what AWS pricing options you have. Now let me move ahead and let me tell you a very exciting point about AWS pricing, right? The free tier. So the free tier is basically one-time offer that you get whenever you sign up. So whenever you sign up on AWS, if you are using a T2.micro instance, which is 1 GB of RAM and 1 vCPU of computer, in that case, it will be totally free of cost to you, right? So what you do get in a month is 750 hours of usage. So you can launch 4 instances, 5 instances, all of them together collectively can be run for 750 hours. The moment you cross 750 hours, you'll be charged the normal price, but up till 750 hours of server usage, you will be not charged a penny, right? And this is what the free tier is all about. Now it is particularly helpful for people who are trying out AWS, or people like us who are trying to learn AWS for our future careers, right? So I'll request you all guys, so whenever you're practicing on AWS, always be under the free tier, because that is literally not going to cost you anything. All right, so the 750 hours that you get are particular to EC2 and RDS. Apart from that, you get some other free tier limits as well. For example, in S3, you have, if you store data up to 5 GB, you will not be charged anything. Okay, then in DynamoDB, if you have to store something, which is if the instance which you're running is under the free tier, and if you want to store something on DynamoDB till 25 GB, it is absolutely free. Okay, so guys, this is the kind of pricing that you get. These are the kind of perks that you get when you're using AWS for the first time. For more details on AWS free tier, you can just visit the aws.amazon.com official website, and they'll give you all the details. There are a lot of other services as well that they offer free tier in or free limits in. For example, the Amazon Connect service that we discussed, which was basically a one-stop customer support center setup. In that, you get in a month you will get the first 90 minutes of your calling for free. And the way you get charged for that particular service is not on the number of hours that you'd be using that service, but on the number of minutes a customer is speaking to an agent, right? That is how you get charged. That's, I think, pretty cool about Amazon Connect. Alright, moving forward guys, I think we have covered enough of theory. Now let's go ahead and do a hands-on where basically I'll show you guys how to set up your AWS services and how to migrate an application from your local computer onto AWS. So let's start off with our hands-on. So guys, what I've basically done is I have created a website using which we can upload data on S3. Okay, so this is how the architecture looks like. So basically my website can upload data on AWS S3, and that record is also saved in a MySQL database. Now, as of now, this MySQL database is on the local host, and also the website is on the local host. And right now my website cannot connect to S3 because it is not being able to authenticate itself. All right, so this is what we are going to, the first step that we're going to do is we're going to authenticate our website to AWS S3 to upload data. Once we have done that, we will migrate this website onto AWS infrastructure. All right, so without any ado guys, let me first show you how my website basically looks like. So let me jump on to my browser. Right, so guys, my website basically exists on localhost/new. Right, so this is how my website looks like. The first thing that I would have to do is I will have to check if it is able to connect to a database. So basically whatever I will be uploading I can view that over here as a list, but right now it cannot connect to the database. So what I do is I'll open up my MySQL on my local host. Here it is, right? And now what I'll do is I'll create a database called images. So because that is what I have configured in my code, right? And now let me create a table with the name names, and let there be one field called name with the value as varchar, and let us give pretty big value so that any length of characters can fit in this particular table. All right, so it says no database selected. Oops, I'm sorry for that. So use images, and now let's create the table. So when I do a refresh over here, it should be able to connect, but now it will show you an empty list because there's nothing inside my database, right? If you want to show anything over here, it will basically be visible once the entry is made inside the database. Second thing is, right now if I try to upload anything, let me go to pictures and let's say this is the image that I upload. If I click on open and if I click on submit, my file basically will not be uploaded. Reason being, it will say the authorized header is malformed, which basically means authentication is not yet given to my account. Now, how can I give authentication to my website so that it can upload on S3? For that, I'll have to head on to my AWS Management Console, and as we have learned, there is a service called IAM. So I will go inside that IAM service, and over here what I'll do is I will create a user, right? And let's say the username is web demo, and what I will have to give this user is the programmatic access, so that by code this user will be able to access all the services on AWS. Now, the kind of services that I want my website to access is only S3, right? So let us put in S3 over here, and as you can see, there's a permission over here which is Amazon S3 full access. Let's give this access to this particular user, and let's review it, and let's finally create the user. Once we have created the user, guys, I will have the access key ID and I will have the secret key, access key. Now this is very important for my application to be authenticated. So what I'll do is I will just copy this access key ID. I will go to my terminal. I will create a new page, and this is my access ID, guys, and this is what my secret access key looks like. Okay, so this is my access key, this is my secret access key, and this will be used to basically connect my website onto AWS S3. Okay, now let me show you how my index or how my code looks like, guys. So guys, this is my code which I'll basically use to upload files onto S3. As you can see, the key and the secret key are not filled as of now. So let us fill the key first. So the key is this. Let us enter it over here, and the secret key is this. Right, so once I enter the key and access key, secret access key, my website will now be able to authenticate itself onto S3, and now it should be able to upload objects into a bucket. Right, which bucket are we talking about? Let me quickly show you. So there's a bucket that I've just created on S3, and that bucket name is basically test Intellipaat. So as you can see, there are no objects in this bucket as of now, right? And now what I'm going to do is let me refresh this website. And as you can see, now it says new record created successfully. That is, the image that I chose earlier should now be uploaded over here. So now if I do a refresh, I can see there's one image that has been uploaded. Let's upload one more image for the sake of understanding it. Let's upload this particular image and let's click on submit. So what happens is, the moment it takes up a file, it changes the name of the file into a random name, and then it uploads it over here. So if I refresh, you can see there's one more image which just has been uploaded. Now what I can do is I can just go back to my website and I can just click on checklist. So this will give me a list of files which are uploaded onto my S3. If I click on this list, I can basically download the file from S3, and if I click on it, you can see the file. This is what I uploaded, right? Similarly, if I click on it over here, this is the file that I uploaded. Right. Similarly, let me upload one more file so that it's clear for everyone. Let's say I upload. Let us not take an image. Let us try to put something else. So let's say there's this app, there's test.jar that I can upload. So let's just click on open and let's click on submit. So this is the file. I click on submit, and now if I do a refresh over here, I should have that file. Okay, so that file might be a little larger in size, that's why it's not uploading. So what I can do is let me take this particular image, right, and let me submit this. As you can see, a new record has been successfully created. If I click on checklist, there is a new image which has been added. If I click on this image, I can clearly see that this is the image that I uploaded. Similarly, if let us try some other file as well. Let's choose a file. Let's try to upload this Excel file. Let's click on submit. And when I do that, a new record has been created. Great. If I check the list, this is the Excel file that has just been uploaded. If I click here, the Excel file is downloaded. If I click open this basically file should now open, right? Great, guys. So I think our website is working fine, but the problem is this website exists on my local host, right? And right now it is basically feeding data onto my local MySQL instance. So if I basically would just do a select star from images, select star from names. This is the name of the table. You can see that this is all the values that are there in the table, and these are the values that you can see over here. So the first thing that I should do is basically let us deploy a database on AWS through which my website will basically be connected. For that, I will be heading on to RDS. Since this database that I'm using is MySQL, let us try to deploy a MySQL database on AWS. So for that, I will be clicking on create database, and the type of database that I want is MySQL. Let's select that, and now let's click on next. Next, I want to create a dev environment or test environment because this is just a POC. So I've selected this and I'll click on next. Next, I can select the MySQL version. So let it leave it at default right now. And I want to enable only options which fall under the free tier usage. Okay, so let's select this option. And everything is filled automatically. Let's identify our DB using a name. Let's say it's web-demo, right? The master username, let's say the master username is Hemant. Let's specify the master password as well. And now let's finally click on next. Right now it will ask me which VPC do I want to put my instance into. So I have the default VPC where my instance is being launched in. That's great.
Just a quick info, guys. If you want to make a career in cloud and DevOps, then Intellipaat provides an advanced certification in cloud computing and DevOps by ENICT Academy IIT Roorkee, and it is taught by IIT Roorkee professors and industry experts. This course is designed to help you upskill and land in your dream job. Now, let's continue with the session.
Second thing is public accessibility. Do I want internet to be able to access RDS? So yes, I want public accessibility to be enabled. If I select no, in that case, there will not be any public IP which will be assigned to my RDS instance. Only the VPC in which my RDS instance resides in, only the instances launched in that particular instance or in that particular VPC would be able to access that RDS. So when I say VPC, it's basically a virtual private cloud, or it's basically a virtual network, right? So if I do not give public accessibility to my RDS, then it will only be able to connect to machines which reside in that particular network on which it is being deployed, right? Not on the internet. Okay. So, but because our website right now is in my local host, from local host, I should be able to upload data onto the database of AWS. So for that, I will need public accessibility, right? Do I want to create a new security group? No, I don't want to. Let us select the default security group. Okay. What should be the database name? So the database name would be the same that I've given for my local MySQL instance, which is images. Rest you can just leave at default. Backup, I don't want any backup, so let's select 0. And disable monitoring, we don't want that. We don't want any upgrades made to my database, right? And I think that's it. Now let's finally click on create database. Now guys, the database instance, it takes around 3 or 4 minutes to create. Meanwhile, while this database is being created, let me tell you the next step that we have to do. Now, since this website exists on localhost, I want this website to be existing on basically AWS. I want this website to be uploaded on AWS. And for that, let us use Elastic Beanstalk, which is the platform as a service on AWS, right? So let's open the AWS Management Console, and now let's head on to Elastic Beanstalk. In Elastic Beanstalk, you can basically upload your website, and I'll show you how you can upload your website, and you don't have to configure anything on the instance. Every software, everything will be configured by Elastic Beanstalk itself. So as you can see, when you reach this page, you just have to click on Get Started, and now it'll ask you the application name. Let's say the application name is web-demo. Right? What platform is my website based on? So it's based on PHP. Do I want a sample application to be deployed previously? Yes, I do. So I'll just click on create application now. So guys, this will basically create a web app for me in Elastic Beanstalk. We have done this earlier as well. We're doing it once more so that we can upload our own website onto this particular Elastic Beanstalk application. Okay, so it'll again take, guys, 3 to 4 minutes for Elastic Beanstalk to get deployed. Meanwhile, let's check if our RDS is ready. I'll just head on to RDS. I can see there's an instance which is running. So it is still in the creation phase. So once the creation phase is over, you would be able to get an endpoint over here. So an endpoint is basically a URL through which you will be able to connect to your database. All right. So let us wait for this database to be ready. And once it is, I will try to connect to this database from my localhost and see how that goes. Right, so it's in the creating phase. Similarly, my Elastic Beanstalk is also being created. Let me show you my code, guys. Let me explain you my code a little bit. Right, so this is my main file. So in this file, basically, I am using the PHP backend language on which I have basically imported the AWS SDK, right? This SDK, you can basically just Google AWS SDK for PHP and you would be able to download it. Now I have included this particular folder in my root directory of my website, which is over here. So this is the folder which has all the libraries, right? And my index.php will basically has included this particular library, and then the service that I want to connect to is S3. So we are using the libraries of S3 over here, right? My bucket resides in Oregon region. The code for that is US West 2. This is my key. This is my secret access key. Don't worry, guys. I will be deleting the user account, so don't try using these keys. They will no longer work once I have the username deleted. Apart from that, it's pretty simple. It's a very straightforward code, guys. Right now, the database that I'm connecting to is on localhost. That's why the server name is localhost. When I would want to connect to my RDS instance, all I have to do is change this server name to the endpoint of RDS, and then it should work like a charm. Right, that's it. This is my index.php. My list.php, where I get a list, is basically I'm just connecting to that same database which exists on localhost, and I'm trying to read everything from the table. This is the field that I'm reading. On the front of that name, I'm attaching this URL. So this is the URL for my bucket, and this remains the same for each and every object which gets uploaded. Right, so I'm uploading, so I'm attaching this along with the name, and this I am basically storing in an ahref tag, which basically gives me a link on my website. Right, so if I can show you over here, as you can see, this is a list, right? And this is the link. So this link is basically a ahref link in which I have embedded this URL with my file name. All right, so once I've done that, it works great. It works like it is supposed to. Now I guess we should go ahead and check if my RDS is ready. Yes, guys, so my RDS is now in the available state. So how do you connect to RDS? There will be a database which has been created on my RDS, but still the table is still not created, right? So first I'll have to create a table on this RDS instance, which would basically be exactly the table like what I have on my localhost. So how do I connect to my RDS? So just copy this endpoint, guys. And now you'll have to go on to CMD, right? So once you are on the CMD, guys, the next step is to go to the bin directory of your MySQL installation. So my MySQL installation is basically in WAM64. So I'm going to go in there, right? So I'm inside the bin directory now. Next thing would be that I will have to call in MySQL. -h would be the host name. The host name in my case is the Amazon's host name, which is this. The username for this RDS instance, it's Hemant. And the password is this. Let me specify it over here. Let's hit enter. And now, if everything has went well, I should be able to connect to my RDS instance. Let's wait. So while this is happening, guys, if it gets stuck like this, it could be that you're not able to connect to your instance, and the reason for that could be in the security group. So you'll have to check if the inbound rules for the security group are open to accept traffic. So let's click on inbound, and yes, so this is the problem over here. It's allowing all traffic, but it's only allowing to this particular security group. So what I'll do is I'll make it anywhere and I'll save it. Once I do this, let us come back here and try to run the command again. I'll enter the password and hit enter. So as you can see, I have successfully connected to my MySQL instance, which resides on AWS. Now this instance should have a database called images. Let's use that. And now let's create a table which will be the same as what I did on my local host. So the table name would be names, and the field name would be name, and the type of information that can go in is varchar. Let's specify that. Okay, so my table is now successfully created, guys, and now my database is ready to basically take in data. Now what I'll be doing is let us go back to RDS and let's copy this endpoint, and now let's make our website maybe be able to basically interact with my RDS instance. So it's pretty simple. Just change the server name to the endpoint of RDS. The username in my case is Hemant, and the password in my case for my RDS instance is Hemant1994. Alright, that's it, guys. That's all we have to do. And let's save this code. Similarly, in my list, I will have to change the values from localhost to these variables. I'll save it. And now when I go back to my website, let us open the local MySQL instance also. So this was my local MySQL instance. As you can see, there are only 4 entries over here, right? Now let's choose a file. Let's try to upload the same XLXX file, the Excel file that is, and let's now click on submit. So it says new record created successfully, but let us check here if this is where my data has been entered. So no, my data has not been entered over here. Let us check on my RDS if my data is being entered correctly over here. Select start from names. So yes, a data has been entered over here with the this particular name. And if I click on checklist, as you can see, even here I get the same value. So you can compare that this is the name that I'm getting over here, and this is the name that I'm getting on my website. If I click here, I'd be able to download that Excel file successfully. Great, guys, this is what I wanted. So now my website is basically connected to my database instance on AWS. It was that simple. Now the next step is basically to put this website on AWS for good so that everybody in the world can access it. Now how can I do that? This is my Elastic Beanstalk, guys, and this is the dashboard that I get when I use the platform as a service instance. Right now it says here upload and deploy. So that's what I'm going to do. I'm going to click on upload and deploy. And now it's going to ask me to choose a file. Now the way you can upload your website over here, guys, is you will have to go to your website codes, right? And then you will have to zip these files like this, right? So once the files have been zipped, this zip has to be uploaded over here. So I'll choose a file. Let me go into that folder where I have the zip. Here's the folder. Let's click on open. Version label, let's try to give this version label as 1.0. Okay, and now let's click on deploy. So now my website is now getting deployed to AWS Elastic Beanstalk. It will hardly take some 2 or 3 minutes for my website to be ready on this particular platform. And once it is, we'll be able to use it via this particular link. This link will basically be my application now that I've shown you on localhost. This will now be available on this particular link. So let me close all the unnecessary windows. And now let's wait for this to be ready. Okay, so it will take around 2 to 3 minutes, like I said, and whatever version that I've specified, that version will now be reflected over here. Okay, so it would be AWS:1.0. So let's say in the future I make change to my code any kind of change to my code, I would be able to upload it over here in the same manner possible. That is, I will have to click on upload and deploy, and then I will have to increment the version. I will show you that as well. Let this complete, and then we will go ahead and check. So as you can see, my running version is now AWS 1.0. Great. So this is what I wanted. Now it's the moment of truth. Let's try to go to this URL and see if our website is working or not. So great guys, my website is now available on this particular URL. Let's try to check if it is able to upload everything. So let's first check a list. So we have one file which is there in my database which is uploaded. Now let's choose a file. Let's try to upload the zip file itself, right? I'm not sure if it will be able to upload. Let's check. So the uploading has started. It says new record created successfully. Awesome. Let's go here. Let's refresh this. As you can see, a new entry has been made. Let's try to download this. So as you can see, the zip is being downloaded. And if we go to our S3, if we refresh over here, you can see the zip is present over here as well. And my zip is also downloaded. If you want to verify if all the contents are fine or not, let's do one simple step. Let's create a new folder here, right? And now let's try to paste this extract over here. It will extract all the files. Click on OK. So all the files are now being extracted. Let's do a Control X and let's paste here. Let's delete these files. So basically on my localhost hello, there should be a file. My website should be up and running. So localhost/hello. So as you can see, I can see my website over here. And if I do a checklist, if I do a list.php here, I should be able to see even the list. So that means these files that have now been uploaded to S3 are working correctly. And also I have successfully migrated my website, which is there on my localhost, onto Elastic Beanstalk without even going to the terminal, without installing any software on the server, right? It is now up and ready, and anyone who will visit this particular URL will be able to access my website. Okay, and as simple as that, guys. And it's basically hosting my files as well. My files are now all available on this particular link. So anywhere in the world, if anybody would go to this particular link, they will be able to access these files. They just have to click on it and they'll be able to download it.
As I already told you, in this session, we'll be looking at a hands-on. So before moving on with the session, let me briefly show you what is going to be the output of our hands-on. So this is our local host and this is our Elastic Beanstalk. So first in localhost, what I'm going to do is I'm going to upload this doc1.pdf and I upload it. So the file has been uploaded successfully. So now let me open Amazon Web Services account and I'll open my S3 bucket. So first I'll open the S3 service, and inside that there are already buckets which I've already created for this demo. So first let me go to from the bucket, because in this bucket I'm going to store all the files which have been uploaded. So first, so you can see already there was a doc1, and right now another file has been uploaded, and also because it is the same name, the file will be overwritten with another name of the current time and the file name. So we have uploaded one more file. Let me show how it works in Elastic Beanstalk too. So it is the same operation, the same code in Elastic Beanstalk. So let me upload another file. So I'm uploading this photo here. So I upload it and the file has been uploaded successfully. So in S3 now, if I reload it, and you can see that file has been uploaded. So the final output is going to be, so we go to the bucket image. So you can see I already had two images, and now there is another image which we uploaded already in the bucket, from the bucket. So here you can see to the bucket PDF, and if you go inside you can see the doc1, and this one was uploaded from this localhost. So you can see here that it has the same name as this one. So it is exactly the same file which was uploaded here, and it was copied to that bucket. So how did we do that using AWS Lambda? That we'll see in this session. So first let us learn the theory concepts of this session, and then we'll move on to the hands-on part. So come on, let us go. Okay guys, now let us begin with the session. So typically an application comprises of three components: the front end, the back end, and the database server. Before the cloud technologies emerged, when a company wanted to host their application, what they did was they used to host all the software components, that is the front end, the back end, and the database service on an individual server. So what happens here is, whenever you want to do an operation, like consider this website is for storing photos like Google Photos. So you upload a photo and then press the button upload in the website. So what happens now is the website does not process. It goes to the backend service. So whenever you click something here, so the process goes to the backend code. Some code is triggered. So what happens is that code runs, and after that, if you wanted to upload the photo, it will store somewhere. It will use the backend's help and it will store somewhere, and it will show the response in your website. Also, there needs to be information stored in the database because there is a name for the photo, there is a link where the photo is stored, and also there will be other properties like size and something else. So they will be stored in the database service. So what happens here is all the software components are hosted in an individual server. Whenever you wanted to do an operation, you click some button or do some operation on the website, which will trigger a service in the backend. So that will happen, and if there needs to be any data stored, it will be stored in the database and the output will be shown on the website. But what is the problem with hosting all the software components on a single server? The main problem is it has limited resources. So let me explain this. So consider your website is getting a lot of traffic and it is using 80% of CPU's resources. And at the same time, the backend service needs 50% of the CPU's resources to run operations in the backend. So what happens here is front-end service uses 80%, but the backend service only gets 20% of CPU's resources to work on. And if a database service wants to use some resources, there are none left for it to use. So right now, the system falls under a deadlock, and the whole server will be in a problem. So what happens is they cannot be scaled, and also this is the reason why the websites get crashed. Hosting all the software components on a single server is quite easy, but it comes with all these possible drawbacks and demerits. So what is the solution for this? Let me provide you the solution with an example. Let us see that. So the solution to this is using a distributed application architecture. So what is a distributed application architecture? It is basically using dedicated servers for each of the software components. The front-end software component is hosted on its own dedicated server, so does the backend and the database. So the front-end server only hosts the website, the backend server only does the backend operations, and the database server only is used when there is a need for the database service. But how does this improve the situation? So let me explain that. Consider the backend service under a lot of traffic or workload. So what happens now? Basically, in an individual server, when all the software components was hosted, so what happened there was backend server will consume most of the CPU resources, and the other services will not have enough CPU resources, which leads to a crash. But what happens here is only the backend server will be having workload on that. The other two servers will be left unharmed. So considering the backend server has used all of its resources and has crashed, the other two servers will not have any harm on them. The front-end server will still be hosting the website, and the website will be still visible to the users. Even though the backend services won't be running at the current time, the users will not be able to use the services provided by the website, but the website will still be visible on the browser. So how does this solve the scaling problem? In this particular architecture, you just have to scale the particular servers which you want to scale. Actually, so here we consider that the backend server is using all of its resources and you only want to scale that particular server. So you can just do that. You can just scale your backend server instead of scaling all the three components. Obviously, this is going to reduce a lot of cost and time. And for example, if you want to only increase the space for your database service and you want to scale your database service, you can just scale that. So to understand this better, let me give you a real life example. Let us consider Google Photos as the example. So here you can see the website. So this is the front end server, and the images which are being retrieved are using the backend service to do that. And also the links for these images, the data, that is the name of this image, the size of the images, are all stored in the database service. And whenever to retrieve this particular image, the database service provides the link and the backend service will use that link to show the image to us. So let us consider this and let me explain how all these services work together. So whenever you search anything on the search bar, so I have two images named hello and hello yes. So I'm searching hello over here. You can see there is photo ID over here 1 and 2. So the names are hello and hello yes, and the site links are this. So this is the site link for the first image, this is the site link for the second image, and the backend service retrieves these information and it will produce it over here. So this is how the front end, the backend and the database service is clubbed together. So now we have learned what is a distributed application architecture and how the front end, the backend and the database works together. So now let us move on and see what is AWS Lambda. So AWS Lambda is a serverless compute service, which means you don't need to worry about servers while building and running applications. You will just have to code as per your needs, save it in Lambda and relax. It will take care of everything else like provisioning servers. We will learn more in depth as we move along. So now what distinguishes Lambda from EC2 and Elastic Beanstalk? They all are compute services, right? But there is a difference. Let me give an idea about that. First, let us compare Lambda and EC2. Later we will move on comparing it with Elastic Beanstalk. Let me start with the first difference. Lambda is a platform as a service while EC2 is an infrastructure as a service. In Lambda it provides you a platform to run and execute your backend code, but in EC2 it provides you virtual computing resources. The second difference is that Lambda restricts to a few languages like Python, Java, C# and a few more. No restrictions in EC2, you can install any software you want in the platform given to you. And then you can choose the environment like Node.js or .NET and push your code into it in Lambda, but not in EC2. In EC2 you have to decide the operating system and then install all the required softwares, and then you have to upload your code or code internally and then execute. And then moving on, Lambda does not provide you the luxury of choosing OS and runtimes, but in EC2 you can configure every single aspect like different instance types and security preferences. So this is what makes them different. I hope you understood the difference between these two services. Now let us discuss what distinguishes Lambda and Elastic Beanstalk. Let me start off with the first point. Lambda can only run your backend code, while Beanstalk can run your entire application without you worry about the infrastructure which it runs on. Secondly, Lambda provides resources based on your workload, but in Beanstalk you have the flexibility to choose the instance type and other configurations. In Lambda you don't need to worry about any configurations or instance types. So the last difference is Lambda is stateless system and Elastic Beanstalk is a stateful system. So what is the difference between them? A stateless system is when the output is based only on the current inputs, not using any other inputs which were stored before. But in a stateful system, it may provide different values for the same inputs by comparing the older inputs. Being stateless provides Lambda the ability to create millions of process threads and execute them all with different inputs simultaneously. Okay guys, now we understood how does EC2 and Elastic Beanstalk services differ from AWS Lambda. Moving on, we'll first take a look at benefits Lambda provides and the limitations of Lambda. First, let us look at the benefits provided by Lambda. Later, we'll move on to the limitations of Lambda. The first benefit is that it provides a serverless architecture. So you don't need to worry about provisioning and managing servers. You'll just have to concentrate on building and running the application. So to be very simple, you will be given a console. You choose the language, write your code and hit run. It chooses an EC2 instance according to the required processing power. The next point is code freely. There are multiple programming runtimes and editors, so you can just choose it freely and code it in like how you do it in an offline editor like in Visual Studio or an Eclipse. The next point is no virtual machines needs to be created. You don't need to create and configure any EC2 virtual machines. As I already told, they are provided by Lambda according to the processing power needed for your function. The next point is pay as you go. Pay as you go is a feature provided for all services in AWS, and what is here is in Lambda you will be only charged for the number of seconds your Lambda function runs on for the particular seconds how many services have run, and that's it. You won't be charged anything more. The fifth point is monitor your performance. You have a default monitoring option in Lambda which is connected with CloudWatch and this particular Lambda function which generates multiple logs and metrics for you to visually and textually understand what is going on in your Lambda function. So whatever advantages a service provides, there will always be some limits to it. So now let us take a look at the limitations of AWS Lambda. The first limitation of AWS Lambda is the maximum disk space provided is 512 MB for the runtime environment. This means the /tmp directory storage can only store 512 MB at the same time. Why do we need /tmp directory storage in Lambda is that because we need a temporary storage for storing the current Lambda function's inputs and outputs, because the same Lambda function, there is no guarantee that it will execute 2 or more times. The next limitation is that the amount of memory available for Lambda during execution is 128 to 3008 MB. So this is the amount of RAM you can choose between either 128 or 3008, and between that it is a 64 MB increment, like 128 plus 64, and it keeps on adding. The third limitation is that the function timeout is set only to 900 seconds. So the maximum amount a Lambda function can execute is 15 minutes and the minimum is 3 seconds. So if you want your Lambda function to execute more than 15 minutes, that is not possible. It can only execute to 15 minutes and the default is 3 seconds. So maybe your Lambda function's execution completes in 1 second, but it has to run at least 3 seconds to stop. The fourth limitation is that the only available languages in Lambda editor can be used for writing the code. The languages are like Python, C#, Java, Node.js, Go and Ruby. Okay, alright guys, we've seen the pros and cons of AWS Lambda, so now let me give you a brief idea on how Lambda actually works. Okay guys, now let us move on. So first, what you do is you write your code on the Lambda editor or upload it in a supported programming language in a zip file. So it is not that you have to create only one Lambda function. You can create any number of Lambda functions your application needs. And after that, the Lambda executes the function or the code in your behalf. You don't need to run it. So, but to run the code, you need to trigger the Lambda function, right? So how do you trigger it? It doesn't run automatically. You need an external AWS service which can trigger and invoke the Lambda function. So for example, it can be an S3 bucket or a database. So what happens is whenever a write operation occurs in the database, your function should be triggered. So you set that as a trigger, and whenever a new record has been uploaded or inserted in the database, the Lambda function will be automatically triggered and retrieve the information which you need from that. So after that, we know that the Lambda code is running, but where does it run? It needs a server or a computer to run, right? So what it does is it provisions servers and also monitors and manages it. So how does it provision servers? So Lambda functions have various types of code. So if your code requires a lot of processing power, it will choose an instant type which has more processing power and RAM. Or else if your Lambda code only executes for 2 seconds, it will choose the lowest possible instance. This will save you money and time. Okay guys, now we understood how Lambda actually works. So what are the various concepts in Lambda? Let us look into it. So now we are going to see various concepts in Lambda, and the 4 concepts you are going to see is functions, runtimes, layers and log streams. So what is a function? A function is a script or a program that runs in AWS Lambda. So the Lambda, whenever it is invoked, this function runs. So you can see here, this is the function name, and here you write the code. So the function processes the event and returns a response. So let us see some function settings. So here you can see the code. The code is the logic you use in the Lambda function, which you write over here. And then runtime. Lambda runtime executes your function. So whatever runtime you choose, that particular code it will be written here. So that will be executed by the Lambda's runtime. And then the handler. The handler is where you mention the function's name with the file's name. So whenever the Lambda function is invoked, this particular function is executed. And then tags. Tags are key value pairs which you can mention for any AWS service just to track their cost or track their metrics. And then description is describing a function which you can give while creating a function in Lambda. And then timeout. You have to set the timeout between after 3 seconds to 900 seconds, because that is the capacity, or that is a timeout period for a function which I have already discussed in this session. So let us move on with runtimes. So what is a runtime? A runtime allows functions to run in different languages in the same base execution environment. That means in the same environment you can run a Python file, a Java file, and a Node.js file. And this runtime sits in between the Lambda service and your function code. So it is in between. So whatever code you send, there are multiple runtimes, and it will choose the correct runtime for your file. If it is Python, it chooses Python runtime. If it is Java, it chooses the Java runtime, and it runs and gives you the executed response. So also see, you can take a look at multiple various runtimes. So these are the latest supported runtimes, and these were already announced. So first it's .NET Core 2.0, C#, so and then Go programming language, and then Java, Node.js, Python 3.7, and Ruby 2.5. And the other supported languages are Node.js, but an old version 8.10, and Python an old version of 2.7 and 3.6. Okay, now let us see what are layers. Okay, so Lambda layers are a distribution mechanism for libraries, custom runtimes, and other dependencies. So instead of downloading using the code which you write in your Lambda function, you can create layers and store those particular libraries or custom runtimes which you want to run your program in, and you can store it in multiple layers, and you can create only 5 layers for a particular Lambda function, and you can upload it so that there is no confusions while the code is choosing a particular library or a custom runtime. For example, if your code needs to run a particular library which it needs for uploading information to an Excel sheet for a CSV file, so what you do is you upload that particular library to a layer, keep it in order so that your code chooses the appropriate layer and gets out the libraries. So after that, also your layers lets you manage the in development function code independently from unchanged. You don't need to change your code or resources that uses. You can just upload the information in a zip file as layers and take information out of that, and you can create multiple layers. The maximum number of layers is 5 per function, and you can use layers which is provided by AWS customers or already available layers, or you can create your own layer. And then comes the log streams. This is the part where you monitor the Lambda function. So normally Lambda automatically monitors your function invocations and reports metrics to CloudWatch. If you don't want to just watch metrics, you can write the code in your Lambda function so that you can get logging statements for each and every step your function goes through, and you can look at the execution flow and how your Lambda function is performing and whether it's working properly or not. So moving on, now let us see how AWS Lambda works with S3. So here we're going to see how exactly an operation in the S3 bucket can trigger the AWS Lambda function. So consider a user is trying to access a website which you can use to upload photos. So if you upload a photo here, it will be stored in the AWS S3 bucket which it is connected to. Also, whenever a put operation occurs, that is, when file is uploaded to the S3 bucket, the Lambda function will be triggered. So for example, you can use it as a put operation or a get operation. So consider it is a put operation for now. So whenever the user is uploading a photo here, so it gets uploaded to the S3 bucket, and when it's uploaded, the Lambda function is triggered. So the Lambda function's code can be anything. You can make any microservice out of it. So if you want to store the file's name and the location, you can store it in the database using the Lambda's code, or you can watch the CloudWatch metrics, and you can also look at the logs which you have coded in the context of your program. So after that, you can also copy this particular file into another S3 bucket using your Lambda code. Also, if it was a get function, like if it was a get operation, if the user is trying to download a photo, again the photo will be downloaded, which is from the S3 bucket which is stored there. So you can use that also as a trigger in the Lambda function, and you can make any microservice out of it. So this is how S3 is used as a trigger with Lambda functions. So now we understood how this works theoretically. So now it is time to move on for practicals. So now let us do an hands-on on creating an S3 bucket and then using a Lambda function to copy it to various multiple S3 buckets. So why does it go to various multiple S3 buckets is because we have mentioned a different type of file extension. So if it is an image, it goes to a different bucket. If it's a PDF, it goes to a different bucket. So whatever the file extension is, it goes to a different bucket. So let me explain that part now. Okay guys, now we are going to do a hands-on using multiple AWS services. So let me show you what we are going to do exactly before moving on with the hands-on part. So what we are going to do is, I already told you how Amazon S3 works with AWS Lambda. So what we are going to do is, we are going to create a simple website which can upload a file to the S3 bucket, and whenever a file is uploaded to the S3 bucket, the Lambda function is invoked. So what happens is, we are going to upload three types of files. One is a .jpg file, a .pdf file, and a .txt file. So whenever an image file is uploaded, it goes to the image bucket. Whenever a PDF file is uploaded, it goes to the PDF bucket, and whenever a text file is uploaded, it goes to the text bucket. And we are going to do this all with a simple Lambda code. And what we are going to do is, we are going to use the S3 buckets uploading, that is put as or post as a trigger, and whenever an object is uploaded to the S3 bucket, the Lambda function will be triggered. Okay guys, now let us see this on the AWS Management Console and how to do this practically. Okay guys, at the beginning of the video I told you that I'm running this file both on the local host and the Elastic Beanstalk. So to understand it better, first let me explain the local host part. So let me show you the code first. So this is the code. There are two files, one is index.php and the other is filelogic.php. So let me briefly explain this. This is a simple form which has an input and a button. So input is you click on a file, and button, whenever you press the button, it uses filelogic.php to execute the uploading to the S3 part. So here I'm mentioning the bucket which I'm going to upload to, and here you can see my credentials. So this is my region and version I've given latest, and these are my secret keys and the key which I have, so that it can access my AWS account and that particular bucket in my AWS account and upload it over there. So here you can see if that particular object with the same name exists, what it does is it adds $time in front of it. So if that same file exists, what it does is, normally if it does not exist, $key will be just $key. But if a file exists in the same name, if doc1.pdf and I'm again uploading doc1.pdf, so it takes the current time and adds it in front of the file name. So this is why we saw in the beginning of the video there was one doc1 and it had another doc1 file with a time duration in front of that. So now we have seen this code. Now let me show you the Python code which is used for the Lambda function. So in the Lambda function, using that, we are going to send this particular objects from one bucket to various buckets using their extensions. So let me explain that also briefly, and let us move on to how to do this using the AWS infrastructure. So this is the Python code, and first I'm importing some things which I need actually. So I'm importing JSON, I'm importing os.path. This is for getting the extension, and I'm importing Boto3. This is mainly important because Boto3 is the AWS SDK for Python. This allows Python developers to build and run applications on AWS using this. So you can write Python applications using Python programming language when you include this particular Boto3. So, and I'll explain this briefly. So this is the source bucket. I'm getting the name here. This is the file name. I'm getting it here. And copy source, I'm giving bucket, source bucket and key. So this is why I imported JSON. So I'm recording the copy source as the bucket which I'm going to upload it from, and this is the object which is going to be uploaded, and this is CloudWatch info. So if I print it over here, it will be available in the CloudWatch streams. Like, you can go to that log streams and check out these things when the function has started. So when the function started, this will be there, and after that this information will be given. So, and then here comes the logic. The logic is pretty simple. You first check whether the object exists. If it doesn't, you check whether extension. First you get the extension or the last 4 characters, that is either .jpg, .pdf or .txt. So even if it is a file with a different extension, if it is a .png, the file will only be available in that particular bucket. It won't be copied to any other bucket. If it is .jpg, it will go to the bucket image. If it is PDF, to the bucket PDF. If it is txt, it will go to the bucket txt. So s3.copy object bucket, this is the destination bucket, this is the file name, and this is the copy source, that is the file which you're going to upload from the bucket, that is from the bucket is the name of that particular bucket. So also if it does not exist, so this will be printed in the CloudWatch log stream. Okay guys, now we've seen the code, let us move on to the AWS implementation part. Okay guys, let us start from the beginning. So first you have to go to the IAM management console because you have to create a role. So first thing you have to do is you create a role. I've already created a role test. So I'm going into that and you have to attach a policy. And I've created a policy already which is s3_move. So you have to create a policy and use this particular JSON code inside it. So I'll explain what this means. So I'm giving effect allow and also over here. So here I'm giving the actions logs, create log group, log stream and events. So I'm allowing all these events to happen in the CloudWatch whenever I'm using this particular policy. So in S3 I'm allowing all operations like post, get, put, whatever operation it is, I'm allowing it to happen. So I'm giving effect as allow. Also they should have a unique resource name, so I'm providing that. So without this particular policy and role, you can't do this. So you can't basically do what I'm going to do right now. So we cannot copy S3 buckets objects into multiple S3 buckets. So you have to create this role and policy and use it in the Lambda function. So the first thing we are going to do now is we are going to create 4 different S3 buckets. One is from the bucket, which is the main source bucket, and we are going to create 3 more buckets which are for image, PDF and text. So let us do that. Before moving on with the S3 part, let me tell you how to do this without copying and pasting this JSON code over here. First you have to create a role which lets Lambda call other AWS services. So here after clicking on create role, you have to choose Lambda so that it can be calling other AWS services. And next you have to give it permissions. You can see here there are a lot of permissions, that is there are policies available. So before we created a policy s3_move and we pasted that JSON to allow access to CloudWatch logs and S3. So what I'm going to do now is I'm going to give full access for S3 from searching here. So I searched S3 full, so I got full access for S3 and I'm searching CloudWatch.
Just a quick info guys. If you want to make a career in cloud and DevOps, then Intellipaat provides an advanced certification in cloud computing and DevOps by ENICT Academy IIT Roorkee, and it is taught by IIT Roorkee professors and industry experts. This course is designed to help you upskill and land in your dream job. Now let's continue with the session.
CloudWatch full. So here you can see I got CloudWatch full access too. So I gave both. So next I'm going to tags. I don't need any tag. So I'm reviewing. I have to provide a role name. So I'm going to give this as practice because I'm not going to attach this. I'm just explaining you how this is going, how to create a role and how to attach policies to it. So you can see here there are 2 policies attached, Amazon S3 full access and CloudWatch full access. So what I'm going to do now is I'm going to create this role. So I've provided create this role and now the role has been created, and as I showed you before, here you can see this, and also I can go into the policy and show you the JSON part. This allows all the actions for S3, and the other policy allows all CloudWatch actions. See, you can see in the JSON, so you can see here it allows everything. So it allows all CloudWatch actions. So that is what I wanted to show you. Now let us move on with the S3 part. So I'm opening the S3 management console. So I already have a bucket. This is for a beanstalk I created earlier. So now let's create 4 more buckets as I told you already. So first bucket is from the bucket. So this is what, so you don't need to configure anything. You don't need to give any tags. So you just click next and it already sets permissions. So block all public access, and also if you want you can review it once and then create bucket. So this is how you create a bucket. It's actually pretty simple. So then I'm creating to the bucket image, and I've created that. Okay, next thing is I'm creating to the bucket PDF, and I'm giving next, 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 and create bucket. And finally I'm creating to bucket text. So I'm giving next, 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 and I've created buckets. So right now we have created 4 buckets, the 4 buckets which we need, which is in the code for us. So what I'm going to do now is I'm going to move on to create a function in the Lambda. So first what we'll do now is we'll go to the Lambda management console and create a new function. So you can see here I already have a function. So let me create a new one. So author from scratch, use a blueprint and browse serverless apparatus or repository. So using a blueprint is that there are already many things. So here S3 get object Python, config rule change triggered. There are many things. So what we are going to do is we are going to author it from scratch because we are using our own code. So I'm giving the function name as AWS Lambda, AWS Lambda demo, and I'm writing my code in Python, so I'm giving Python 3.7 as my runtime. And another thing, so what I told you, we have created a role and attached a policy to it. So we have to use an existing role here. So the existing role which I told you was test. So I'm using that particular role here. I'm creating the function. So the function has been created successfully. So what we have to do now is see, I'll first explain the dashboard. So here is the configuration and here is the monitoring. So you can see CloudWatch metrics and CloudWatch logs insights. So right now it is loading. So let us see. So it will be empty right now. After the function starts executing, then we can see some data over here. Also we can see the logs in CloudWatch. Let me show that later. So first we'll configure it. So first I'm adding a trigger. Our trigger is going to be S3. So also what I'm going to do is the bucket is actually from the bucket. So whenever an object is uploaded to from the bucket, it has to be triggered. So our bucket is from the bucket, and here I'm put post or copy. So however it may be, if an object is uploaded to from the bucket, it triggers and the function starts executing. So it is all object create events. And here I don't need to give anything. If you just want to copy one particular suffix, like if you want to copy only JPG files, then you can mention it over here. So right now I'm implementing that in the code, so you don't need to give that. Also give enable trigger here and add it. So this trigger will be added. So you can see here trigger has been successfully added. Okay, so the next thing is now we have to use the code here. So you can already see there is a code written, a simple code. So let us consider this as our runtime right now. So the runtime is Python 3.7. This is the editor to edit the code. This is the handler which I showed you. So lambda function underscore lambda function dot lambda handler. So even my definition, even my function's name is lambda handler. So I don't need to actually change anything over here. So let me copy that code and paste it over here, and let us save this particular lambda function. So I'm going here, I'm copying this code, I'm pasting it over here. So the code has been copied. So you can see the imported function, imported libraries, and here is the print function, and here is the CloudWatch info, and here is the logic to copy from S3 to another S3 bucket. So now let us save this. So once we save it, it is saved. So now whenever an object is uploaded to the S3 bucket from the bucket, then this process will start happening. First let me show whether it happens or not. So you can see here from the bucket is empty, and to the bucket image is empty, and even these two will be empty because we just created them. So right now I'll manually upload a file to from the bucket. So I'm adding files, I'm adding this image, I'm providing next, 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 and upload. I'm uploading this file to from the bucket S3. So you can see here that the file has been uploaded. Now let us cross check with to the bucket image. So it has to be uploaded to the bucket image because our Lambda will be triggered right now and that function will be running and this process would have happened. So I refreshed it and you can see panda.jpg file has been uploaded here. So right now it manually works. So what I have done is I've created a simple web page which can upload files to S3 and then the process happens automatically. So what we are going to do now is we are going to create the same web page which was running in the local host. Now we are going to make it run in the Elastic Beanstalk using a URL. So anyone can upload a file right now and it gets segregated according to the extension and it gets copied. So I told you after execution of the function you can see the CloudWatch metrics. So let me go to monitoring. So here you can see CloudWatch metrics and here you can see some data. So this is invocations 1. So the function has run one time and the duration is given here, and also the success rate was 100%. There was no errors. So you can see that here. Also let me show you the logs. So a log has been created. I'm opening that. So you can clear. So function start CloudWatch. So let me open the code first. Okay, so here function start CloudWatch, and you can see the details being delivered there. So log stream name, log group name, request ID. So log stream name, log group name, and request ID has been. So after the request ended, it is ending the report and the report has been sent. And you can see here it took 566.10 milliseconds and duration was 600 milliseconds. So it is rounded. So memory size, the maximum memory size was 128 MB. So there was no more memory needed for this function. So now let us move on with Elastic Beanstalk and we'll create and deploy a Elastic Beanstalk application over there. So let us get started. So let me click on get started. So first thing I have to do is I have to create an application. So my application is going to be AWS Lambda demo and I have to choose the platform. So my code was in PHP. If your code was in any language, like if it was in Java or Go or Python, you can choose that. So right now I'm choosing PHP. What I'm going to do is right now I'm going to create the application. Later I'll upload the code to make it more clear. So the application is creating right now. So it would take some time. So let us wait and start the processor. Okay guys, now you can see it has been created successfully. So let me show you what actually is there before we do this. So there is a default PHP page over there. So this is the default PHP page and what we're going to do is now we are going to upload and deploy our application here. Before that, let me explain what actually there is a little change in the code because okay guys, before uploading our application and deploying it, let me show you and explain you the simple change which I made in the code. So this is the code. So here you can see index.php. So there is no change in this, but in filelogic.php you have to change the path because you're going to upload it to an Amazon Linux environment and the path changes there. So it is /var/app/current/your file. So index.php and filelogics.php will be in this directory and whatever file you upload to Elastic Beanstalk will be in this directory. So what I'm going to do is you have to click on all the files and choose over here and you have to archive it into a zip file. So if you ask why should we zip it rather than make the file a RAR file or a tar file, because Elastic Beanstalk environment only accepts .zip files. So you can just do it in a normal way. Instead of using WinZip, you can just click on them and you can just send them to a compressed file which will automatically create a zip file. So I've already done that. So now let us upload this file to the Elastic Beanstalk. So let us upload now. So I click on this button. So I have to choose a file. So what I have to do is I have to go back. We go to AWS demo. So this is the file which I have to upload. So AWS uploads file logic and index files are within this particular zip file. you should not create a file on top of this and give that. You have to create a zip file just clicking on these files. So I'm opening it and I'm naming it as AWS Lambda demo. So it is AWS Lambda demo. So I'm going to deploy this. So deploying it takes time. So let us wait until then and we'll check out how our application works. Okay guys, now our file has been uploaded. You can see the running version is AWS Lambda demo. This was the name which I gave for this particular application. So now let me open the URL and show you the website which is running. So here you can see our website is running fine. So what I'm going to do now is I'm going to upload few files to this and check whether it gets uploaded in our S3 bucket and it is moved to the respective S3 buckets for image, PDF and text. But before uploading, let us check whether the S3 buckets are empty or not, so that to make sure that there were no files before and only the uploaded files are getting uploaded right now. So I'm going to, from the bucket, it's empty, and I'm checking all the other buckets just to make sure. Okay, now all the buckets are empty. Now let us upload few files. So I'm going to upload 3 different types of files and check whether each of the file goes to its respective bucket. So first I'm going to upload a PDF. It is successful. And then I'm going to upload an image and it is successful too. And then I'm going to upload a text file. So first let us check whether all these files have been uploaded here. So now we can confirm that the doc1 PDF, doc.jpg and text1.txt have been uploaded to the S3 bucket. So now let us check whether each of the respective files with different extensions get uploaded to their dedicated S3 bucket. So first let me go to the bucket image. Let me refresh it and you can see the .jpg file over here. So next to the PDF bucket and you can see the PDF file over here. And then to finally to the text bucket and I'm refreshing it and you can see the text1.txt file over here. So right now our Lambda function is working and it corresponds with whenever we are uploading a file through the Elastic Beanstalk. So Elastic Beanstalk is successfully running our application and it gave us an instance to run it on. So whenever you upload a file using that, our files are getting uploaded to from the bucket and Lambda function is triggered, and using this particular logic, if it is to the bucket image, it goes to the bucket image and then PDF and then text. So this is what happening in our hands-on. So before finishing this hands-on, first let me explain the complete process which we did to make this happen. So first we created a policy and first we created a role and we attached a policy to allow all the functions which we wanted to do in the S3 bucket. So and then we created 4 different S3 buckets, 1 for source, 3 for destination. And then we created a Lambda function and we uploaded a code which basically copies from one particular S3 bucket to a S3 bucket which we give the destination name. And we also created a trigger for S3 which is whenever an object is created. So from S3, from the bucket, whenever an object is created, this particular trigger happens and this function code runs. So this function code runs. So whenever this function code runs, what happens is a file from the particular source S3 bucket is copied to the destination S3 bucket. And then what we did, we launched our application, we uploaded our local application into Elastic Beanstalk and we deployed it. And we right now have an URL to run our application. So then now we are going to see CloudWatch. So let me refresh it once more. So we've uploaded multiple files after that and you can see there are multiple logs over here. So this was the first time, and then you can see whenever the next time the function is coming as function start, and that is the next function. So the function will be keep on running. So you can see log stream name, log group name, request ID. This is one particular function execution and this is one particular function execution. This is one. So the function has been executed this many times and the function was started at the first time. So this is how we have to use CloudWatch. Also, you can see the CloudWatch metrics over here in the monitoring tab. So here in the monitoring tab in CloudWatch metrics, now you can see there are totally 5 invocations. So the CloudWatch has been invocated 5 times. That means the function has been run 5 times. And here you can see the success rate. The success rate has been 100% and there are no errors because all the files which we were uploading got uploaded and the function never got any errors and it ran successfully. So right now I hope you guys know how to use Lambda to write a code and use that and use other services like S3 as a trigger to run your particular application. So right now we've learned multiple services. We learned IAM so that we have to create a policy first, and then we know how to create S3 bucket. We know how to write code in a Lambda editor, and then we know how to use CloudWatch, log streams and also metrics, and also we learned how to upload your local application into Elastic Beanstalk so that you will get your own URL and you can access it from anywhere in the world. So use cases of Lambda. There are various use cases of Lambda, but right now we'll discuss 3 of them. So the first one is the serverless websites. The second one is the automated backups, and the third one is filtering and transform data. So let us see serverless website. So I already told you what is a serverless architecture. A serverless architecture is where you just have to code and it automatically takes care of provisioning and managing servers and its infrastructure completely. So what you can do here is you can host your static website on S3. Your static website is basically HTML, CSS, JavaScript or TypeScript files. It cannot run server-side scripts. You can only run client-side scripts. So in server-side scripts like PHP and ASP.NET cannot be hosted on S3 as a static website. And using S3 for static hosting is very cheap. And you can write Lambda functions and connect them with the S3 to correlate it. You can make your static website available using AWS Lambda by writing some code so that the users can keep track of any resources which is being used on the website. So next is automated backups. So the word says you everything. The sentence, the automated backups, you can automatically create backups. You can create Lambda events and schedule them at a particular time on a particular day and create backups automatically in your AWS accounts. So to create backups, you can check whether there are resources idle and take those content and just back it up and delete it from that particular place. And also you can generate reports using Lambda in no time using code or just connecting it with CloudWatch. So you can generate every report and you can see how much of data has been backed up, how much of data has been deleted, and you can manage it very easily and schedule it on time. So the third use case is filter and transform data. So you can connect Lambda with other Amazon services like S3, Kinesis, Redshift, and database services like RDS, DynamoDB, or Amazon Aurora. So you can filter the data before sending the data to any Amazon storage service or database service. You can filter them using the code, and you can easily transform the code and load the data from between Lambda and to all these services. Now let us discuss Lambda pricing. First, let me explain what is free tier. Free tier is provided by AWS for a 12-month period, and in that period you can use free services which are provided by AWS. You can use free tier eligible services. You can use services like EC2, S3 and even Lambda for free, but they have their own limitations. For example, in Lambda, you can use 1 million requests per month or 400,000 GB seconds of compute time per month for free, and anything exceeding that will cost you. Also, you might be guessing what is GB seconds and 1 million requests. 1 million requests is when the Lambda function is triggered 1 million times, and GB seconds is gigabits, that is 1000 megabits per second, that is the transfer rate. So 400,000 GB seconds of compute time per month is allowed. 400,000 GB seconds of transfer time is allowed per month for any given Lambda function. And then requests, as I told, 1 million requests are free, and then after that each 1 million requests costs you $0.2. And after that duration, I already told you what is GB seconds, so 400,000 GB seconds per month is free, and after that every GB second you use will cost you the number which is given there, that is $0.000166667. So that is all about Lambda pricing.
We have seen the various Amazon services. We are going to learn about some more services on the management side, the deployment and managing of Amazon services. Till now, if you see, if you want to deploy applications, you might be using EC2 EBS. For monitoring, you would use the CloudWatch. For storage, S3, even EBS would be helpful for your persistent storage. For scaling, auto scaling, Elastic Load Balancer and CloudWatch. VPC for security, IAM for security, RDS for database. Now, we will be talking about the deployment and management. How do you deploy your application better way? How do you manage them better way? That is what we are going to cover. The Amazon Elastic Beanstalk. We would see what is Elastic Beanstalk. We would see about the key features. Now we are covering a few services where it's very important for us that we understand why they are used. We might not be going so deep down, but at the same time, their understanding why this would be useful and how would I use that service, it's very important for us. Elastic Beanstalk is a easy to use service for deploying and scaling web applications and services like Java, .NET, PHP, Node.js, Python, Ruby, Go, Docker, whatever stack you want to work with, it is available. What it does is, if you are a developer, suppose you are a developer, you want to deploy your application on Amazon. What are the steps you would be creating? You would be creating an application. Now it's a Java, you might be creating a var file or jar file, something like that. For .NET, it might be separate format, something you would be making over there. Whatever the version of your code, you would be uploading that to an EC2 environment. So you would be launching an EC2 environment. You would be managing this environment. So the management includes so many tasks like security, AMI creation, server setup, let's say your Tomcat or PHP or whatever, your load balancer, your auto scaling. So version management, whenever new version is coming, that you would be doing with the AMI also. Backup management. Now, log management. All these tasks you are doing in managing environment. What if there is a tool available which would be doing all these tasks on behalf of you? All these tasks it's doing on behalf of you. You only need to focus on creating an application and uploading here. Everything else is being taken care by this environment or this tool. What would you call that? Yes, I'm sure you would be saying it's an elastic beanstalk, you would call it. No, there is something different word also. It's a very easy to use, very simple. And the advantage is it gives you very quick deployment options. It supports various stakes, multiple stakes. It also supports the automated deployments. It's available free of the cost. No charge at all for all this management. Yes, any resource it you launches, like it launches an instance, it creates a load balancer, whatever it is doing, that would be, it's charging for that. It's a scalable because it's doing all this scaling activity on behalf of you. Highly reliable. It does support your version management too. This is a PaaS offering. It's a platform as a service offering for you, which is managing all the platform for you. Your deployment, scaling, backup, a platform is offered to you. If you remember in our cloud computing video, we talk about this. This is a PaaS, which helps me manage my platform. Here, Elastic Beanstalk, where the developer would have a full control. Here you would have a root access to your EC2 instance also. And in that same instance, you can create your own applications also. It does support auto scaling, elastic load balancer, RDS, CloudWatch, so integrate with those application services. It also helps you make your custom AMI. If you want to make your custom AMI, you can do that. Let's not stop that only Elastic Beanstalk is doing this. Elastic Beanstalk says, I am doing everything on behalf of you, but you are also free. If you want to do something more, you can do that. Important is, if you want to manage load balancer, you want to manage the auto scaling, you want to manage the CloudWatch part, you want to manage the EC2 configurations, Here with Elastic Beanstalk, everything available monitoring at single place, easy to manage for you. It gives you an automated deployment, automated version management. It has the manage environment settings. So all environment settings are managed by it. You can always modify that. Whenever you upload a version also, new version, it keeps the backup of the older version also. And whenever it is deploying this new version, it would automatic restart of server and AMI creation would be taken care by it. Whenever this version is doing, it also manages the log for that. So everything is easily managed by you with the Elastic Beanstalk. If you see under the hood, underlying how the Elastic Beanstalk would work for you is, it gives you an environment where you would have a, when you create an environment, it would be creating a various EC2 instances. That each EC2 instance would have a internally, if it's a Java stack, it would be having Amazon Linux. On top of that, there would be an Apache and Tomcat install out of that. Only thing you need to submit is application. Application would be automatically deployed on Tomcat. A log file would be created for that over there. Automatically it would be making an AMI also out of this. And this whole environment would be managing, it would be if required creating auto scaling, load balancer, everything it would be creating for you. If it needs to replicate more environment, it would be doing everything managed by Elastic Beanstalk. Let's see the demo of the Elastic Beanstalk and see how it helps us. So I am in my AWS console and I am going to the Elastic Beanstalk. Here currently I have no application available. As we say, it supports the multiple platforms: Java, Node.js, PHP, Python, Ruby, Tomcat, IIS, Go. These are the web servers you want to, or Dockers also, the containers also it supports. Pre-configured Docker with the Glassfish, Go, Python, it supports that. I can go and say create a new application on top. I give name something like this. For Elastic Beanstalk, I shouldn't write. Now, which web server do you want to use? Do you want to use the web or do you want to use the worker environment? The web means you are going to deploy an application with the web server like Tomcat or something like that. I can say create. I'll say I'll go with the Java. Do you want to go with the single instance environment or do you want to go with the load balancing environment? I say go with the load balancing environment. I am okay. Now, do you want to upload your own application or you say no, use the sample application only? Whatever the sample application available with this Beanstalk, you can do that. It also supports the how do you update your application also. Sometimes you want to update your application. What you can do is, if it's a with the load balance and all that, you can say 30% of the fleet only update that time, or only whenever you're applying a batches or patches, whenever you're applying new application, do it for one instance at a time, then do for the rest instance. Then this is my environment name would be, and my URL would be something like this. Let me check it's available or not. It is available. I just give some description and I say next. Do you want to create an RDS database also with that? If you want to, do you want to create this environment inside a VPC? I say yes, create inside a VPC. Okay, which key pair you want to use? I say use my original key pair, Intellipaat. Do you want to get notified anything about that? I say yes. Do you have any application health check URL you want to specify? I say no. Whatever the load balancers, these are the, now you see, these are all load balancer settings you are doing. You are making those checks here. Automatic updates, health checks, cross zone load balancing, connection drainage, everything you would be supporting here. What would be your root volume? Do you want to say magnetic general purpose provision? I say general purpose. Do you want to specify your size of the root volume? I say no, go ahead, whatever is default, I would use that. What is the key? Name. So name is already we have reserved. So if I want to give additional tag saying that environment, it's a demo environment, I can say that. Which VPC do you want to use? I say this is the default VPC. I want to go assign a public IP address. Yes. Do you want to use the ELB supports all zones? EC2 also supports here. So auto scaling would be also supporting. So here we are supporting for the ELB and the auto scaling, which zone it would be used. VPC security group, I can say use my Intellipaat security group. Elastic load balancer visibility, it's a external only, it should not be a internal. Do you want to create a role? No, I'll just go ahead with whatever it is. These are the settings we have configured. So you see application information, environment, it's a web server, 64-bit Linux with load balancing and auto scaling. Sample application we are using. Environment name is this. This would be my URL. It's a t1.micro. Key pair is Intellipaat. General purpose volume. VPC with security group. All is configured and I'll say launch. It has started creating environment for me. Isn't that easier? Everything is being taken care. Now we learned the load balancer, we learned the auto scaling, how do we configure everything. Here everything is taken care by a single platform. Wouldn't that be a fun and easier way to manage? It would be creating each and every. So you can see the log also at the bottom. What it is doing. Whenever it keeps doing everything, it would keep adding the things at the log also. So we can see, till the time it logs comes, we'll see different part. When I go to the configuration, you can modify various configuration. As I mentioned, it's one place to monitor or manage all your configurations. So here you can say, this is my auto scaling configurations, where it says number of instance 1, auto scaling by entity also defined here. So it says currently there is 0 instance, but minimum and maximum is set. It says minimum is 1, maximum is 4. It supports all availability zones. Cooldown period is 6 minutes. Scaling triggers are also set that on network out you scale out, network in you would be scaling up. So scale out means adding one instance, or scale up over there. Scale in means you are decreasing the instance. If you want to set up the time based, schedule based scaling, you can also set up that here. You can add a schedule event also here. So this is how you are configuring your Elastic Beanstalk with that. I come back to configuration. You would also see this is the instance type, storage type. If you want to modify that, you can do that. This is the notification. This is the software configurations. How the updates would be deployed. Your networking. So this is your load balancer thing. You want to set up, this is the listener port. If you want to use the SSL with that. Do you want to enable the session stickiness? Health check interval. This is how we configure health check with the elastic load balancer. So all the elastic load balancer parameters in a single page. Same way all your VPC parameters in a single page. Now remember what is happening. Till now we learned the various services. We learned the EC2, we learned the EBS, we learned the auto scaling, we learned the load balancer, we learned the VPC, we learned the CloudWatch. Now you see combine of everything is available in a single page. This is your pass. Gives you the power to manage your application. It would also keep generating the logs. What is happening? Currently, since application is not logged or launch, after that it will start generating the logs and do that. It will keep checking the health of this also. What is the instance ID? What is its status? You can see also here very easily. So load balancing request, latency, how it's performing, load average, everything available here easily. You can do your own monitoring with the CloudWatch. Alarms you want to configure, you can add alarms also. If you want to subscribe to various events, you can do that. You have given certain tags, it would be doing the tags also. If I go to my EC2 by now, you would find that it has started launching one instance for me. The demo name which we give, it is the URL of this. This URL it is working on. It is having the various security groups. So it is having 3 security groups. One is Intellipaat, which says 80 and 22. Should just check the rules here. We can check the rules here. So it has opened 80, 22, 80, all rules it has opened here. So this rule it has added from the second rule is coming from this new security group it has created. The new rule says open port 80 for this security group. Now what is the security group? We will see that. This is SG414, which says open for some elastic load balancing security group. That's a 94. I add the second group also. This group allows over 80 traffic. So now load balancer is allowing the traffic on port 80. My security group allows traffic from port 80 from load balancer only. So if I directly try to hit this URL, it would not allow me. It would allow me because I have another security group which is added. That's Intellipaat. If I remove that, it should not work. Rather, it should not allow port 80 directly with this. Even if I have not selected Intellipaat, that is okay. It was not required because Elastic Beanstalk has created its own security group and manage everything on behalf of me. I believe everything is ready for me. It's still creating. Let's check the URL if it's available and working for me. You can see that's ready. Your first Elastic Beanstalk Java application is now running on your own dedicated environment in the AWS cloud. You can see how do you work with the Elastic Beanstalk. That's the links they have just given. How do you work with the logs? These are the things available. But this is my application is set up and running over here on port 80. So this is how you will be setting up your environment and how it would be working for you. We can now go ahead. We can see this is the environment. It must have created a load balancer also. A load balancer is having a URL something like this. This URL is mapped with my Elastic Beanstalk URL. And this is how it is managing. My load balancer is managed with the URL. So that is managed by the Elastic Beanstalk internally. It would not be using my Route 53. It would be using the Elastic Beanstalks, and how this load balancer URL is mapped, that is managed by the Elastic Beanstalk. But overall, everything, yeah. If you want to give a sensible name to this URL, then you can use the Route 53 on your own. You can use Route 53 and manage this. Otherwise, you can directly use your own or whatever they given by Amazon, you can use that. So this is how the Elastic Beanstalk works. We are going to learn about the AWS DynamoDB. For that, first we would try to understand what is a NoSQL database. We would have an introduction to DynamoDB. We would have a key DynamoDB terminology, and then we would have a hands-on on the DynamoDB. Generally, when you have an RDBMS, that's a relational database, what does it follow mainly? It follows the ACID properties of a database: atomic, consistency, isolation, and durability. Now, in some cases, it's not possible to follow the ACID. Plus, when you see a database structure in a table, what would happen? If you have a suppose you need an address record. You have a 10 fields. 6, 7. For now, keep it 8 or 9. Now each column or each row would have the same number of columns. Whether you are using or not using, it would always have same. That is the rule of the RDBMS. But in some cases you need only 2 columns. In some cases you need only 4 columns. In some cases you need completely different data structure. Is it possible to achieve with the RDBMS? No, the ACID properties does not allow that. What if we have a completely unstructured database? Unstructured database means in one row you want 3 fields, you get 3 fields or 4 fields. In one row you need 10 fields, you get those 10 fields here. In one row you need only one field, you use that only. This is the unstructured, and it may happen that whatever the data is in row 2 might not be similar way, the columns might not be similar as row 1. They all would be different. It's a kind of a schema-less unstructured data. NoSQL database is an unstructured database. It stands for not only SQL. It doesn't mean that it doesn't have the SQL. It means not only SQL. There are popular NoSQL databases like MongoDB, Cassandra, CouchDB, and many more. Amazon is having its own offering called Amazon DynamoDB. That is the NoSQL offering from Amazon. Amazon DynamoDB is a key value store where everything is stored as a key and there would be a value corresponding to key. So for example, you take the data of a citizen. A citizen would have some unique ID to identify that. Now one thing it would have is its a name, email, address, phone, everything. One would have this ID, but only its education, you have not much information. One would have its a name plus it would have some more data like its a name, phone, email, address, education, graduation, job information, his personal information, everything would be one row might have that. So it's a completely unstructured. You can do this with NoSQL. So important is there would be a key and each key would have a corresponding values. It's a highly scalable and fully managed database. Now what do I mean by the fully managed? The fully managed database means you don't have to worry about the database creation, database scaling, database backup, security patching. You don't have to worry at all about that. Everything is being managed by the Amazon itself internally. High availability, fault tolerance, everything, even scaling. So what you have to go is you have to go and create a table only. Even you don't have to create like we in RDS we were creating a database instance and inside that we created a database and there it had a database tables. So where we were responsible for managing backup or if we require snapshot. Though RDS provides all the mechanisms, or we have to plan for the multi-AZ, we have to plan for the failover, we have to plan for the performance with the read-only. Even we have to select the instance type, large, small, extra large. Nothing here. You just have to go and select a database or directly create a table only. Now what is the advantage you get here is with this, since it's a fully managed, you would be now able to work in a way that it would be able to, you just have to define the performance. What are the concurrent users you would have? Only thing you need to define is that, and based on that you would get the throughput, based on that automatically it would be scaling, automatically security patching, fully it will be managing on behalf of you.
Just a quick info, guys. If you want to make a career in cloud and DevOps, then Intellipaat provides an advanced certification in cloud computing and DevOps by ENICT Academy IIT Roorkee, and it is taught by IIT Roorkee professors and industry experts. This course is designed to help you upskill and land in your dream job. Now, let's continue with the session.
You can access through console and APIs. It doesn't have a separate database client like in MySQL we use the HeidiSQL, or you can use the Toad, PLSQL Developer, MSQL Studio, something whatever you are using. Here there is nothing like that. It is only through console or APIs you would be able to use that. very high performance, and you can dictate your performance also. You want to say I want the 1000 reads 500 writes, or I want the 10,000 reads 200 writes. What is your performance required, you can define and you get that. It's a fully managed, so automatic hardware and software provisioning. It's internally secure, all the data encrypted. It does manage automatic patching, upgrade everything. Very, very, very easy to use. So we saw that DynamoDB is a fully managed scalable database, and it gives you predictable and controlled performance. The predictable and control means you can define what kind of a performance you want. You define and say what is your requirement. It comes with a built-in fault tolerance. So whether it's a working fine, not fine, it's everything is defined here. Automatically it would be internally, if it fails, like we saw the case of the elastic load balancer RDS, inherently it's a fault tolerance and it would be start serving you from the different infrastructure. Very flexible. What's your requirement? So you watch your concurrency requirements, otherwise it's scalable, easy to use. It can integrate with the Amazon's own Hadoop offering called Elastic MapReduce. It can work with the CloudWatch for the monitoring it provides services. It gives you strong consistency and atomic counters. So there are two kinds of a consistency model it offers, which we will see in a while. When you go to the DynamoDB in RDBMS, if you go, it would have a table. Each table would have a row and a column. Here, it would have the table, but then table would have an item and the attribute. You do not need to create a database, just create a table. And DynamoDB database itself is a collection of table for you. So table would be collection of the data. In each there would be an item which is nothing but a group of attributes. And this attribute is nothing but a fundamental data entry or the how the data is stored. For example, you have a training record. So for that you have a given unique ID, that's ID number 1. Who is the trainer name? ABC. Which training did he take? That is the AWS. On which date did he take? This is the date. What was the rating? 4 or 5? Whether course material available or not. In some case it's not that. It would be who took the training, that's a XYZ. The training is still not ready, so you just have that content ready or not. It's not ready. In third record you would have a trainer name, trainer email, trainer rating, date, follow-up session, hands-on session, training material available, feedback, and many more attributes. Each and everything, this what you are seeing is an attribute. You can say attribute is like a column in database, but the difference is it's a fundamental data entry and it can be unstructured in a way that multiple attributes make one item, and each item can have a different number of attributes. In our RDBMS, each row had same number of columns. Here you can see one item has a 2 attributes, another item has a 10 attributes, another item has a 6 attributes. That's why besides the key attribute, this is the key attribute. That's where the record is identified. Apart from that, everything else is unstructured. Each attribute is identified by a primary key. In the primary key is nothing like through which you identify. The primary key are of two types. One is a partition key, which is a simple primary key, which is composed of one attribute known as a partition key. That's like a normal primary key. Apart from that, there is a partition key and a sort key. This is like a composite primary key. Sometimes you want to say the training record and then the trainer name. Both should be combined because one training is conducted by many trainers. So here the trainer name would be a sort key and the training ID would be a partition key. So one would be having a multiple names over there, or training name would be. Till now we have learned the various services and covered about the Amazon CloudFront and Amazon Import Export with the Snowball. Amazon Simple Email Service. You would see what is Simple Email Service, where this is used, what are the key features of the Simple Email Service, and we will see a demo of Simple Email Service too. Amazon SES is a cost-effective, scalable email service. It is useful to send the bulk emails. Remember, this is not your replacement of your Gmail or Outlook mail. No. But if you want to send a bulk mail, transactional mails, huge number of mails, this is the ideal solution for you. A few months back, Amazon SES also started service called Receive Email. Initially, it was only for sending email, where the mails would be received, delivered to your AWS S3 bucket. But the major purpose is it's used for the sending email. Important aspect is it supports pay as you go model, very cheaper. Free tier gives you almost 50-60,000 plus emails in a month, free of cost for up to a year, and then over again also it would be charging you 6 cents per around 1000 emails. So that's a very cost effective and cheaper service. It's a highly reliable and very scalable. Simple email service, easy to use and very scalable. Important is it gives you a feedback loop mechanism also. So whenever a mail is bounced due to any reason, over quota or due to the wrong email ID, it gives you back. And it also keeps track of that how many mails from your end are bouncing. And with this feedback loop, you can always increase your delivery rate. It does work with the Amazon other email services or other services. It can integrate with them. And it is a very easy to use interface. We will see that also in a demo. Where it would be useful. When you want to send for bulk and transactional emails, it's a perfect support. It does support the SMTP also. So you can use the SMTP to send the emails using Amazon SES. It does support the receiving emails also and deliver them to the S3 bucket. But do not use as a junk email, as AWS may stop your access. Remember, that's a very important point. If you try to misuse the SES as a junk email for sending junk or hacking or some other purpose, Amazon would stop your access, because Amazon keeps giving you feedback, what your success rate, everything, and it also keeps track of that. If it finds there is a huge number of bounds and your production access may be stopped for SES, it would not allow you to send more emails. It's very important you use it wisely. It's a very cheaper email service for delivery, cost effective. And those emails are bound to fail. We know that emails may bounce. So it doesn't mean that if one or two mails fails, Amazon would stop your production access. No. But it evaluates you. It continuously keeps checking what is your bounce percentage. If you send 1000 mails and 10 mails bounce, that's okay. But if you send 1000 mails and 600 mails bounce, there is a serious problem. If there are a huge number of complaints received from your email, or the quality of email is not good, it keeps checking how much bounce percentage, how much complaints, how much overquota, something like that, and it thinks, okay, there is something wrong. SES takes those parameters very seriously, and it can reduce your production access. But if your bounce percentage and the quality of email is good, it's within a measure, that measure is defined by Amazon, SES is very cost effective and service for sending email for you. How would you use SES? When you sign up with the SES is having a two modes. First is you have to sign up with a simple email service. Initially you would be using beta access. During the beta access, whatever email you want to send from, so if you want to send from my email ID, learnawsonline@gmail.com something, and you have to first verify those emails before you can send from that ID. Even if you're sending a mail to abc@abc.com, you have to still verify that email ID. Otherwise, it would not support. You have to send to approved emails only. So abc@abc.com has to approve you. Then once it is done, you can request a production access. Once the production access is approved, Amazon would allow sending around, if I remember, 24,000 50,000 emails in a day, or little more, much more. But everything keeps increasing gradually based on the mail quality you are sending. And then you can send email to all. It will keep checking the feedback. So in the production access, you do not need to get approval of each and every email addresses. You can send to all. But yeah, In that case, the feedback would come in a picture. It would keep checking whether person is having a lots of bounds, complaints, and if there is so much complaint, a production access would be banned. Sometimes it may happen that the people, suppose you are sending an email from abc@gmail.com. Now, the mail would be from this person, the SMTP and the from would be something from Amazon SES. In this case, quite a few mail clients would consider that this is a spam mail and they would immediately move that to a spam. So that's not the right way. How can you overcome this? You have to use domain key identified mail service. This is this is a standard that allows senders to sign their email message. So when those email messages are signed, they know this is an authorized email, this is not a junk. It might be used from a program, but it's an authorized. Then it's considered as a legitimate mail and it would be delivered to your inbox only. It would not go to some other box. This DKIM signing helps you delivery of email message. ISP can verify this. This DKIM also you can configure using SES console or using the REST APIs. What are the typical use case of the simple email service? You can use for the transaction emails, bulk emails, system emails, gaming, social networking, blogging, subscription emails, business emails, and many more. Just in a case, the people who are using Candy Crush, they might be sending a receive request to their friends, though it might be through Facebook, but there might be a way you can invite through emails, or there would be a way you want to share your score with your friends. Simple email would be a easier service for you in this case, where you are a game programmer, you want to send those transactionals or gaming or the bulk social networking mails. This is a perfect solution for you. Let's see a demo of the simple email service. I'm going to simple email service. Currently there is nothing available. So either you can, if you are owning your own domain like Intellipaat.com, you can verify your domains, or I'll start with the email address. I'll say verify a new email address. So verify this email address. It has sent an email to this learn AWS. The verification is pending from this user. If I open my inbox, it would show there is an email from Amazon Web Services. It says, do you authorize this person? I say yes. Once it is authorized, it is authorized. Now I can use this console. It's a verified. I can use a send a test email. Remember, I am still in a production access. Sorry, I am still in a beta access. I need another email ID. So if I say abc@gmail.com, just an example. If I try to say send, it would not. The abc@gmail.com is not verified yet. I need to verify that email ID. Else I have to send an email to only authorized email ID. So it would send the mail to them. You would see that there is a mail from me only. The sender is me and it has sent me, hello, how are you? If I go and try to see the headers, you would see the received from a8smtp amazon ses.com by Google to learn AWS online.com. So mail is received from this, and in those cases, if it's not authorized, it's likely that it would be marking them as a junk or So that's why it's important how you deal with that. Now if I go back to my console, this is how you send an email. If you don't want, you can always remove this ID. You can get your sending statistics with CloudWatch, how many mails you delivered, how much it worked. You can make your SMTP settings also. If you want to use it programmatically and you want to use it you want to do it using SMTP, you can do that. This would be your SMTP server name, this would be port, you can use that. If there is a Amazon creates its own separation list, like if there are the mails bounced across the globe from various people, you can use that also. Those would be automatically, if you're sending the people using SES to those same people, it would be removed automatically. You can remove those separation list also here. If you have enabled the domains, then after enabling domains, you can also enable the DKIM setting. That also you can do that. So this is all about this. Now you would say, how do I enable my production access? So to enable your production access, you have to go and request over Amazon support. Over Amazon support, you have to go and request. So if I go to support center, and here you have to request for the SES production access. I have to create a case. Remember, this is where you have to request for service limit and Amazon. Here you have to accept request for that. Okay, for US East, I want what are my times of mails, what I'm going to do. All that you will be able to request here. You have to request over support. Now remember, the support service is free of cost because you have selected basic support plan. Amazon offers various different kinds of support plans. Ideally, with a free user tier, it would be good. We can increase the limits with that also. Amazon Elastic Block Storage is mainly used for the persistence data storage. Now what is block storage? So when you talk about the storage system, there are two kind of a major storage system. One is a block level storage system, another is a file level storage system. In the block level storage system is more like a SAN or storage area network, where each block behaves like a raw unformatted volume. It's like each block is an independent hard drive. It works like a device which is mounted. It works as an independent hard drive. This each block is again controlled by the operating system. If you want to imagine, this is more like your hard disk over a remote network. In compare, when I go to the file level storage is more like a NAS systems. It's more like your regular file system. It's very easy to use and manage. Now when you go to the Windows and whatever kind of a file system you find, that's more like a NAS systems. And that's why it supports the various protocols like NFS, SMB, CFS kind of a protocols it does support. Advantage of the file level storage is that each can control individual files and folders, and that can be managed by this file level storage system. We know that we have in Windows, we would be creating a files and everything we can work with. Here in the block level storage, they are unable to directly control the smaller storage blocks. Here everything works as a block. Yeah, block might have as a data as a folder, or block might have a data as a file, but it's a whole as a block. One block may have a multiple data as part of that. And that's why those smaller storage blocks would make up your files and folders. So if you want to control at the OS level, now when you see at the OS level, you can see, oh, even my Linux machine would have a files and folders, then why it's still block level storage? But remember, at the underneath, there is a block level storage, which everything works as a blocks, and the data might be stored in the various blocks. And Amazon, when you talk about, manages those blocks independently. So that's why when you talk about the block level storage, one thing which is very important, you have to create a volume, you have to deploy an operating system, and then attach this created volume to the instance or server where you want to attach. While in the same case of the file level, the storage device handles the files and folders on the device over there. So there is a difference between block level and file level storage. At the same time, block level would also bring you more control, because if you want to take a backup and something, it would be easier to do that part also. Very good part over there. So we would be talking about the Amazon's own persistence block level storage, that is EBS. It gives you block level storage volume. So each EBS is known as an EBS volume, and that would be used with the Amazon EC2 instances. Also, Amazon does offer the relational database service, that's a RDS, which we would be seeing in the future videos. That also uses the underneath the EBS, because at the end what you need is a persistent storage, and that makes it idle for file system persistent database storage. EBS is the use case for you. If you remember, in the EC2 section we talk about there are two kinds of AMIs, EBS backed and the instant store backed. In the EBS backed, the root device is EBS volume. It gives you persistent storage, and this persistence also helps you achieve high availability and the reliability for the volume and the data. If you want to take the backup, it's a very easy mechanism. Just take the snapshot, and we would be doing in the hands-on also. That's a very easy to do that snapshot. Advantage is snapshot is an incremental, so whatever the data is being modified, only that part would be backed up, not everything. This EBS volume comes between size of the 1 gigabytes up to 16 terabytes. So you create volume as per your requirement. You increase that. It also helps you with the security because it provides the encryption mechanism. In addition, if you want to increase the size of the same system, you can do that. You can add multiple volumes to a single instance. So there are multiple use cases and advantages of using Amazon EBS volume.
So let's get started right now with the IAM, that is Identity and Access Management. So Identity and Access Management is basically a service wherein we can create multiple users to whom we can assign the AWS login ID and password, the access and the credentials. So let's get started. We will look into what is IAM. We will look into users, groups, roles, and demonstration, the hands-on demonstration I'm going to perform for each one of them. Identity and access management enables you to securely control access to AWS services and resources for your users. So we can create and manage users, assign policies, we can create groups. Then Identity Federation is the service using which we can associate Active Directory with AWS, and we can create and manage roles, and we can restrict the users like what all services they can use in AWS. So that's the reason the term has been used, fine-grained access to AWS resources. We can create and manage policies, and the most important part, this service is free. Only you are charged for the underlying resources. So let's get started with IAM. So, and sign into the console. So here we go, and we have to go inside IAM. Using IAM, we can create groups, we can create users. So first thing first, let us create a group. So I'm gonna give the name Intellipaat Admin. So all the admin users will be put inside this group, and I can attach the policies. Suppose all the users who are being added, I want to give them EC2 full access. That means both read and write access to EC2, but not anything else. And I will go in users and add user. So the first username will be Ram, then it will be Ramesh, it will be Rohan, then it will be Rahul and one more. So these are the 5 users I have added, and I want to enable the AWS management console for them to be accessed using the username and password. So either I can go with auto-generated password or I can customize the password. So as of now, I will keep the password as 12345678. And if I check mark this option, users must create a new password at next sign in. And now it's asking me, there is already a group that is int admin. Do you want to associate it, all the users with the group? Yes, I want to. So these are the choices I have made. There has been one policy attached, that is IAM user change password. That means on the first login, it is gonna ask the users to reset the password for them. And then I will hit create users. So these 5 users have been created. I can download a comma separated file so that I can share it with my management. So individual users name has been added with a link with which they can log in. So he will use this particular link, and the password, the username is going to be Ramesh, and the password will be 12345678, and sign in. We can see that Ramesh is able to log in right now. So straight away it is asking to reset the password. So the new password is going to be any random password, 8765431 and 8765431. So he has Ramesh @root login ID, and he cannot use any other service other than EC2. So the only service that he can use is EC2. The only service he can use is EC2, and let us say if he wants to use S3, because we have only given the rights, that is EC2 full access. So you can see access denied, but no issues at all with EC2. He can spin up the virtual instances. He can see the other virtual instances. So on and so forth. Now I can log out from here and log into my root. IAM username is going to be, so I will log in with the root account, that is my account credential. And now, so the users have been created right now. So we can add a feature called multi-factor authentication, right? Like those of us work from home, the companies provide us one key fob so that we can access the company's network remotely using a VPN. So we can have the same feature here as well. Like, so we are inside Rahul's account, and we can go inside the Ramesh account as well. And if I go in security credentials, so you can see that the console login ID, we cannot edit it. Like the password, we can edit it, and we can also enable multi-factor authentication. So how do we do that? I click here. It's asking me, do you want a hardware MFA device or a virtual MFA device? So I will go with a virtual MFA device. And next step. So it's basically asking here that on your smartphone, you should have one Google Authenticator. Okay, so you can see on my computer screen, this is my mobile phone. And so this is the application that I have downloaded, that is Google Authenticator. And you also need one application that is QR code reader. So QR code reader is right here. It's right here. So what I'm going to do is I will go here and it's asking me to scan the code. So I'm going to scan the code with the application that is QR code reader. And you can see that on my mobile phone, Amazon Web Services, a key has been added in Google Authenticator for Ramesh. And for Ramesh, this is the code 254157. 254157. So I will type 254157 and wait. So it's changing. The new code is 718125. So I'm going to say 718125. Hit enter. It accepts. So I will say finish. Now next time Ramesh tries to log in. Okay, so here we go for Ramesh and the password is 876543221. I say sign in. It asks for a multi-factor authentication code. So I will again refer to my cell phone 300083. So 3000. Now I'm able to log in into the Ramesh account using multi-factor authentication. Let me log in back with my root account. So I will say sign out and let me log in with the, so I will click on this link and it will take me to the root account. So we can attach the different policies on the fly. Like if I go in groups, so right now in this group, we have Amazon EC2 full access. Let us say I want to give the users S3 full access, and so I can do that. Okay, now all the users will be able to access EC2 as well as S3. So that is users and groups. Now this is the flow chart. Create users, create groups, assign user to the groups, create the policies, assign policy to the user or group, user access, AWS resources. So this is what exactly we did just now. Now these are the definitions. So these are some terminologies. The account you use to register with AWS is the root account. Then we can create the login password, secret keys, and AWS policy can be integrated with S3, so that we have already seen. Then we can add multi-factor authentication using IAM.
Now, it is very important for all of us that do we monitor this service? Monitoring is one of the key aspects of any infrastructure. Unless you monitor, you would not know how this infrastructure is behaving, what are the trends, whether you need some upgradation, whether you need some more resources, or you want to decrease the resources. Amazon offers Amazon CloudWatch as a monitoring service. Amazon CloudWatch is a monitoring service for Amazon's own services. Though there are multiple things in addition to Amazon's own services, but the major purpose why Amazon CloudWatch was launched was monitoring of the Amazon's own service. In this session, we would talk about the Amazon CloudWatch and how it would be helping for you. So when you talk about the CloudWatch, CloudWatch has numerous examples or numerous advantages. The most important advantage you can think of is it is used for the monitoring service. So you can monitor Amazon resources in the real time. Now you mean real time means whatever the data is happening within a minute or 5 minutes you get the updates. You get the updates in a graphical way, so it's easier for you to understand. You can get the data in the various metrics and trends. So you can get trends, what is happening over the period of time. For example, if you see, let me draw this way. There is a graph something like this, which tells you that at certain period of time, like 9 a.m., your load increases. At 12 p.m., your load is much higher, and then post 5 p.m., the load started decreasing. That is the case. Unless you see graphs, unless you see the data, you would not know what is happening. And the advantage is you can get up to minutes of the statistic with that. And what is the use of any monitoring service if it cannot alarm you? And that's why Amazon CloudWatch has an amazing service called Alarms, which can send you notifications. It can send notifications over email. In If you're in United States, it can send over the SMS, and there are some other ways also where you can get the notifications. It's also integrated with the various Amazon services like Amazon Autoscaling, which helps you to scale up and scale down also resources. You get the visibility of your resource utilizations and the most important, the demand patterns. What is the peak usage? What is the bottom usage time? How is my trend going on? And that helps you to plan or forecast the resource requirements. When you're doing budgeting, costing, everything would be helpful for you. And don't forget, it also helps you for setting billing alarms. Everybody's using Amazon for the cost effectiveness. Though that's not the primary use case, but that's one of the important use case. And when you're talking about the pricing, it's very important if you can set certain billing alarms which would tell you that how my usage is going and if it is going to cross certain limits or not. So that's what the CloudWatch is all about. Recently, I won't say it's recent, it's a few months back, Amazon has started CloudWatch events concept also, which gives you delivery timely stream of the events. If there is some events happening, like there is change in Amazon resources, new instances are launched, new instances are terminated, they would be getting to the events and they would notify you also. And you can set up certain rules that on this event, take this kind of a route, notify something, or there is a service called Amazon Lambda, something you can work on that. So all these things would be working here. So this is what Amazon CloudWatch we are going to learn more and more today. And where can you use CloudWatch? You name the services, and it's very likely CloudWatch is having a monitoring service for them, whether it is Amazon EC2 or EBS, which we have seen till now. But then, apart from that, there is a autoscaling, S3, CloudFront, CloudSearch, DynamoDB, RDS. You might not know quite a few of the names. Route 53, Redshift, and as I said, estimated Amazon charges. That's the one of the key aspects. I want to know what is my billing I can get through CloudWatch. How do you start using CloudWatch? Generally, when you sign up with Amazon, CloudWatch is available for you. In quite a few, or I would say most of the services, it would be giving you data at every 5 minutes. That is known as a basic monitoring. When CloudWatch is giving you data at every 5 minutes, that is known as a basic monitoring. In some cases, it gives you a detailed monitoring case also, which is where it would be giving you data at every 1 minute. And we would be seeing those services in a while. CloudWatch can send notification to autoscaling also, where it can help you to scale up and scale down. And you don't need any additional software. use whatever is offered by Amazon, you can use that very well. Now, how do you start using it? With the EC2, if you're in EC2, go to Amazon console, launch an EC2 instance, you would be seeing the detailed monitoring part. Yeah, there would be a monitoring tab. Generally, it would be a basic monitoring. It will be a basic monitoring aspect. If you enable the detailed monitoring, then it is a chargeable thing. You can get the instant state. So what is the instant, whether it's in running state, there is some issue with the instance. That also kind of a matrix CloudWatch does provide. And you get everything in a graphical way, you can get it. Yeah, if you want to get the data, you don't want to see only graphs at the Amazon level, but you want to collect the data, you can also do that. Amazon provides the APIs, command line tools, download the data, store it for your repository, and manipulate or present in your own way also. So this is how on the right hand side what you see is the how the CloudWatch graph would look like. When you see, I said there is a tab called monitoring. So this monitoring tab, when you click on that, there would be a few aspects. One is says enable detailed monitoring. This enable detailed monitoring, if you enable this or if you click this and you enable it, it is a chargeable thing. It would be chargeable, and remember that is not part of the free usage tier. So Amazon would cost you, or rather Amazon would charge you. How much? They would charge you $3.5 per instance per month. If you enable that for whole month, it would cost you $3.5 for whole month total. And when you go, if you have not enabled, that is a basic monitoring. Now you would say, what is the difference between basic and detailed? As I mentioned before, basic means it gets you data every 5 minutes, and detailed means it gets you data at every 1 minute. So if you see here the CPU utilization, discrete operations, there are multiple metrics which we are going to see now are available with the CloudWatch just for EC2. For each and every service, there are various kind of the available metrics, and you can monitor those. Now, after all this introduction, if I go and tell you what is a CloudWatch, CloudWatch is nothing but a repository of the data, which helps you in one of the core part of the scalable Amazon services. How? For example, if you have set up CloudWatch with your EC2 instance, now the CloudWatch when it is set up, it would keep on generating various logs. Along with CloudWatch, you can set up alarms. When you can set up alarms, that alarms would notify you or notify Amazon services whenever there is a breach in the threshold. So if some it crosses certain above level or certain below level, it can notify Amazon auto scaling. And you can configure auto scaling that whenever it receives the alarm, it can scale up or scale down. So this is the concept where CloudWatch plays a key aspect with the auto scaling. It would be very important that the CloudWatch generating the events or generating the thresholds and notifications, sending auto scaling would result in some scale up or scale down, as I mentioned a while back.
Just a quick info, guys. If you want to make a career in cloud and DevOps, then Intellipaat provides an advanced certification in cloud computing and DevOps by ENICT Academy IIT Roorkee, and it is taught by IIT Roorkee professors and industry experts. This course is designed to help you upskill and land in your dream job. Now, let's continue with the session.
CloudWatch is nothing but the repository of the data. It's just a collection of the data where data is collected in certain format at Amazon CloudWatch. Now, when data is collected, that would be in a format, say, it would be if you say a metric would have some name, namespace, a timestamp, a unit, a value, quite a few parameters a metric would have that would be stored inside CloudWatch. So if you see, it's just a database of the monitoring data. But that's not only for Amazon. It definitely, the prima function of the CloudWatch was to monitor the Amazon resources. But it does support your custom data monitoring too. You can monitor the custom resources. Like if you have a desktop and you want to monitor the resource of that, you can do that. You can send the monitors, or rather you can send the metrics to CloudWatch. CloudWatch provides APIs, command line tools, which allows you to upload your own data to CloudWatch. Now, I'm sure everybody would say, why would I upload my own data to CloudWatch? Does it give me any advantage? It does. Because with the CloudWatch, it has CloudWatch alarm. The CloudWatch alarm can be sent that whenever metric, suppose I'm drawing a graph that my usage is something like this, and I can say whenever it crosses the above threshold, or this is my below threshold, whenever it crosses the above threshold for some time, it would generate an alarm. So I can configure an alarm that's saying whenever CPU utilization is above 70%, take certain action. Or whenever CPU utilization is below 10%, take certain action. So this way, CloudWatch alarm plays a key aspect. And we all believe that there is no use of a monitoring service unless it gives you alarm, because it's not possible to keep on monitoring 24/7. If you get the alarms, that would be more actionable item for you. CloudWatch goes one step beyond. It takes actions on behalf of you also. You can configure the actions. So it can allow to take three kind of actions. First action is Amazon Simple Notification Service. Now, Simple Notification Service comprises of the four major blocks, where it can send a notification over email, it can send notification over some HTTP URL, it can send notification to some SMS over through. But remember, SMS is only available for US as of now. Also, there is a SNS where you can send to your custom, like the mobile notifications you want to send, you can do that also. So it does support the mobile notification also. So email, HTTP URL, SMS, and the mobile notification. SNS, Simple Notification Service, is a service which sends notification over four channels. So whenever, for example, CPU usage goes above 70%, CloudWatch would notify SNS saying there is an increase in the CPU utilization. SNS would say, okay, I have an action configured here which says that whenever you get this kind of an alarm, send an email to Intellipaat. It would immediately send an email. It can also do that. I have also configured email that whenever there is some event, you notify over HTTP URL. Now you would say, what would the HTTP URL help me? Suppose you have created a automated report tracking tool which is hosted on some website where there is a HTTP URL. You can hit it there. It will automatically create a ticket for you. It's just an example. If you are in USA, you can get an SMS also. So CloudWatch would help you get real-time notifications. Apart from that, the second service which it sends notification is, or it can send, is auto scaling. The auto scaling service we spoke in the previous slide allows you to scale up or scale down. So auto scaling would be scaling up or scaling down and help you. Then third service is Amazon. If it's for EC2 only, it helps you to take EC2 action. Like due to certain reason, you want to stop an instance, you want to start or terminate an instance, or you want to restart an instance. Now just imagine a case. You have set up a web server. Now there is a web server which is running on your EC2 machine. Due to heap memory or certain issue, the web server becomes unresponsive. It has stopped. It might have crashed. Right? Now your EC2 machine is running fine, but your web server has stopped. If you have set up certain kind of your custom parameter or certain kind of a monitoring which says that your web server has stopped, what you can do is you can notify the CloudWatch would then notify your EC2 instance and say reboot. It would reboot, and if you have set up the bootstrapping for your instance for your web server, it would automatically restart the server and would solve your problem. In some cases, you think there is a long running process which can run 8 hours, 10 hours, 15 hours, 3 days, 5 days, something like that. Take an example, some batch processing, heard of something, and you want to say whenever batch process completes, it would be copying data automatically to some centralized folder or some database. But after that, I don't want the instance to continue running. Reason, it would be costing me. There is a better option available for you. Why don't you stop the instance or terminate the instance? So you can set up that for this kind of a EC2 instance, whenever CPU usage falls below 1% for 1 hour, 2 hour, you can say take an action and terminate or stop the instance. So CloudWatch can take action on behalf of you also. What are the action? SNS email notification, auto scaling, and EC2 instances action. We would be seeing in the demo most of the actions as now. What are the services CloudWatch supports? When you talk about the basic monitoring, which is every 5 minutes, it has a EC2, auto scaling, elastic block storage, DynamoDB, Elastic MapReduce, Amazon Machine Learning, Simple Notification Service, Simple Queue Service, and a few more. There are quite a few services which it supports every minute of the monitoring. Out of this, only EC2 and auto scaling, when auto scaling running for the EC2, when they have detailed monitoring enabled, it's a chargeable. But apart from that, everything is free of cost. It doesn't cost you extra. Now, when you want to see the default metrics for CloudWatch, there are various kind of a metrics available with the CloudWatch. If you see, there is EC2 instance. EC2 instance would have a lots of metrics like CPU utilization, discrete bytes, discrete operations, discrete bytes, discrete operations, network I/O, and many more. CPU credit usage, CPU credit balance. Those are the available when you have a T2 family, which gives you CPU credit. When you see all these parameters are available, and quite a few are available at every 1 minute also. A few parameters which would be interest for us is status check field. When you launch an instance, if you remember in the EC2 I mentioned, we have to wait till the instance state is 2 by 2 status check pass. Unless that is 2 by 2 status check pass, it's not used for us. And why it was the case? Because this 2 by 2 are one is status check field and one is status check field system. These are the two checks an instance has to pass before it is available to you. Now, why do you need those chains? These checks are required because it's a virtual machine available on the cloud, available over the internet. So Amazon does a checks on behalf of you, like whether instance is launched correctly, does it have a network connectivity, does that system has a power capability, if it does not have any software issue or any hardware issue. So anything at a hardware level or firmware level issue, they are check at an instance level. Then anything at the operating system level, like failed system status check or misconfigured networking or startup configuration, memory issue, corrupted file system, incompatible kernel, all these issues would be checked by the system status check system command. If these two pass, that means there is no issue in the system and system is running perfectly or instance is running perfectly fine for you. So it is important that when you see the status check, if it's a 2 by 2 means both the checks are passed and system is available for you to run. At the same time, when you see Elastic Block Storage gives you the parameters for the read operations, write operations, read time, and so many. So when you see the IOPS, it would be for the operations or the for optimize total read time. So you get all these attributes which would help you to understand what are the metrics important for you. If you are interested to read more about the metrics, these are the URLs available. You can go through and it would list down each and every metric. Now I keep on talking about the metric. A metric is the fundamental concept in the CloudWatch that represents a time order set of data points. That means a data at certain point of time. For example, current time is 10 a.m. So at 10 a.m., what was the temperature? That's a 30 degree. That is your metric. So what metric would have it would have a name. What is name? Here you can think that temperature is the metric name. Then namespace would be whether it's a combined under the some environment variable or something. It's a group of the variables. it would have a one or more dimensions, timestamp, and unit of measures. Now, what are these all aspects about? When you talk about this, a namespace is nothing but a container for the matrix where a multiple metrics combine and make a one unit. So, for example, a EC2 instance. The EC2 instance has a multiple metrics. It would have a for CPU usage, it has a disk read, or it would have a CPU carried, kind of a various metrics available. All these metrics are combined under one namespace, that is AWS slash EC2. Same way, autoscaling would have a different metrics. They are combined under AWS slash autoscaling. So namespace is nothing but a bucket or a container for all the metrics. When you go to the dimension, dimension is nothing but a name value pair that help you to identify a metric. For example, in EC2 you would have a autoscaling group, image ID, instance ID. Now what does that mean? If you take an example, you have a EC2 instance. That each EC2 instance would have some instance ID that is launched from some image. So it would have some image ID. It has an instance of size micro, small, large. It would have an instance type. It might have some volume attached to that, so it would have a volume ID. So these are the attributes of an EC2 instance, and that each would have some value associated with that. Now you would think, why do I need this? Sometimes you can group based on that. For example, you want to see how are my all micro instance doing. So you can group based on the instance type. Correct? Or how are my instance which are launched from this my own AMI doing? You can get it from here. The dimensions are nothing but a way to identify a metric, a different or unique way to identify the metric. Each metric would have a timestamp also. That is the most important. That would be in a microseconds or whatever way, and the timestamp would be in a UTC format always. UTC, that's what the Amazon supports, the time zone format. Each unit would have or each metric would have a unit also. That unit you can think of it like a byte or seconds or the percentage or kind of a unit it would have. Like. Each metric is always specific to a region because all service would be specific to region, so it would be part of that region only. Some of the sample namespace I have listed here, they are for Elastic Block Store, it would be like EBS. For Elastic Compute Cloud, it would be like EC2, or SNS, it would be like SNS, something like that. That's the namespace. And each would have a multiple metrics as part of that. And each metric would have a dimensions as part of this. So dimension, as I just mentioned, it's a name value pair, which helps you to uniquely identify an instance. Timestamp is also a very important aspect for you. Timestamp is ranging, it would be where it would be up to 2 weeks in the past. It is very important to understand that the timestamp is always measured in UTC format, so it can convert to your own format. But Amazon CloudWatch keeps the data of the last 2 weeks only. At any point of time, there would be data of the last 2 weeks only. There would not be any data beyond that. But you say, oh, I want to capture the data of the data before 2 weeks. How would I do that? Then you have to download the data on your own and you have to save that. You have to download the data on your own and save it. Amazon does not provision any option to save the data. You download it and you store in your own database. We talk about the units. There are the various samples which are the units, like you can have a seconds, bytes, bits, percentage count, bytes per second, bits per second count, or second none. So there are the various kind of units you can have that. So when you talk about the metric, as I said, has a multiple things. It would have a name which defines the name of the metric, like it's a CPU utilization, it's a read operations, write operations, what is it that? Then it would also have on top of that a namespace which uniquely identifies to helps you to group the metrics. Then it would have a dimension, which are the attributes of a metric. It is having unit, it is having a timestamp also. Also, CloudWatch provides a various kind of a data aggregation methods. That is the statistics. where it gives you statistics like a minimum. So over this period of a 1 week, 2 week, what is the minimum value? So it would show the sample values of the minimum, it would show the maximum values during that period. When you see sum, it would say all values submitted and the matching metric added together. When you try to get the average, it would say what was the value of sum or sample count during that part. When you say sample count, it would find out the sample during the each period and give you. So Amazon CloudWatch also helps you to get the various. It does have a periods also. The period can be as short as a 1 minute and as long as a 2 weeks, because it goes up to the last 2 weeks in the back. You would have a start time and end time also. You can specify to determine what period data you. Alarms, the best thing that happened to the CloudWatch. Because it helps you to make decisions and take an immediate actions. Alarms can automatically initiate the actions on your behalf, and based on the specified parameters, it can work for you. It can take an action to SNS, as I said, email, or if you want to take the EC2 action, or even it can take the auto scaling actions, kind of a various actions it can take. Each Amazon is specific to a region. Rather, each Amazon CloudWatch metric is specific to a region, and one region data is not available in a separate region. Because the service belong to that region, the data of the CloudWatch also belong to that. CloudWatch does support the custom matrix. The custom matrix helps you measure or monitor the data for your own case. So, for example, you have some example where you want to take the case of your own Linux operating system. How is that doing? What is the device space, or what is the disk space available? What is the disk space used? Those kind of a matrix you can see here. The CloudWatch does support that. What you have to do is, if you are using a Windows, you just need to run certain PowerShell scripts. And if you are running a Linux, you run some Perl scripts, which would help you to generate the matrix and send it to the pricing. CloudWatch basic monitoring is free of the cost. It doesn't cost you. Plus, if you're part of the free usage tier, you get up to 10 metrics, 10 alarms at free of the cost with the CloudWatch. But remember, detailed monitoring is not part of free usage tier. It would be chargeable to you. So don't forget that digital monitoring would cost you. So that's it for the Amazon CloudWatch theory. I hope you all enjoyed this. Bye bye.
So OpsWork is a configuration management tool that basically involves a DevOps tool called Chef for continuous deployment. So as I said, it is a configuration management service that helps you configure and operate applications of all shapes and sizes using Chef. These are the key features. It supports any application. The whole configuration becomes code due to Chef. Automation to run at scale and resource organization. So there are few terminologies used in AWS OpsWorks. The first is stack. Now the stack is a cluster of EC2 and RDS instances. Okay, and a layer is a blueprint added to it, which basically defines like what type of EC2 instance is going to be that. Is it going to be a web server, application server, or a database server? So those kind of configuration details are mentioned in the layer. So layers give you the complete control over which package are installed, how they are configured, and how applications are deployed. Now, recipes and cookbooks are something which we study in detail when we actually take up the topic on Chef, because recipes and cookbooks is something which is denoted by Chef only. So let me show you the practical demonstration for AWS OpsWork. So for AWS OpsWorks, let me check if there is a video that is available. You can check, like the one we had for Elastic Beanstalk. I think there is a video. So we can get that video here. So many times people ask what is the difference between CloudFormation and OpsWorks and Elastic Beanstalk. So the first major difference is OpsWork does not work alone. It works in collaboration with Chef, which is a DevOps tool. and it has cookbooks and recipes to deploy the configuration. So here is the video, that it's a 3 minutes video. Whenever you get time, just go through this video. That is introduction to AWS OpsWorks stacks. And first thing first, we have to create a stack. So right now, do we have a stack? Let me check. So first of all, we are going to add a stack with Chef 11 because that has built-in cookbooks and recipes. So I'm going to name it as Intellipaat first, and rest everything will be same. And I say add a stack. So the stack is being added right now. Now the next step is to add a layer. So how do we add a layer? We click here, and here I'm going to add a PHP server. So I would say PHP app server because the code, my application that I want to deploy is written in PHP. I do not want to attach an Elastic Load Balancer as of now. And I say add the layer. So the layer has been added. And to the layer, I'm going to add one EC2 instance. So I'm going to add t2.micro, which is free tier eligible. And I say add an instance. Now on this instance, I'm going to start it. And on this instance, my PHP application is going to be hosted. So it is starting the instance right now. So as I said, it is explaining the difference between OpsWorks and CloudFormation. So CloudFormation is used for spinning up the AWS resources. However, OpsWorks is something which is used for deploying the third-party applications, which can be written in Go, AngularJS, Node.js, Ruby, Python. All right. So the same difference is between OpsWorks and Elastic Beanstalk as well. Like Elastic Beanstalk does not involve any chef configuration. So the instance, the EC2 instance is getting started right now. Okay. So it is online. The instance is online. The next thing is to add an application, the PHP application that we were talking about. So I'm going to give it a name, Intellipaat first. And my application is stored on Git repository. So I'm going to provide the URL for Git. It's right here. So here we go with the URL. We say add an application. So the application has been added. Now the next thing is to deploy the application. So we are going to deploy it on the EC2 instance that we just created. And it is being deployed right now. Okay. So this has been successful. And all we have to do is go to PHP app server. And basically we need to go into instances. And this is the IP address. So it says your PHP application is now running in your own dedicated environment in the AWS cloud. And this host is running PHP version 5.3.29. So in CloudFront, we will learn about edge locations. We will see the hands-on practical for CloudFront. And so CloudFront works on the concept of edge location. And there are around 54 edge locations across the globe. So what is an edge location? An edge location is the third-party data center that is not directly owned by Amazon, but Amazon has done tie-up with certain vendors such as Reliance, Tata, etc. So the whole purpose behind edge location is to expedite the complete process and decrease the latency. So let us say I'm sitting in India, New Delhi, and I want to access a website that is hosted in United States. So the content of the website will first be delivered to one of the availability zone here in India, which can be in Mumbai. And from Mumbai, it will be transferred to one of the edge location in New Delhi. And it will be stored there permanently as a cookie or as a cache. And then the page will be delivered on my laptop or my desktop. Now, the second time I ask for the same page, the request would not go to United States server. It will directly search for one of the edge locations in New Delhi. And if it finds the content there, it will pick it up from there and deliver it on my computer, right? So CloudFront is a global content delivery network service. It caches the static objects. So that is what I told. Charges are pay as you go. And in Asia, there are around 13 edge locations right now. And what it does is it puts the objects in S3 and then it creates the distribution. So what do we mean by creating the distribution? It transports the content to the 54 edge locations across the globe, and it issues a link to the object. So one can access the objects using a link or a hyperlink. So that is something which we are going to look into right now. So this is the basic diagram of CloudFront. So there are developers store the object in S3 or HTTP server, and then a function is triggered to call Amazon CloudFront. And what CloudFront does is it distributes the content across all the edge locations. So on the right hand side, you see a diagram wherein a user is sitting on the computer. It is asking for the website, and the request goes to edge location. If it doesn't find an edge location, it goes to the S3 bucket or the HTTP server where exactly it is hosted. And then from there, the request is retrieved onto the edge location and finally onto the end computer. Basically what happens in S3 bucket, we can store a lot of variety of objects like HTML, CSS, JavaScript, images, and then CloudFront fetches the information from S3 and then distributes it across the edge locations. So here we go with aws.amazon.com and sign into the console. So let me sign in with the credentials. And here we type CloudFront. So straight away it asked me to create a distribution. So there are two types of distribution. One is web and other is RTMP. RTMP stands for real-time messaging protocol. So the difference between web and RTMP is that in web, the content will be stored both in Amazon S3 or it can be on an HTTP server. But here in RTMP, it can only be on Amazon S3 bucket. It cannot be a EC2 server or HTTP server. Or okay, so that is the difference. So we will go ahead with web option, and here it gives me the S3 buckets that we had created. So let us go with Intellipaat training S3. So let us check first what all objects are there inside the 3 bucket. So this is the bucket, and we have all type of objects, cf1.png, cf2, tp1. So all these are there. Okay, so origin path I will keep blank. It is for the specific file that I want to access over an S3 bucket. And restrict bucket access, I will keep it to no. And I don't have any header name and values as of now. And protocol policy, I will go with HTTP and HTTPS both. And I can choose this option, that is get head options put post. So these are basically functions which will be triggered whenever somebody tries to access my S3 bucket. And here we can customize the object caching. The minimum time to live is 0 seconds and maximum time to live is 3,15,000. 31,53,000. No, it's more than that. So these many seconds are there in a year, right? So default time to live is 86,400 seconds, which are there in a day, 24 hours. So if we multiply 86400 by 365, so it comes out to be 3,15,36,000 seconds, which is in a year. So these many seconds are there in a year. So maximum time to live is 1 year, and rest of the options will be kept default. And distribution state I will keep enabled and hit create distribution. So it is creating the distribution right now. It will take exactly 15 minutes, 15 minutes to create the distribution. So these are the number of edge locations that we have in different regions across the world. So if we talk about Asia, we have the edge location in Chennai. Then we have the edge location in, now as per the recent report, the edge location is there in Pune and Delhi, New Delhi as well. So 3 edge locations. Now these are the different features of AWS CloudFront. Like we have caching, fast and simple, easy to use. Then we can download the distribution. It supports HTTP and HTTPS request. It is elastic in nature because it is configured with S3, and we can have the real-time streaming with RTMP. It supports cookies. It integrates with other AWS services, and it is secure with private content. Okay. So it supports the query strings, as in some queries which are written in SQL, even those are supported. The one that we saw, get, head, push, post. So those kind of strings are very well supported. with CloudFront. First of all, we have a user, and let us say he is sitting on the internet. So this is internet, and trying to access a website that is hosted on the AWS cloud. So this website is hosted on the AWS cloud, and there are two servers. One is the primary server, and the second one is the secondary server. Now there can be one elastic load balancer in between, which is distributing the traffic towards the primary server and the secondary server. Okay. Now let us say he's trying to access a website. All right. That is www.eduism, because that's the domain name I have purchased from GoDaddy, eduism.co. All right. So the request can come to the primary server, or it can come to the elastic load balancer, and then elastic load balancer will route the traffic between the primary server and the secondary server. The brief architecture. This is the brief architecture, how things work. Eduism.co top level domain name server. It checks into the authoritative domain server. It also checks into the example.com authoritative DNS server. Fetched. So the route 53 comes from the name, because this route 53 service works on the port number 53. That is the port number for DNS. Okay, so that is one thing. So this is once again a cycle. A user is sitting on the computer, and he's looking for a website, www.example.com. The request comes to domain name server, and domain name server, if it has the records, it will forward it. If it does not have, it will say, I don't know, and I will ask the authority server. So authority server is when the request goes to route 53, and route 53 reverts back with the IP address of the example website, and it forwards it to DNS resolver, and finally the DNS resolver forwards it to users. So as discussed, it is a highly available and scalable domain name system web service. It effectively connects user requests to infrastructure running in AWS, such as EC2, ELBs, S3 buckets, and we can also route the users to infrastructure outside of AWS. So that is something which we are going to see right now. It is fast, easy to use, and cost effective. It answers the DNS queries with low latency by using a global network of DNS servers. And if you need a domain name, we can find an available name and register it using Route 53. So these are some key takeaway points. Now, it is reliable, fast, integrated with AWS, easy to use, cost effective, and flexible. It is reliable because it works on the concept of edge locations. So there are 54 edge locations supported by AWS, and it can be managed using command line interface as well. It is quite cheap, and it follows the round robin scheduling. So If the request is coming on to the Elastic Load Balancer, it has the capability of following the round robin scheduling to distribute the traffic among the various servers. We can run application in multiple AWS regions and route users to the one. So in case of failover, okay, let us say that this server stopped working and this entire infrastructure is in Mumbai region, okay, and we can fail over to a server that is in Singapore region using route 53. So any request that is coming to the primary server will be rerouted to the failover server in the Singapore region. So that is what I'm going to perform the practical demonstration. So you can see that, okay? So that is one thing. And it follows the concept of hosted zones and record sets. So what exactly is the hosted zone? So let me show you right now. Now we have a website called mail.google.com. Then we have something called as contacts.google.com, and we have drive.google.com, and we have photos google.com. So these are basically the record set for a single hosted zone, that is google.com. So hosted zone here is google.com. This is the hosted zone.
In this, we are going to learn about the AWS SES or Amazon Simple Email Service. Till now, we have learned the various services and covered about the Amazon CloudFront and Amazon Import Export with the Snowball. Amazon Simple Email Service. You would see what is Simple Email Service, where this is used, what are the key features of the Simple Email Service, and we will see a demo of Simple Email Service too. Amazon SES is a cost-effective, scalable email service. It is useful to send the bulk emails. Remember, this is not your replacement of your Gmail or Outlook mail. No. But if you want to send a bulk mail, transactional mails, huge number of mails, this is the ideal solution for you.
Just a quick info, guys. If you want to make a career in cloud and DevOps, then Intellipaat provides an advanced certification in cloud computing and DevOps by ENICT Academy IIT Roorkee, and it is taught by IIT Roorkee professors and industry experts. This course is designed to help you upskill and land in your dream job. Now, let's continue with the session.
A few months back, Amazon SES also started a service called Receive Email. Initially, it was only for sending email, where the mails would be received, delivered to your AWS S3 bucket. But the major purpose is it's used for the sending email. Important aspect is it supports pay-as-you-go model, very cheaper. Free tier gives you almost 50-60,000 plus emails in a month, free of cost for up to a year, and then over again also it would be charging you 6 cents per around 1,000 emails. So that's a very cost effective and cheaper service. It's a highly reliable and very scalable. Simple email service, easy to use and very scalable. Important is it gives you a feedback loop mechanism also. So whenever a mail is bounced due to any reason, over quota or due to the wrong email ID, it gives you back. And it also keeps track of that how many mails from your end are bouncing. And with this feedback loop, you can always increase your delivery rate. It does work with the Amazon other email services or other services. It can integrate with them. And it is a very easy to use interface. We will see that also in a demo. Where it would be useful. When you want to send for bulk and transactional emails, it's a perfect support. It does support the SMTP also. So you can use the SMTP to send the emails using Amazon SES. It does support the receiving emails also and deliver them to the S3 bucket. But do not use as a junk email, as AWS may stop your access. Remember, that's a very important point. If you try to misuse the SES as a junk email for sending junk or hacking or some other purpose, Amazon would stop your access, because Amazon keeps giving you feedback, what your success rate, everything, and it also keeps track of that. If it finds there is a huge number of bounds and your production access may be stopped for SES, it would not allow you to send more emails. It's very important you use it wisely. It's a very cheaper email service for delivery, cost effective. And those emails are bound to fail. We know that emails may bounce. So it doesn't mean that if one or two mails fails, Amazon would stop your production access. No. But it evaluates you. It continuously keeps checking what is your bounce percentage. If you send 1000 mails and 10 mails bounce, that's okay. But if you send 1000 mails and 600 mails bounce, there is a serious problem. If there are a huge number of complaints received from your email, or the quality of email is not good, it keeps checking how much bounce percentage, how much complaints, how much overquota, something like that, and it thinks, okay, there is something wrong. SES takes those parameters very seriously, and it can reduce your production access. But if your bounce percentage and the quality of email is good, it's within a measure, that measure is defined by Amazon, SES is very cost effective and service for sending email for you. How would you use SES? When you sign up with the SES is having a two modes. First is you have to sign up with a simple email service. You would be using, initially you would be using beta access. During the beta access, whatever email you want to send from, so if you want to send from my email ID, learnawsonline@gmail.com something, and you have to first verify those emails before you can send from that ID. Even if you're sending a mail to abc@abc.com, you have to still verify that email ID. Otherwise, it would not support. You have to send to approved emails only. So abc@abc.com has to approve you. Then once it is done, you can request a production access. Once the production access is approved, Amazon would allow sending around, if I remember, 24,000 to 50,000 emails in a day, or little more, much more. But everything keeps increasing gradually based on the mail quality you are sending. And then you can send email to all. It will keep checking the feedback. So in the production access, you do not need to get approval of each and every email addresses. You can send to all. But yeah, in that case, the feedback would come in a picture. It would keep checking whether the person is having a lots of bounds, complaints, and if there is so much complaint, the production access would be banned. Sometimes it may happen that the people, suppose you are sending an email from abc@gmail.com. Now, the mail would be from this person, the SMTP and the from would be something from Amazon SES. In this case, quite a few mail clients would consider that this is a spam mail and they would immediately move that to a spam. So that's not the right way. How can you overcome this? You have to use domain key identified mail service. This is this is a standard that allows senders to sign their email message. So when those email messages are signed, they know this is an authorized email, this is not a junk. It might be used from a program, but it's an authorized. Then It's considered a legitimate mail and it would be delivered to your inbox only. It would not go to the some other box. This DKIM signing helps you delivery of email message. ISP can verify this. This DKIM also you can configure using ACS console or using the REST APIs. What are the typical use case of the simple email service? You can use for the transaction emails, bulk emails, system emails, gaming, social networking, blogging, subscription emails, business emails, and many more. Just in a case, the people who are using Candy Crush, they might be sending a receive or request to their friends, though it might be through Facebook, but there might be a way you can invite through emails, or there would be a way you want to share your score with your friends. Simple email would be a easier service for you in this case, where you are a game programmer, you want to send those transactionals or gaming or the bulk social networking mails. This is a perfect solution for you. Let's see a demo of the simple email service. I'm going to simple email service. Currently there is nothing available. So either you can, if you are owning your own domain like intellipaat.com, you can verify your domains, or I'll start with the email address. I'll say verify a new email address. So verify this email address. It has sent an email to this learn AWS. The verification is pending from this user. If I open my inbox, it would show there is an email from Amazon Web Services. It says, do you authorize this person? I say yes. Once it is authorized, it is authorized. Now I can use this console. It's a verified. I can use a send a test email. Remember, I am still in a production access. Sorry, I am still in a beta access. I need another email ID. So if I say abc@gmail.com, just an example. If I try to say send, it would not. The abc@gmail.com is not verified yet. I need to verify that email ID. Else I have to send an email to only authorized email ID. So it would send the mail to them. You would see that there is a mail from me only. The sender is me and it has sent me, hello, how are you? If I go and try to see the headers, you would see the received from a8smtp amazon ses.com by Google to learn AWS online.com. So mail is received from this, and in those cases, if it's not authorized, it's likely that it would be marking them as a junk. Or so that's why it's important how you deal with that. Now, if I go back to my console, this is how you send an email. If you don't want, you can always remove this ID. You can get your sending statistics with CloudWatch, how many mails you delivered, how much it worked. You can make your SMTP settings also. If you want to use it programmatically and you want to use it you want to do it using SMTP, you can do that. This would be your SMTP server name. This would be port. You can use that. If there is a Amazon creates its own separation list, like if there are the mails bounced across the globe from various people, you can use that also. Those would be automatically. If you're sending the people using SES to those same people, it would be removed automatically. You can remove those separation list also here. If you enable the domains, then after enabling domains, you can also enable the DKIM setting. That also you can do that. So this is all about this. Now you would say, how do I enable my production access? So to enable your production access, you have to go and request over Amazon support. Over Amazon support, you have to go and request. So if I go to support center, and here you have to request for the SES production access. I have to create a case. Remember, this is where you have to request for service limit and Amazon. Here you have to accept request for that. Okay, for US East, I want what are my times of mails, what I'm going to do, all that you will be able to request here. You have to request over support. Now remember, the support service is free of cost because you have selected basic support plan. Amazon offers various different kinds of support plans. Ideally, with a free user tier, it would be good. We can increase the limits with that also. So this is about the Amazon SES, a powerful and scalable and easy to use tool for sending an email.
So these are some key terminologies. What is EBS? What is EBS volume and EBS snapshot? So EBS is the block level storage. It is just like the solid state drive, and it is really fast. So EBS volume is the EBS. It can be a general purpose SSD or provisioned IOPS or magnetic volume that can be attached to an EC2 instance. And a snapshot is a point in time backup of volume used to instantiate multiple new volumes. And we can expand the size of a volume or move the volumes across the availability zones, regions, as well as the various other accounts as well. So snapshots can be transferred from one AWS account to another AWS account, from one region to another region within the AWS account, and from one availability zone to another availability zone. That is how it contributes to high availability EBS snapshot. So the one condition is that the EBS volume which is going to be attached to a EC2 instance has to be in the same availability zone. Let us say we have this EC2 instance in 1A. The EBS volume that I'm going to attach to it has to be created in 1A only. It does not work like cross availability zones. It does not work. So right now the server is ready. So let us run the command lsblk to figure out how much space we have got. So it is saying only one volume is attached right now, that is XVDA, which has got two components, XVDA1 and XVDA2. And it is overall 10 GB in size. We can also see the volume through df minus h. So it also says 10 GB volume is there. This is the volume, the boot volume that was created along with the instance A, 10 GB. And we can create a new volume. So we are going with general purpose SSD. If we go with provisioned IOPS, it's going to cost us extra. That is chargeable. So as cold HTTP and throughput optimized. Magnetic is free, but it's very slow. So that's the reason I will go with general purpose SSD. And size I'm gonna take is 10 GB. Maximum I can take 16 TB. And the IOPS, that is input output operations per second, is going to be 300, and the maximum is 3000. So since we have taken 10 GB, the IOPS has changed to 100. If we take 30 GB, let us keep it to 10 GB as of now. And the availability zone is going to be 1A, and I want to encrypt this volume. So I want to encrypt it with the default AWS EBS key and sign into the console. So I will have to go in IAM, Identity and Access Management, and check out the option encryption keys. So right now the key that we are using is AWS EBS. I can create my own key. So I can create it by the name EBS, and I will keep the same description. And I want to have a KMS, that is key management service. I would not go for external, and I will hit next. So this is the key that has been written in JSON format, is ready right now. So this key has been created in North Virginia. So that means I should be able to use it here. So I want to go with 10 GB. It will change to 100 IOPS. And I will make sure that I'm creating the volume in the same availability zone, that is 1A. And I can encrypt this volume using either default ABS, or I can use EBS as well, the one that I just created right now, and hit create. So I will give it a name as extra volume. It is available right now, and I can go in actions and attach this volume. The moment I click on instance, it's automatically going to show instance A in North Virginia. And the device it is going to allocate is /dev/sdf, and I say attach. So now if I go back to the console and run the command, so let me run the command. So now if I run the command lsblk, I can see that XVDA is there with 10 GB, and XVDF, the new volume that we just now added, is there 10 GB. Now if I run the command df-h, only 10 GB volume is there, that is XVDA. It is not showing up XVDF. The reason is it is not mounted and it is not formatted as well. So first of all, we will have to mount it, as well as we will have to format it in order to replicate the changes. So first of all, we will format this, and the command that we are going to use is sudo mkfs -t ext4/dev/ the name of the volume that we have attached, that is XVDF. It has been formatted. Now the next step is to mount it. So in order to mount it, I will first create a directory, new, and now I will mount it on the new directory. So I'm going to mount this newly created volume on new directory. So it has been done. Now if I run the command df-h, it is very well showing here. So two components are there, XVDA and XVDF. So it's very well showing here. And I can cd into the new directory and create some empty files, sudo touch 1 2 3 4 5. So I'm going to create 5 empty files, and if I run ls-lia, all the 5 files are listed, 1 2 3 4 5. So on this new volume, 10 GB volume, extra volume, XVDF that I created, I have added 5 empty files to it just for the demonstration purpose. Now, let us dig deep into EBS volume. So this is the life cycle of EBS volume. We have unused space. We create a volume from 1 GB to 16 terabyte. We attach it to an EC2 instance. Now we can use it. So we are done till here. After that, we can create a snapshot. What is a snapshot? It is point in time backup of the EBS volume, and that snapshot will be uploaded on a Amazon S3. We can attach this snapshot across the AWS account within the multiple regions, as well as we can transfer it from one AWS account to another AWS account. And from this snapshot, we can create multiple volumes of even bigger size. Let us say that this 10 GB volume, I created a snapshot. Now from that snapshot, I can create even a 20 GB volume that will have all the data of the 10 GB volume as well. So that is what we are going to see right now in the practical demonstration. So this is the architecture of EBS volumes. EBS with the EC2 and S3. So basically what happens, all the EBS snapshots are stored in S3 volume. So basically we can create the snapshots, and from that snapshots, again, the volumes can be created and attached to EC2 instances. And all of this can be managed and accessed via the internet. So these are few features about snapshots. We can create a snapshot of any EBS volume, and these snapshots are stored in Amazon S3. There is a charge attached to snapshot. It is $0.095 per GB of storage. And these are the advantages. We can create new EBS volume from snapshot. We can expand the size. We can create the volume in separate availability zone or region or different AWS account as well. So overall, it helps for disaster recovery and high availability.
In this session, we are going to talk about the Amazon Autoscaling. Amazon Autoscaling is a service which allows to add new EC2 instances based on the conditions defined. Before we move on to autoscaling, we would first try to understand what are the types of the scaling possible in regular world. We would understand what is autoscaling, what are the types of autoscaling, or how do you achieve the autoscaling, and we would go a little deep down about the autoscaling too. Let's see first what are the types of autoscaling in the market. Suppose you have a M3 medium instance size and you have a EBS, that's a root volume of 40 GB size to that. Now if you want to increase the capacity because your load is increasing, one way is from M3 medium you change the size to M3 large. To change the size, you have to stop the instance and then change the size, provided this is an EBS back instance. Yes, if you want to change the size from 40 GB to 80 GB, you can also do that. You take a snapshot, you create a new volume of 80 GB, attach as a root volume. But changing the instance size or changing the volume size, in these two cases, it would require instance to be stopped temporarily and then the size would be changed. But that is possible. If you can do it in a off-peak hours or something, you can back up. It's a possible thing. In another case, you want to change size from M3 medium to M3 extra large again by stopping server. Yeah, if you don't want to remove the original size of the EBS volume, you can attach additional EBS volumes also. You can RAID them and then you can make them as a one EBS volume. All these cases are case for the vertical scaling. In the vertical scaling, you add resource vertically to your current infrastructure. Whether you add memory, you add compute power, whether you add storage, all the cases are of the vertical scaling. Vertical scaling has some kind of a limitation. because one limitation we just saw, it may require the instance to be brought down. In some cases, there is a threshold. Beyond that, if you keep on adding more resources, it may not improve the performance because eventually it's a single machine. A single machine has its own limitations, which might not work beyond certain capacity. So when you think about M3 extra large, M3 large, in both the cases, this is how it's going to work. Let's think over the another option that is known as a horizontal scaling. The horizontal scaling case, you add more resources horizontally to your fleet. So you have one M3 medium, you add one another M3 medium, you add another M3 medium. All three are managed by the elastic load balancer. So suppose you have a 10 requests coming up. Now even if you have a 300 requests coming, it would be evenly distributed among each machine with the 100 requests. So that's the horizontal scaling for you. Amazon auto scaling helps you achieve horizontal scaling. It adds more resources horizontal to your fleet, and you can also make them part of the ELB automatically, which allows you to scale horizontally. And believe me, the horizontal is the go-to thing for you, because if you want to add more and more from 5 to 10 to 15 resources, that's a possible. Plus, it does not need any downtime, and it doesn't need, or it won't have any capacity threshold like a vertical scaling. You keep on adding, it would work perfectly for you. Auto scaling helps you achieve horizontal scalability for your applications. It's a perfect case for the high availability. It can scale up and scale down EC2 capacity automatically based on the conditions defined. You can manage your desired capacity. Now, what is that? When you make an auto scaling case, it would have three kind of a parameters: minimum size required, maximum size required, and desired capacity. Minimum means it would never go below those many numbers. So suppose at any moment you think I need two EC2 instance running. So at auto scaling level you define that I need two as a minimum. Now due to any conditions it would keep adding more resources because there is a load increase something. What happens if there is a DDoS attack and it keeps adding more and more resource? You don't want to do that. Or there is a known case because you know there is a virus scan going on. It's not a real increase in the load, but my CPU is behaving oddly. What you can do is you can set up the maximum limit also. You can say my maximum limit is 8. So when the load increases, it keeps adding more and more resources. So from 2 to 3 to 4 to 5, it would not go beyond 8. It would stop at 8. So this way you can control. And at any moment, how many instances you want, that is defined by the desired capacity. You would see in the demo how can you scale up, scale down, how can you define the minimum size, maximum size, and the desired capacity. But it's important to understand these are the three parameters: minimum size, maximum size, and the desired capacity. And with this, you can see you can increase or decrease capacity seamlessly. Now that's why this is the perfect case of the cost optimization. You would say, how would it optimize my cost? Imagine if you have 5 instances. Now, for these 5 instances, you might have to, you don't want the 5 instances running all the time. You say at any time keep 2 running. Whenever required, load increase, add 1, 2, 3 more instances over there. If you were in your own data center, you might have a procured capacity as per 5 instances and it would running. Here, you are running only 2 instances. As and when load increases, you add more resources. As and when load decreases, you remove the resources. And beauty of Amazon is you pay for only what you have used. So you would be paying for those 2-3 instances only when they are available or only when they are being used. That case, you would be paying for those additional 2 to 3 instances for some few hours only. That's why it's a huge cost optimization for you too. Autoscaling helps you to achieve the best of the high availability because it does keep check of the health of the instance, and even if it finds any of the instance unhealthy, it would terminate that and launch a new instance for you. You will read a little bit more about that in the future. Also, if you think, it helps you since it's a scalability. So if one zone goes down, so that instance stops behaving, it would automatically scale up because the CPU load increase, something like that, and it would help you achieve high availability and disaster recovery too. Autoscaling is ideal for hourly, daily, weekly variability. If you ever load something which is in a spike, something like this, that's not the case. The reason is by the time it spikes up, you are about to spin up a new instance. It has spiked down, it has come down, and it's about to be terminated. Then again it spiked up, it is about to be launched. So you have to find a pattern and baseline something, and then only you should be setting up the auto scaling formulas or events to come across. It works with the ELB and the CloudWatch perfectly. We'll be seeing in the demo how does it help you. And the most important, it does not cost you extra. It's a free of the cost service. So auto scaling is elastic by nature. We know it's elastic. It can add more compute power elastically, and that's why it helps you in the dynamic scaling. You want to add the resource, you want to remove the resource. It helps you for that, and that results in your cost savings because you are paying for the resources which are added only when required. So helps you for high availability. The important point is it works within a region only. So auto scaling is particular to a region. So whatever condition defined would be part of that region only. Whenever load increase, it would keep on adding. Whenever load decrease, it would keep decreasing. It works in that way. Auto scaling, how do you work with that? So there are the few steps you need to follow when you are working with auto scaling. First and foremost step is you create a launch configuration. So when you go to the auto scaling, there are two things you need to work. One is a auto scaling launch configuration. Another is a auto scaling group. Now, what is a launch configuration? You have to think what is the role of a auto scaling. It launches an EC2 instance based on the condition. Now, while launching an EC2 instance, what all parameters do you need? You need instance size, you need key pair, you need AMI because it would be launched from that. You need security group, you need EBS volume, and a few parameters which are required to launch an EC2 instance. While launching an EC2 instance, we have followed these steps multiple times. That is the exactly thing you define in a launch configuration. Here you identify the EC2 runtime parameters. That's a very important. The AMI ID is the most important because you want that I have a application set up with the Apache web server. Now I want to do that whenever there is a load increase, it would add a Apache server over there or new instance over there, which is the Apache server already running part of that. What you can do is you set up an EC2 instance, install Apache over there, configure that whenever the instance boots up, Apache starts automatically, and create an AMI out of that. Provide that AMI to EC2 launch configuration. So in future, whenever autoscaling launches a new instance, it would launch this also. It would also launch this instance, and where the Apache is already installed, Apache would start automatically, and you make it part of the load balance, it would start running for you as it is. It's very important you identify the runtime parameters, and that would be defined based on your AMI. That's the one key aspect. Apart from the AMI, you would be selecting more parameters like key pairs and the security group and the EBS volume size and a few more. The next step is, and here you are just identifying parameters. The next step is you create an auto scaling group. In the auto scaling group, you would be selecting or taking this launch configuration as part of this, as well as you define maximum size, minimum size, and desired capacity as part of this. You also define which all zones does this. I'm talking about zones of a region, not multiple regions. Zone of a region. Which all zone this auto scaling be part of. So what happens? As soon as you create an auto scaling group, it would launch an EC2 instance. How many instances it would launch? It would be based on the desired capacity. And if you have not specified desired capacity, then what is the minimum capacity you have specified? Based on that, it would launch EC2 instances. Those instances would be launched based on the launch configuration parameters you have selected. It would select the same AMI ID, same key pair, and everything it would take out of that. So your first step was creating a launch configuration. Second step is creating an auto-scaling group. Once all this is done, you can create an auto-scaling policy. In the policy, you define that whenever there is a threshold above 60%, below 60% something, or based on time, you launch a new instance. So as soon as CloudWatch detects the condition breach, it would notify auto-scaling and it would execute this scaling process. When the scaling process is executed, that also be part of ELB, you have configured that. So everything works seamless for you. Launching a new instance, and even if the vendor it goes below the threshold, it would terminate the instance also. So when you think of the auto scaling process, the important steps are creating a launch configuration, creating an auto scaling group, and creating a policy for that. Auto scaling with the elastic load balancer gives you a perfect resiliency. So what happens? Suppose auto scaling has launched an EC2 instance. Now that instance is also added to the elastic load balancer. Autoscaling itself also performs the health check on the instance. Now we know ELB does perform the health check on the instance. Autoscaling also performs the health check on the instance. In this case, as soon as the instance becomes unhealthy, ELB would stop sending traffic to that instance. ELB would stop sending traffic to that instance. We know that ELB keeps check of the health of the instance. When it's unhealthy, it stops sending traffic. And if it's unhealthy, autoscaling would terminate that instance automatically. And since it's a terminated, so your desired capacity has to be maintained. Autoscaling would launch a new instance as per the desired capacity. That instance would be part of the ELB again, and the whole thing starts working back to the normal. So even if due to any zone outage or any other outage at Amazon level, instance goes down, ELB would stop sending traffic to that. Autoscaling would terminate and launch a new instance for you. That would give you the case of the perfect resiliency. Autoscaling works in the three scenarios. Let's see what are the possible cases in this three scenario for the autoscaling. First is a based on the time. Scaling based on the time. You can create a schedule action. Suppose when you are doing your load monitoring with the CloudWatch, you feel that every day 9 a.m. the load increases and every day 5 p.m. the load decreases. What you can do is autoscaling allows you to scale based on the schedule. So you can create a schedule where based on that load it would automatically increase the capacity, based on the schedule it would decrease the capacity also. You can set up the time in Amazon Management Console. You can also set up, it's not a week, one day. You can set up that if it's a recurring, it's a one time, what do you want to set up that? And based on this desired capacity, it would be changing that. So this is scaling based on time. Where you know the pattern and you want to scale up, scale down, you can do that. Second is a dynamic scaling, where you want to scale based on the conditions. You don't know your application is working normally, but suddenly there is a huge hike on the load. Let's at the 9 a.m. the load has increased by the 50% or 60%. At 5 p.m. the load has decreased by this something. It happens. Now, what would you do that? You would be creating a policy for scaling up and scaling down. You can say that, sorry, it's not a time waste, that's my miss. You can set up that, okay, when there is a CPU utilization, so if I say my application is working normally, my normal CPU utilization should be below 60%. Now, due to certain conditions, if the load increases and it stays there for a longer period, you can set up a policy which would scale up automatically based on these conditions. So you can create a CloudWatch alarm which says that whenever CPU is more than 60%, notify auto scaling. Now, this auto scaling would then take up and launch a new instance as soon as it receives a notification from the CloudWatch. You can also set up a bottom threshold that whenever it's below 20%, again notify auto scaling. So whenever it goes below 20%, it would then also terminate the instance. So you can set up the scale up policy and scale down policy. In the same game, third is the manual scaling or the constantly growing scaling. When you want to follow the certain pattern, how you want to scale up or scale down, you can do that. And this is more about that okay, this is the time I want to increase the load. You don't want to wait for any conditions, you don't want to wait for any time base, you want to do it manually. This is the case for you. It's very easy. You just go to the you just go to the auto scaling and change the desired capacity to your required, and it would be based on the desired capacity, it will scale up or scale down. The one of the exact example I would say, due to certain conditions you have set up that okay, it should scale up, but you don't want to set up the scale down policy as of now. So what you've done is when the load increase something happens, you would be scaling up. Now after some time you think okay, this is the time now I want to scale down, you can go and manually change the policy. Again, as long as there is a less manual intervention, that is the best policy, but in some cases you might require that. So you can think of that option too. This is a simple architecture of the how the auto scaling things would work. You would have a website, something like example.com, that is being mapped to some IP address of the load ELB, and I would say not IP, it's a DNS using Route 53 service. With this elastic load balancer would be sending the request to the instances, and there is an auto scaling configured as part of that. When auto scaling is configured part of that, and whenever there is a threshold or some breach of the conditions, it would add more resources to this auto scaling group, and that would be again part of the load balancer. So when the load increase over the example.com, automatically it would be taken care by the using elastic load balancer, auto scaling group, and CloudWatch. It can scale up, scale down based on the policy defined, and it receives the alarm from the CloudWatch. Let's try to understand a few vocabulary of the auto scaling. Auto scaling has a launch configuration. The launch configuration we spoke about, it's a first step to create your auto scaling, where you define what all runtime parameters it should use to launch an instance. This is the EC2 runtime parameters. Then it does have an auto scaling group too. Auto scaling group is nothing but a representation of a multiple EC2 instance. So it uses the launch configuration to launch an instance, but what would be the max size, minimum size, what zone it supports, that all thing you define in the auto scaling group. As soon as the group is created, it launches a new instance. You also have a policy. A policy is that you define that based on the response from the CloudWatch, what action should auto scaling take, whether it should scale up or scale down, that is defined in the policy. A trigger is nothing but the what you receive from the CloudWatch. When a CloudWatch you receive an alarm from there, it would be part of that. It is part of a.
Just a quick info, guys. If you want to make a career in cloud and DevOps, then Intellipaat provides an advanced certification in cloud computing and DevOps by ENICT Academy IIT Roorkee, and it is taught by IIT Roorkee professors and industry experts. This course is designed to help you upskill and land in your dream job. Now, let's continue with the session.
CloudWatch alarm and auto scaling policy. So as soon as the alarm crosses the threshold, it notifies auto scaling. Auto scaling policy would be executing the thing. That's the whole thing is called as a trigger. And auto scaling keeps checking the health of the instance regularly. It does perform the health check and keep the check of the status of the health. So as soon as it finds any instance unhealthy, it would terminate that and launches a new instance on place of that. What are the use case for the autoscaling? It's ideal for the web tiers or stateless tiers. So you should use it for the Apache, Nginx, Tomcat, JBoss, wherever you have a web server tiers, it is required for that. Can you use it for the load database? You cannot. We'll see in a moment. So ideally, when you have web servers which are facing the external world traffic, or when you have a stateless tiers which does not manage your states, that is the case for the auto scaling. We learned the three types of the scaling: manual scaling, scaling by schedule, and scaling by the policy. It's a recommended that you should have a two policies, one for scaling up and one for scaling down. Let's try to see a little bit of the scaling in depth. The scaling is recommended when you have a gradual rise or the gradual low. If you have a spiky requirement, scaling is not for that. Yeah, there is a spike of the increase, scaling is that. But what I meant is spike up, down, up, down, up, down. That is not the case for the scaling. You can create up to maximum 100 launch configuration as part of the auto scaling. In some case, you want to suspend the scaling. You want to resume because you are doing something new installation. You are doing something over the instance. You know that. So you can suspend or resume the scaling also. You can have maximum 125 scheduled actions for auto scaling group. So every day it can have allowed 4 actions per day. That's a possible. Also, when auto scaling is terminate the instance, you can define in which way it should terminate. That is the oldest instance first, newest instance first, instance with the oldest launch configuration first, or instance which is closest to instance R, that is for the pricing base first. You can define that also, and we would see that also in our demo. We know that EBS back AMI boots faster than the instant store back. Ideally, word should be instant store back AMI. And even it's easily to make also. So that's a recommended to use the EBS back AMI as much as possible. Yeah, you cannot modify your existing launch configuration. So in case you have created a new AMI and you want to change the launch configuration, what you have to do is create a new launch configuration and modify the auto scaling group with this new launch configuration. You cannot update existing launch configuration. You can use spot and reserved instance also with the auto scaling. Auto scaling works across the multiple availability zones within a region only. It works seamlessly with or without ELB. In some cases, you might not need ELB because you're doing some Hadoop or batch processing. You can use the auto scaling for that purpose also. Auto scaling checks the health of the EC2 instance regularly. It does perform the health check, and during the health check, if find the status of the EC2 instance okay, then it's a good. If it also performs the health check of the ELB also, if it find the ELB health check in service, then it's a good. If it find it's not running, because what happens, an EC2 instance is registered with the ELB. Now, when it's registered, the status of the EC2 with the ELB would be in service. Due to any reason, if it's out of service, auto scaling would mark that instance unhealthy and terminate that. If an ELB is unhealthy, all instance will be also marked as a unhealthy. Auto scaling does also support its own metrics for the CloudWatch. They are like what is the minimum size, maximum size, desired capacity. Yes, if you have enabled the detailed monitoring with the auto scaling for EC2 instance, that is a chart. Auto scaling should never be used with the database unless it's a read-only data. Why? Imagine a case, you have a database. Now, suppose the load rises and you say, I want to spin up new database instance. What would that result? It would result in inconsistency because some data comes to this machine, some data comes to this database. The data is not consistent. You cannot have a two instance. So, and plus auto scaling can terminate this also whenever this load decreases. So your data would be lost. Since it's a persistence tier, auto scaling should never be used with the database. If you have a read-only database, then only you can do that. So what happens that your data is coming only for the reading part. It's not doing any insert, dealing, anything update part over there. Then it's okay, because if you have a 3 instance, 5 instance, even if the one terminated, you don't mind because it's a read-only thing. When we go to the RDS, we will see that read-only part too. If you have a critical configuration like log, audit trail, something coming to the EC2 regularly, you should plan keep moving them to the S3 at regular interval. You should also optimize your resources after monitoring pattern. You should keep monitoring your resources regularly, and whenever you find upward downward scale, you should add or remove the resources too. So this is all about the auto scaling in the theory. Hi, in this we are going to learn about the Amazon economics, and we will also have Amazon billing and account overview. Till now we have learned the various Amazon services. We went the deep down of many services like EC2, EBS, CloudWatch, up to RDS, Route 53. We were covering many services in deep down. We also get a very good overview with the hands-on demo for the DynamoDB, Glacier, CloudFront, Import, Export, SES, all that we tried to cover here. So the purpose was, we all should be prepared and understand why this is helpful. You should understand why these services are useful and how would I use in a practical case. At the same time, when you are preparing for Amazon architecture, it's also important to know how do I optimize the cost, how do I plan for the Amazon, what budget would Amazon need, or what would be our monthly costing. How do I monitor those aspects also? So it's very important to know the other aspect of the, apart from knowing the Amazon services, the other and very important aspect of the Amazon. So for that part, we would be learning about the Amazon economics. After that, learning Amazon economics, we would be going to the Amazon account overview. So I'll go in there. I am on our website awsamazon.com/economics. When I'm here, you can see it gives me some overview about the economics, how Amazon can help you optimize the cost, you can save the money, how much, and you would be wondering with the numbers, are this number true? Would I get my return on investment in just 6 months? How would I get more? Gartner has always put the Amazon in the leader quadrant since the beginning. So even we know that in 2015 this was the leaders quadrant. How would we know how much am I going to save this? So for that part, I'm just clicking on the resources section on the left hand side. So when I click on the resources, it gives me a few calculators, and which are very nice to have the calculators. Apart from that, Amazon also gives a good white papers. One of them is how does Amazon pricing works. So you can know and read about this, that how you would be, whatever you're planning, how much Amazon would be charging you. Also, introduction to Amazon economics. These are the very nice white papers. You must follow that or read that. For now, we are going with the AWS total cost of ownership white paper. So when I select this is my total cost of ownership white paper, where this would be useful. So when you are just planning as an organization, you are planning to move to the cloud. You want to move things to the cloud, but you don't know how to do that. You are not sure how would I optimize my cost. You are not sure how am I going to reduce the cost, or whether Amazon is the right solution for me or not in a pricing wise. For that case, you might need to go with the AWS total cost of ownership calculator. So when you go, I'll just click on the launch the total cost of ownership calculator. This would be giving you an overview about if you're hosting something on your on-premise thing and something you are going to host on Amazon, how much you are going to save the cost. That is the concept here. So let me start with the basic. We go with the USD as a amount. Okay, so what are you trying to compare against? I say, are you going to use on-premise or are you going to use the co-location? I say I'll be using on-premise. Their whole infrastructure was going to be in my data center. Now instead I'm thinking to move to the Amazon. So what is the cost comparison between that? Where are you going to host? In which region? I would say I'll start with the US East region. Were you planning to use the physical machines or were you planning to use the virtual machines? In that case, I would say I was planning to use the virtual machine because that would give me more resource optimization. But I was planning to use the virtual machines. Okay, so how many things are you going to use? I was needing a web servers where I had at least 4 web servers requirement. They were all 4 CPU, 8 GB RAM. I'm just going a rough estimate. For a hypervisor, were you going to use the VMware or open source? I'm saying I would use the VMware. The costing would be different for the VMware because it would be having a license cost also. As I was requiring app servers also, where I required 4 app servers. They all had a 4 CPU but required a more memory, 16 GB RAM they were required. I'm just putting a rough numbers here. Then I needed database servers also, where I would have 2 database servers, one primary, one secondary, but they would be very high configuration. So this is my requirement. Do you need a storage? I say yeah, I need a storage, but I don't think I would be having more than 2 terabytes of storage. That's the okay for me. I'm not going to even use 1 terabyte. So just keeping 2 is a buffer part. I'm okay. And now I say run calculate total cost of ownership. It's a calculating some magic numbers for me. And what it says, over 3 years, over 3 years, you would say almost $200,000. That's the whopping number, $200,000 just saving. You would be great, glad. Wow. Let's see how it works. So Amazon, when giving you this estimate, it goes for the 3-year reserved instance part. So that is where you would be saving, because we know with the Amazon, even 3-year reserved instance helps you save almost 40 to 50% of the cost. You would just try to compare the things. So your on-premise server might be costing you $161,000. How this cost come, we would see in a while, because the bottom Amazon has explained everything. Well, Amazon, it would be costing much cheaper. Storage also would be very cheaper for Amazon. Your networking cost, you need to procure a network, which Amazon would not need to. So your total cost is almost this way compared. So from comparing 239 to 42,000, that's how you would be saving almost $197,000. If you go a little deep down about each and every aspect, what Amazon has compared. So when you say I was requiring a 4 VCU and a 8 GB RAM machine, Amazon recommended M4 large for that. For app server, it recommended M4 extra large, and for database it recommended M4 4x large. So these are the 3 things it has recommended to us. Then I'm going to use the storage part. So how is the storage going to help me? So in the storage, you would have a 2 terabytes of storage required. So that's what it has considered. Here it has considered CPU. How is this matches? Going little on a pie chart way. This is how the costing for the on-premise works. Well, for the Amazon, this is all about the your infrastructure cost. Also storage cost is how this is considered. Now, how did Amazon calculate these things? So we come to the calculation part. So Amazon says in the left hand side, server hardware cost for these machines. So it would be using these machines, and this would be costing you around 6,947. So this is the unit cost it has worked out. For each unit would be costing around 10,000, and it considers that the vendor is giving you 25% discount. So this is how the cost is working out. And this cost it has got, we'll go a little below and see how this cost has come out to also 900,000. If it's for your organization, that's a different cost, you can consider that. This is the hardware maintenance cost you might be paying over the year, 3 years. You might need the racks. So what is the cost of the rack infrastructure? That is also coming. The rack is a very costly infrastructure. Virtualization software. So if you are going with the VMware, you would be paying 100,000 almost for the VMware. Your facility cost. your server cost breakdown, how it's coming out for you. Now when you compare everything, also your storage cost, total data center space, power costing and cost. So it has also counted because you need a data center. You would be paying for the electricity. You might be paying for the cooling cost and everything, AC and everything. So that's the cost also it is counted. Considering all this, it's a much higher. Then this is the networking cost, which Amazon you don't need to pay. Yeah, in the Amazon you need to pay for the support. So that's the support cost. It is counted also. Support cost for the reserved instance also it is considered. So all these costs it is considered. Now we go for the methodology. How does this work? It says total cost of ownership. Use this the following methodology equal to acquisition cost plus operational cost. So how much you need to pay for the paying for procuring this infrastructure and how much you need to pay to keep it running over the period. So this is your cost is coming out. Server cost, storage cost, network cost, everything. Also for the on-premise or co-location, how much it is costing you. So your total cost of ownership. Then your server cost, storage, everything what you are counting, Amazon has considered that. So you should be able to refer this to what Amazon offers and what would not be available in your infrastructure, which you might need to pay additional for that. What are the assumptions Amazon has made? So here the pricing also, the server and rack pricing. So for that it is considered Dell PowerEdge prices which is available from here. It is considered the HP ProLite rack servers pricing which is available from here. So different kind of a rack, HP, all that pricing it is done. Considering all this, it has made the assumptions and the calculation for you. If you have any questions also, there are the few questions answered here. You love the report, you want to show to your management saying I'm going to bring 200,000 savings in 3 years, everybody would love that. That's where you can download the report also. So this is how the Amazon is one of the most effective or cost optimization way for you. Yeah, you might need to go for the reserved instance. This is a much higher level, or I would say 30,000 feet overview Amazon cost optimization technique for you. In some case, you would need to go deep down and understand how am I going to save the cost for each and every service, or how much Amazon going to charge me. So for that, in the resources, there is AWS simple monthly calculator available. If I go to the simple monthly calculator, this is the simple monthly calculator, which is a very helpful tool which would help you to calculate the various cost of Amazon over the period. I'll start with the Amazon EC2. So what I'm going to use, I would say I'm going to use web servers. How much I'm going to keep it running for all the time, 100%. What type of instance are you going to use? I'm going to use the m4.large. The m4.large cost you 12 cents per hourly, but if you go for the reserved instance, it will be effectively 0.04. So for now, we are not going with the reserved instance, we are just going with the normal case. I would say I need 4 for the app servers. Again, I would need 4, but I would need a much larger capacity now, not much larger, one larger, m4 extra large. Then I'm going to use the DB servers, 2 m4.4x large. So considering also you would need a storage, so you would say yes, storage. You would need one volume, we are just going, I'm going with the general purpose. I would need 2 terabyte almost storage. Am I going to take the snapshot? Yes, I am going to take the 2 GB of the snapshot every month or 20 GB. So that's where over the period my storage would keep increasing. Are you going to use the elastic IP? Would that elastic IP be unattached? How many elastic IP remap you are going to do? What is your inter-region? What is your intra-region? All the kind of a data transfer you are going to read or do. What is VPC peering? If you are going to use, we learn about VPC peering. How many elastic load balance are you going to use? So considering all this, when I go to estimate of your monthly bill, it comes to $3,000 per month. Here it is considered, it is going to give me the first 12 months free tier also it is counted. So out of this 3,000, almost $2,400 cost is for the EC2. It is considered the AWS support cost also. I would go and say I don't want to count the reserved instance, sorry, free tier part. So here my monthly cost comes to almost 29-21, and again my EC2 cost comes to 2,450. I'll just write it down, 2,450. We'll need to wipe out anyway. And we have not used anything like a reserved instance as of now. Let's see if the reserved instance is going to save some cost for me. I would say for 1 year all upfront reserved instance. In all cases I'm going to see. Remember we were paying $2,450 per month. Same way 1 year all upfront. I'll just put down the things in the notepad also for our easier reference. 2,450, no reserved instance cost. Then I go and say here now my monthly cost has come down to $300 from 3,000. Why? Because I have already made a payment of almost $17,000 to Amazon as an all upfront cost for the reserved instance. So now then it would not be charging me anything on a pay as you go model. But what am I going to save here? If you see now almost 17,000, 16,900. So almost 16,900. One time payment I have done. But what is it saving me? At the same time, it would be saving me almost 2,450 per month, because that's what it's not going to charge me. Let's do some math. Let me open the calculator. Almost $17,000, and 2,450 into 6.5, almost $16,000. So almost we say in 7 months I am able to recover all money. So from 7th month to 5th month or 12th month, the 5 months cost I would be saving a lot with the reserved instance. Here, because I have paid one time upfront almost 70,000 from first go, this way I am saving 5 months of cost. If I am going to keep on running 24/7, I am going to run by the 5 months of cost. If I go with the, instead of 1 year, I go with the 3 year all upfront. My monthly bit says same, but my annual payment or one time payment is now raised to the 32,854. 32,854, 3-year payment. Now what is the difference here? If I consider the monthly also, Yeah, let me open my calculator. $24.50 into almost 14. Okay, so almost in 13 months only. If I was on demand, I would have been paying 2,450 fixed cost every month. So in 13 months only, I might have paid 31,800, 32,000 almost. So in 13.5 months only, my reserved instance payment would have been recovered. 3 years. In 1 year per reserved instance, it was in a 7 months, here in a 13.5 months. If you see another important thing, if you are going for a yearly reserved instance, you pay 16,900. So if you are going year by year renewal, that means you are paying almost 33,000, almost 34,000 in 2 years period. While if you go ahead and pay for 3 years upfront, you are saving almost whole year even on the reserved instance 1 year payment. So this way, reserved instance helps you save a tremendous amount of cost. Yeah, it's required. You need to understand that when I'm going to use the reserved instance, it's going to cost me in a way, because even if you don't run the instance, it would keep on costing you 24/7 for 365. So if you're sure you're going to run your environment 24/7 365, you must go with this reserved instance option, which would help you save a lot of amount of money. We would see different services also now. You can clear the form from this part. We will now check some other services also. So if I click on Amazon S3, this is how you can help, or you can calculate the cost of Amazon S3 storage. For example, you are going to store 500 GB on Amazon. How much would it cost you? What would be the how many requests you are making? How many get and other requests you are going to make? So for each and every, are you going to use the infrequent access storage object? Are you going to use the RRS? Or what is the data transfer you are going to make? Each and every service would be costing you. Data transfer in does not cost you. Data transfer out only cost you. But Amazon says it's good to put the number so you are aware about then how much it would be costing you. Also, we can clear out this form also. So we know that for the S3 it would be costing around $15. I can clear out. I can go for Route 53, CloudFront, RDS, DynamoDB, whichever service is offered by Amazon. All services are mentioned here. Also, if you are going to procure the Amazon support plan, the Amazon support plan cost is also mentioned here. Now, Amazon also gives some ready to use examples. Like if I want to use the disaster recovery backup or large web application all on demand, where this is an example created by Amazon, which looks like this, where it would be a 3-tier application, web tier, app tier, and the database. It uses DynamoDB for session management, Amazon RDS with the read replica or the standby, multi-AZ, Amazon S3, CloudFront, all it's using. I'll say go and give me the details. Here the monthly cost is coming almost $1,000. So in the $1,000, when you go to the EC2, it says it's using two web servers, but all small. It is using the 300 GB of storage and 10% of the storage as a snapshot. It's using Elastic IP also, an Elastic load balancer. Same way it might be using the various other service, so it would be using the Amazon S3 also, so the cost of the S3 also mentioned. Then cost of the Route 53, what it is using, CloudFront service, RDS service, all the services cost mentioned here. So you select the RDS, it uses the one MySQL database, multi-AZ of 5 GB, m1.large. So how much it would be costing you? So that's your RDS cost of $337. One thing it's very important for us to understand also, whenever we are selecting, remember to select the region also, where you are going to host. Because if you change the region, the pricing would different also. So from US East to US West, the pricing US West is almost similar. But here, when I go for Asia Pacific, if I'm going to host something here, the pricing would be different for me. So you have to think for which region you are hosting and select the accordingly. One good thing also Amazon gives is you can save this. So you can say save and share. So when you say save and share, it would create, you can put down the numbers, details, all that, and you can say, when you say okay, it would generate a URL for you, a static website hosted Amazon S3 URL for you. This URL would be very helpful for you because now this URL would allow you to share with any of your peers, colleagues or managers, and they can directly come and view this here. Let me see if I copied correctly and I can put the paste here. Oops, no, I should try again. This is how, when I paste it, it would bring down the same thing for me. So you can use it for copy and share also. So this is all about the Amazon simple monthly calculator, a very powerful tool and very helpful tool also when you estimate your monthly budget, yearly budget, what service you should use, reserved instance or on demand or what, how much difference would it make for me, everything it would come handy for you. After looking at the Amazon economics aspect, it is also important for us to understand the Amazon, how does this real billing things works and how do you manage that. In the CloudWatch session, we learn about that we can always create a unique, or rather we can create a billing alarms, which we did that. We would be going here. So when I'm here, under my name, I would be clicking my account. And there is a billing and cost management. Two aspects are there. I would be just starting with the my account. So this is my account settings. So this is my 12-digit account ID. I can change the password. Then this is my billing. If I want to define anyone else also for the billing contact, so if there is some issue or there is any escalation, it would be mailing to this person. What are the operations? What are the configure security challenge questions? So I am user access to billing information, account contract information, any communication preference, your cancel service, all this would be, if you want to cancel out your service completely, you can do that. If you want to close your account, you can do that here. So this would stop charging you anything. You could come to the dashboard. This would give you your monthly spending. So last month there was 82 cents. This month it might be costing me around 79 cents. This is just an anticipation from Amazon. Now, if I want to see my bills, I can go to the bill section where it would be giving me detailed report. So I can click on the March, and this is the March consumption report where it says $82. Out of that, my major cost was Elastic Compute Cloud. Though I was using free usage tier, it charged me for the net gateways. So net gateway cost me. It charged me for the database. Then in the Elastic Compute Cloud also, I had demanded a medium instance for the OpenStack and all that OpsWorks. It did that. So that's also one cost. Then Elastic Block Storage, whatever the cost was there. So this is my Elastic snapshot cost. Snapshot would be chargeable. These are the cost of the snapshot for you. Elastic IP address, time where my IP was not released, almost for 82 hours, it also costed me. So all this cost is counted out, and then it cost me almost. So this is my Route 53 cost. I did some Route 53 for a while. Simple email we tried, so that's also cost for that. So considering all this is my total cost, almost 54 Indian rupees coming to this. I can view various reports also. So Amazon gives you an option to create a reports based on the usage part. You can go and create reports. I can also do the cost allocation. So if you have created a various tags, like you have created a tag for the production, or if I say VPC, there was based on the name. So based on name, we were giving a various name. So you can generate what are the tags you generated, and then based on that you can create the various reports also. Then what are the payment methods? Your credit card information would be stored here. Then there would be a payment history, how much payment you have done till now. There is a consolidated billing account. That's an important. If you have a multiple AWS accounts, you should, instead of paying from the one account, you can use the consolidated billing account. So in that case, what would happen? You have a master pay account, and you have 3 different verticals within your organizations. You can say it's a production, development, and test. And this is the another account for your HR or admin or somebody or IS team. It is using that. Now, since you have 4 accounts, you might be getting 4 bills. You would be paying for the 4 different person for this. How would you manage it? Here for you, you can configure a master pay account and link all this account with this master pay. So you have to send sign up consolidated billing, and you have to send all 3 accounts request for this. Once they accept the request, henceforth all the charges for this account would be billed to this account. So this becomes a master pay account. It's just a payment facility. So instead of 4 bills and 4 separate payment methods, only one account is paying for you. So that's how you would be setting up the consolidated billing also. You would have your own preference, and this is where we set up the billing alerts part. So we can set up the billing alerts. If you want to get the billing alarms, you want to receive that, you can do that also. If you want to receive the emails of the invoice by mail, you should mark that. So this time every month it would be sending you over the email. You want to get the credits. If your Amazon has given you any credits and you want to use that, you can add those credits here. How does the text settings work? So if you are having any PAN number and you have done any settings, you can do that also. So this is how your overall dashboard. And it's a very important. You should go to this your console, keep checking your bill regularly every 3-4 days, and without fail, you should have set up the billing alerts. This is a very, very important aspect. You should not forget that. We can see that apart from that, there is a security credentials also. We checked that before also. I'm just giving a very quick overview. So in the security credentials, you can modify your passwords from this place, your account. If you want to enable your multi-factor authentication for your organization, for your root account, you can do that. Access key and secret access key, these are helpful when you have a access key and secret access key available when you want to access Amazon services like EC2, EBS, RDS, VPC, anything over the web APIs or SDKs or command line tools. This would be helpful for you. CloudFront key pairs are also very helpful for you. So CloudFront key pairs would be when you want to secure the access, you want to create a unique URL, you would be able to use that. X509 certificates are helpful when you want to make a SOAP protocols over the web service. When you want to use the REST calls, you might use access key, secret access key. For SOAP protocols, you might use the X509 certificates. For the account ID, this is my account ID, and this is a canonical user ID which is useful for the Amazon S3. For when you want to configure the AWS access control list, you can give this canonical user ID also. So this is how the security things will work for us. So this is all about our Amazon account overview. AWS Glacier. Here we would have an introduction of the Glacier. We would understand what are the key terminology of the Glacier, and we would see a demo. Now before we begin, what is a requirement for the archival? Suppose you are having a very large data set, but that is very infrequently used. If I give you are having a banking data, right, where you need to keep the transactions of your own bank transactions for at least 6 to 7 years as per IT laws, but you are not referring them day-to-day basis. You might need to store them. Now suppose this is a company and where there are the huge data covered like that, which might be in a gigabytes of the size. You need to maintain that. Or you think of there is a factory where there is a manufacturing going on, where there would be lots of data available about the manufacturing units, the procurements, the POs, invoices and everything. You again need to maintain those data. Now the common factor in all this part is this data is hardly used. Like in the banking data, only when there is an audit requirement you would be able to use, or in the invoice or some other where there is a query you would be able to use. Otherwise you don't use it, but you still need to maintain them. So you need data to be stored only considering there might be a future need. There might be. And another point is, you don't want the data to be available immediately. You don't want the case that, okay, I need data now, give me in a moment. You are okay that most of the cases, even if you get in 1 or 2 hours or 3 hours, you are okay with that. This is the perfect case of archival. These are the cases where you would be using the archival services. Amazon Glacier is an extremely low cost storage service used for the data backup and archival. It's a AWS managed. It's a scalable archival service. So your advantage is you don't have to do any capacity planning. You don't have to do any hardware provisioning, any kind of a data replication, hardware failure and detection, repair, automatic. So maintenance of that. Everything is being taken care by Amazon Glacier. You just have to put the data, it would be archived and managed on behalf of you. Imagine you have a terabytes of the data and you need to maintain that. How would you do that? Amazon Glacier would come very handy for you. Glacier, when we try to compare with the Amazon S3, if I am trying to store a 500 GB of the storage, Amazon S3 would cost me around $15. At the same time, Glacier would cost me $3.5. Now when you compare these two, this is almost less than 10% cost, or almost I would say 20% or 25% of the cost of this, less than 1/4 cost. So that is the advantage of the Glacier. But Glacier is not a replacement to Amazon S3. They both have a practical difference. The cost wise, S3 is cheaper, Glacier is the cheapest. They do charge you for the put, copy and different services. Even object size, S3 supports maximum 5 terabytes, Glacier supports maximum 40 terabytes. Here the difference you lie is access. When you go to S3 and you try to access, data is available immediately. With Glacier, it takes 3 to 5 hours minimum to make the data available to you. In S3, data is stored in a unique bucket. The bucket has to be unique across the globe. While here archive is available in a vault. We call it an object there, here we call it an archive. So the purpose is, this is useful when you have a frequently accessed objects. We learned about the static content storage. When you have static files, you want to store that, S3 is the perfect solution for you. Glacier is for archival only. When you don't need the objects to be available immediately, you request and it would take 3 to 5 hours to make that object available to you. But that's why you save the humongous amount of cost with that. Let's try to understand the concept more. Glacier has two concepts, vault and the archive. A vault is nothing but a container for storing the archives. While when you create a vault, you would be specifying a name. You select an Amazon region for this vault. So vault would have a unique URL, something like HTTPS. Everything would always be HTTPS. Then glacier.something, that is the which region it belongs to. Your account ID, this is your AWS account ID. Then vaults and then the name of your vault. This is how a vault would be created. Difference between vault and object bucket is, bucket name has to be unique across the globe because it was accessible over internet. Vault does not need that restriction because vault is not accessible over internet. So that's why it would always have account ID part of that. So it has to be unique for your account only, not across the globe. Otherwise you can think vault is like your bucket only because it's a container for storing the archives. Same way your archive is also like a file or object. What you want to archive, what you want to store the data. It can be any doc file, PDF, image, photo, video, whatever you have, you want to do that. Each archive has a unique ID. This would be archive ID. So this would be your vault name, and after vault there would be a archive ID, a huge long around 64 digit plus ID offered by Amazon Glacier. These archives ID are always unique. So if I upload one archive, it would be assigned a unique ID. I uploaded second archive, it would be assigned a new ID over there. So each archive would have its own ID. And you can always do an unlimited number of archives in a vault.
Just a quick info, guys. If you want to make a career in cloud and DevOps, then Intellipaat provides an advanced certification in cloud computing and DevOps by NICT Academy IIT Roorkee, and it is taught by IIT Roorkee professors and industry experts. This course is designed to help you upskill and land in your dream job. Now, let's continue with the session.
Let's discuss why one must opt for GCP. GCP offers various unique features such as best pricing, automatic task scheduling, live migration, customization, flexibility and scalability. Let's discuss all these features one by one, starting with best pricing. Google Cloud uses a pay-per-use model according to which you only have to pay for the resources that you use. Also, Google Cloud hosting plans are said to be cheaper than other cloud hosting plans. So, GCP provides customer-friendly pricing where there is no upfront cost and termination fee. Automatic task scheduling. Google Cloud allows you to virtually schedule any task or job, be it running your staging VM environment only for working hours or turning down half the machine fleet in the middle of the night. The cloud scheduler will let you automate many of these tedious tasks in a managed manner. Live migration. Google Cloud's live migration feature allows proactive maintenance of all resources without causing any hindrance in the performance of the virtual machines hosted by the organization. This saves businesses from the headache of dealing with downtimes or outages. Customization. GCP provides a custom machine type feature that lets users create a virtual machine customized to their needs. Custom machine types are priced based on the resources that you use, and in some cases you can even save up to 50% or more compared to other cloud providers. Data privacy and security. Google Cloud Platform has put a significant amount of effort in ensuring data protection and security for their customers. Google has hired a team of professionals called Information Security that constantly work on securing and protecting the data stored in the Google Cloud. Also, Google uses several layers of encryption to protect the data of customers that are using GCP. Flexibility and scalability. Google Cloud Platform is known for the scalable system that it provides, which automatically adds more capacity as the workloads increases. You can specify how much CPU and memory each instance of your application needs, and the flexible environment will provision the necessary infrastructure for you. So these are all the main features that make GCP stand out the most. So moving on, let's now understand what exactly is GCP. So Google Cloud Platform, as you must already know by now, is a cloud platform offered by Google. It offers various cloud computing services such as compute, network, storage and more. But that's not all. There is more to GCP. I bet you all must have used or at least be aware of Google products such as Google Search Engine, YouTube, Gmail, Maps and Hangouts, right? What if I told you that Google uses their own cloud platform to manage and operate these products? I mean, how awesome is it that Google offers the same cloud infrastructure as they use for their own products to its users? We all know how amazing are Google products, right? So imagine how awesome will be the underlying infrastructure. And you'll get to use that same awesome infrastructure if you use GCP services. So here's another huge reason for you to choose GCP. So moving on, let's now understand GCP global infrastructure. Even though GCP is fairly young, they have been able to establish a reliable infrastructure which is growing across the globe at an awe-inspiring rate. Google Network is known worldwide for its speed, reliability, and capacity. Google Cloud is made available in 19 regions, 58 zones, 134 network edge locations, and 200 plus countries. And it will also be soon expanding to places like Japan, Indonesia, and Los Angeles. So now let's talk about the services that GCP offers. These services are categorized into different domains such as compute services, storage services, networking services, machine learning services, big data services, identity and security services, and many more. But the main services that can be used to host any kind of application are compute services, storage services, and networking services. Let's now understand these services individually, starting with compute services. So in compute services, first we have Compute Engine, which is basically an infrastructure as a service offering from Google Cloud Platform. Compute Engine service provides VMs, that is virtual machines, hosted on Google's infrastructure. Now, being an infrastructure as a service, you can think of it as a fresh piece of computer where you'll be given various options for OS, and you'll be given various options for units of CPUs and memory that you want for your virtual machine and everything else. Basically, all the configurations will be at your hands. Next comes App Engine, which is a platform as a service offering from Google Cloud. It's basically used for hosting and deploying your applications on Google Cloud Platform. So if you're using App Engine to deploy your application on Google Cloud, you won't be given any access to the operating system configurations or storage or the installation of the frameworks that you will need to deploy your application, because that will all be managed by Google Cloud itself. All you have to do is upload your application using App Engine and you'll be provided a link where your application will be running. So next comes Kubernetes Engine, which is basically a cluster management and orchestration system for coordinating Docker containers. So if your application is running in different Docker containers and you want to deploy that application on Google Cloud, then all you have to do is migrate those Docker containers using Kubernetes Engine, and you can then deploy your application on Google Cloud. So after compute services, next comes the storage services. So in storage services, first we have cloud storage. Cloud storage is an online file storage web service for storing and accessing data. Cloud storage can be used to store any kind of data. So when you're hosting an application on Google Cloud and you want to store the application data somewhere other than your server itself, then you can use cloud storage, which is also reliable and secure. And also, it's always considered good practice to create distributed architectured applications. So next in storage services, we have Cloud SQL, which is structured query language. Cloud SQL is a fully managed MySQL database service for hosting relational MySQL databases on Google's infrastructure. So if your application deals with only relational or structured data, then Cloud SQL might be the best option for you. Next storage service is Cloud Bigtable. Cloud Bigtable is a fast, fully managed and highly scalable NoSQL database service. Cloud Bigtable is actually used for big data applications like Hadoop. Now after storage domain comes the networking domain. So in networking services, we have VPN, that is Virtual Private Network. VPN provides a private network to create a secure environment for your deployments. So basically, let's say you launched an instance and then you launched another instance and you want both of them to be communicating with each other. Now for that to happen, you'll have to include those two instances inside a network which will provide the instances a secure environment to be communicating with each other. So that's how VPN works. After that, we have Cloud Load Balancing. Cloud Load Balancing is a service that load balances and auto-scales GCP compute resources. So basically, Cloud Load Balancing is a service which will distribute the incoming traffic of your application to multiple servers. Now there are two kinds of load balancing. First one is classic load balancing and the second is application load balancing. Now if you want the traffic to be equally distributed to multiple number of servers, then you will have to use classic load balancing. But if you want the traffic to be distributed on the basis of requests that you're getting on your application, then you'll have to use application load balancing. For example, if the user is requesting for storage upload, you may direct the user to some other server. So in networking services, next we have Cloud CDN, which is Content Delivery Network. Cloud CDN is Google's globally distributed edge points of presence to cache application content close to users. Suppose you hosted an application on Google Cloud in some region, but the user base of your application also exists in some other region. So when they try to access your application, it'll obviously take some time for your application to respond because your application resides in some other region and the user base is in some other region. So what you can do is you can use Cloud CDN to create a copy or a cached version of your application and place it on a server which is in a region closer to your user base. So now when they try to access your application, it won't take as much time as it used to. So that was all about networking services. Now moving on, let's discuss big data services. So in big data services, first we have BigQuery. Query is a fully managed data analysis service that enables businesses to analyze big data. After that we have Cloud Data Flow, which is a fully managed real-time data processing service for batch and streaming big data processing. And then we have Dataproc, a fast, easy to use, managed Spark and Hadoop service for distributed data processing. After big data services, we have identity and security services. So first we have Cloud IAM. Cloud IAM lets administrators authorize who can take actions on specific resources, along with built-in auditing. After that we have Cloud Resource Manager, a service for programmatically managing the resource containers and also used to group and organize GCP resources. Cloud Security Scanner, a web security scanner for common vulnerabilities in App Engine applications. Now let's discuss machine learning services. Cloud Machine Learning. Cloud Machine Learning is a managed service for building machine learning models using TensorFlow framework. Cloud Vision API. Cloud Vision API is used for image recognition and classification, detecting individual objects and faces within the images. Cloud Speech API. Cloud Speech API is used to convert audio to text. This API recognizes over 80 languages and variants. Alright guys, so now let's move on to the hands-on part. Like I said before, we'll perform a practical where we will use various GCP services. So let me quickly brief you about this hands-on. What we'll actually do is that we'll create an application, a PHP application that lets you browse your local machine for an image and lets you upload that selected image onto the Google Cloud storage. We will then also deploy this application onto the Google Cloud. So before we start, let me show you how this application actually works by running it on my local machine. Since it's a PHP application, I'm using XAMPP. So for those of you guys who don't know what XAMPP is an open source cross-platform web server solution which lets you run your PHP scripts on your local machine by providing you a local web server. So to run my PHP application on my local machine, I had to first set up my machine, right? I had to download XAMPP, then I had to install it, and now I can run my PHP applications. So guys, before I run my application, let me quickly show you where all your PHP files should reside if you want to run your PHP application on your local machine using XAMPP. So when you download XAMPP and install it, you'll probably find a folder in your C drive called XAMPP. So in this folder, you'll again find a folder called htdocs where all your PHP files should reside. So my file is index. So to run my PHP application, all I have to do is type in localhost on my browser /index.php, my PHP file name. And when I press enter, here's my application. So as you can see, there are two options here, choose and upload. So let me click on choose to browse and select an image from my machine. Here I have an image called GCP tutorial. I'll select this image, open, and as you can see, the image has been selected, GCP tutorial.png. So before I click on upload image, let me also show you my cloud storage bucket so that you know it's empty, and after I click on upload image, the image will be uploaded. So here I go to my bucket. I've created this bucket for my application. So right now you can see it's empty, right? So going back to the application, if I click on upload image, it says the image has been uploaded to your bucket successfully. So let's go back to our bucket and confirm if that's true. See here, if I press on refresh bucket, here you can see the image has been uploaded. Okay guys, so now you know how the application works, right? So now let me tell you what are all the components that you will need to run your app. So first of all, you will need an App Engine instance to deploy your application on the Google Cloud. After that, you will need cloud storage bucket where you will be uploading all your images from your application. After that, you will need something called Cloud SDK. I'll tell you what it is and why do we need it once we get there. After that, there's something called service account key that you will also need. And then there is Composer. Again, I'll let you know what it is and why do we need it once we get there. So guys, these are all the components that you need to deploy your application on cloud. But what about creating our application? What are the things that you need to create your application? Well, first of all, of course, a PHP code file which you will run as an application, and then there is app.yaml file, which is a configuration file that you will need for your PHP code file. Okay, so now let's get started with our demo. For that, you'll have to go to your Google Cloud Console. In GCP, everything you do that includes any service you use, any resource you run, any application you deploy, absolutely anything that you do is counted as project. So basically, if you want to perform any activity, you'll first have to create a project where you can associate that activity to that project, or you can just select any of the previously existing projects. So guys, if you want to create a new project, then all you have to do is go to this tab that currently says hello. That is because the project that I've selected or the project that I'm currently using is named as hello. So when you click on this tab, you will be able to see the list of all the projects that you have previously created. For creating new project, you just have to create a new project, and then you can name your project anything you want, and then after that you can just click on create. Also, here as you can see that every project has something called ID. So when you create a project, GCP will auto-generate a unique ID for all of your projects. So once you have created a project for your application, make sure that the name is reflected over here, because that means that the project that you just created is currently selected and you're going to work under that project. So after creating the project, the next thing that you have to do is create your first App Engine instance. Now you need App Engine instance to run or deploy your application on the cloud. As you guys saw, when I was running my application on my local machine, I had to first set up my local machine to run my PHP application, right? I had to first download XAMPP and install it, and then I had to make sure that all my PHP files reside in that particular folder. So basically, I had to set up my environment for running my application. But when you're deploying your application on App Engine, you don't have to worry about any of that, because App Engine, as I've already mentioned in this video before, is a platform as a service offered by Google. So all the necessary infrastructure and the environment setup will be provided to you, and you can just directly deploy your application and run it. Now, to create an App Engine instance, there are actually two ways of doing that. First, you can directly create an App Engine instance using this console, or second, you can use something called Cloud SDK. Now, Cloud SDK is a set of tools for cloud platform, which also includes command line tools. So basically, you'll be able to access and use any of the services provided by GCP using a command line tool. Also, Cloud SDK is what you need to deploy your code files onto the cloud. So in this hands-on, we'll be using Cloud SDK. To use Cloud SDK, we'll first have to download it. So let me show you how you can download Cloud SDK. You just have to click here and you see downloads here, right? This option is basically the home for all the tools that you may need to use with any of the GCP services. So if you want to download any tool, you can just click here and you'll get a list of all the tools and you can download any one of those. So let's click here. So here, as you can see, this is the list that I was talking about. You can download any of these tools whenever you need them. So right now we need Cloud SDK. So let's click on that. So now we are directed to the Cloud SDK documentation. So I'm using Windows, so I'll just keep it this way only. But if you're using some other OS like Linux or Ubuntu or any of these, then you can select those. And after that, you just have to click on this Cloud SDK installer. Once you click on this, the Cloud SDK installer will be downloaded to your machine. So all you have to do after that is run this exe file and the Cloud SDK will be installed on your system. So after you have successfully installed Cloud SDK onto your system, you'll probably find a shortcut to your Cloud SDK shell sitting on your desktop like this. So now we have Cloud SDK, which we'll be using to deploy our application code files onto the cloud, and we'll also use Cloud SDK to launch App Engine instance where we will deploy our application. So now one of the remaining components that we need for this hands-on is Cloud Storage Bucket. So let's move on and create a Cloud Storage Bucket. To do that, we'll go to our console. Here, if you see on your left side, there's a list of all the services offered by GCP. So we'll navigate to storage and then there it is, we'll go to browser. So here you can see a list of all the buckets that I've already created, and on the top of the list there's the bucket that I was using for uploading the images from my application onto the cloud. So since you have to create the bucket from scratch, let me show you how you can do that. You just have to click here on this option called Create Bucket, and then you'll have to provide a name for your bucket, which by the way should be unique globally. So let me try. So as you can see, if you're trying to use a bucket name that is already in use, then GCP will inform you like this. So let me try some other name. Alright, so I guess I found a name. So next we have default storage class. So here we have 4 different options. Multi-regional and regional storage classes are based upon regions, whereas nearline and core-line storage classes are based upon the usage of your bucket. Multi-regional is to be used with a bucket that is going to be accessed frequently from multiple regions, whereas regional should be used with a bucket that is only going to be accessed from a particular region. Nearline should be used with a bucket where the data of the bucket is going to be accessed once per month, whereas core line should be used with a bucket where the data of the bucket is going to be accessed very rarely, that is once per year. So here for this hands-on, I'll use multi-regional storage class for my bucket, and then I also have to specify that my bucket is to be accessed from multiple regions in Asia. Alright. You can further also compare storage classes on the basis of the cost, but then you don't have to worry about that if you are in your free trial period. So moving on, we'll just click on create. And there you go, your bucket has been successfully created. So now we have Cloud SDK. We'll be launching App Engine instance using Cloud SDK. We also have a storage bucket. Let's now look into service account key. Service account keys are used to authenticate machines such as compute engine instances or app engine instances to use other cloud services. Like in this hands-on, we are using service account key to authenticate our app engine instance to use our storage bucket that we just created. So let me quickly show you how to create a service account key. All you have to do is go to APIs and services and then on credentials. After that, you just have to click on create and then select service account key. Here you have to choose new service account and then give a name to your service account such as select the role as project and then owner, and then make sure the key type of your service account key is JSON. After that, you just have to click on create and the service account key will be downloaded and saved on your system in JSON format. So here you go. Now make sure you keep this file safe because we are going to need this. Now we also have service account key. So what's remaining is Composer. So let's get to it. Composer is basically a package manager that deals and handles with all the packages and libraries that you may need to include in your PHP code file. So when you download Composer, all the necessary packages and libraries that you may need to use with your PHP code file will also get downloaded in a folder named vendor. So let's download our Composer. I'll mention the link to download the Composer in the description below. So once you're directed to this page, just click on download and then click on composer setup.exe, which will download the installer for you. After the composer setup is downloaded, you can just run this exe file and the installer, as mentioned here, will download composer for you and set up the path environment variable, so you can simply call composer from any directory. After the composer is downloaded and installed successfully on a machine, like I said before, a folder named vendor will also be created containing all the necessary packages and libraries for your PHP file. So moving on, let's look into our application code files. So this is the folder where I've kept all of my application code files. As you can see that I also have a JSON file here. This JSON file is the same service account key that we just created and downloaded to my system. So let me open my PHP application code file and show you my code. So here's my PHP application. First of all, let's just get over with the front end of our application. Here's a regular HTML code where I have included a form for the front end of my application. And here's the whole PHP code for all of the backend work that my application is doing. You can find a similar PHP code on Google Cloud documentation also. So I'll just tell you all of the things that you will have to include in that code on your own. So first of all, I have included a file called autoload.php, which is basically a library which resides in the folder named vendor, which was downloaded when I installed Composer on my system, under which I am running my application. So for this field, you'll have to include the project ID of your own project that you created in the very beginning of this hands-on. After that, I have included these 3 lines of code where I have provided the name of my JSON file which was downloaded to my system when I created my service account key. So you'll also have to include your service account key in this field. After that, here in this field where I have actually created a variable called bucket, I have included the bucket name that I am using to upload my images from the application that I have created. So in this field, you'll have to provide the cloud storage bucket name for your bucket. This is the basic PHP code for uploading images from an application. After that, I have included these 2 code lines where basically I'm uploading the selected image to the bucket. Here I've used the variable named bucket, which I created when I was including my bucket name. After that, I'm simply displaying a message that the image has been uploaded to your bucket successfully. So that was all in my PHP code file. Now let's look into app.yaml file. So app.yaml file is basically a configuration file that tells App Engine how our application is going to behave. Let's go line by line to understand this app.yaml file that I have. So the first field that we have here is runtime. Runtime tells what kind of script I'm going to use to deploy my application on App Engine. So if you're using a Python script, then you'll have to mention Python here instead of PHP. After that, we have API version. API version specifies the version of runtime environment that the App Engine is going to use to deploy your application. Specifying the value 1 here tells the App Engine to use the latest supported runtime environment. And then next we have handlers. Handlers section defines which requests are going to be processed by which script. So for this hands-on, the application that I am using contains only 1 script, right? But what if I had 2 different scripts? Let's assume that I had 2 scripts named image.php for uploading images into the bucket, and then the next script named file.php for uploading text files into the bucket. In that case, I would have mentioned in the handlers that for the kind of request where the user wants to upload an image into the bucket, my image.php script should be processed, and for the kind of request where the user wants to upload a text file into the bucket, my file.php script should be processed. But right now we don't have to worry about that because I only have 1 script, that is index.php. So that was all about the app.yaml file. Going back to the PHP file, once you're done including all the necessary files like service account key and your bucket name, your application will be able to upload images in your storage bucket. You can test it by running it on your local machine using XAMPP like I did in the very beginning of this hands-on. Once your application is up and running, you'll be ready to upload your application onto the cloud. Moving on, let me show you how to do that. So the very first thing that you need to do is start your Cloud SDK shell. So let me do that here. So before we can start using our Cloud SDK shell, let me first tell you that you'll have to append the path of your Cloud SDK in your environment variable. Repeat, once you've done that, you can start using your Cloud SDK shell. So now what we need to do is, we need to run the command gcloud init. So now since I've already logged in using my account and I have already selected my project, I don't have to create a new configuration. I can just reinitialize this configuration with new settings. So let me pick my numeric choice as 1. So I would like to choose my account only. Alright. So again, I will use the first project because that is the project under which I'm going to run my application. Alright, do you want to configure a default compute? Okay, yes. I'll choose Asia South. So now we are ready to deploy our application onto the cloud. But to do that, we'll also have to deploy our application codes onto the cloud, right? So to do that, I'll just have to move to the directory where all my application codes reside. So let me first do that. I'm moving to the project directory where all my application codes are. So we can also view all of the files and directories residing inside the project directory with this command. And so now you can deploy your application codes using this command, deploy. Do you want to continue? Yes. So it says file upload is done. Alright, so now my code files are deployed onto the cloud. So to run my application on App Engine, all I have to do is copy this from here and I'll paste this link on my browser, and here you go. Now my application is actually running on App Engine. Let's see if it's still working or not. Again, I'll choose this image and I'll click on upload image, and then I'll go back to my bucket to see if the image has been uploaded or not. So again, the image has been uploaded. So guys, that would be all for this hands-on. Let's now move on and take a quick walkthrough of the whole session. So the first topic that we discussed was cloud computing. We learned what is cloud computing, and then we looked into the categories of cloud computing and various cloud providers. Then we learned why one must opt for GCP. We learned out of all the cloud providers what makes GCP stand out. Then we learned what is GCP. We also had a look at some Google products. After that, we learned about various GCP services, and then we learned how to use GCP services by performing a hands-on. So basically, we covered all the major fundamentals of GCP and we also performed a hands-on.
So coming to the first question on the top cloud computing interview questions and answer set, we have a question that states compare between cloud and on-premise computing. Well, whenever we go on to compare cloud and on-premise computing, you really have to talk about 5 very important points. And the first thing is, of course, it's always going to be initial cost, because so whenever you're talking about a cloud computing environment, your initial cost to set up the